Oh god, I just realized I've been recording the first 25 minutes without mic.
LeMayo!
LeMayo! Oops.
Oh well.
Oh well, whatever. So, hello everybody,
Bit of dinner.
welcome. We're gonna do the assignments first, then the things. I recorded the first 25 minutes without mic. That's my bad.
Why
You're
does
getting further
answer
conversations
string...
from other people's talking.
No. They couldn't hear
Professionalism.
anything. I didn't record either my mic or my thing. So it was just silent.
The
It's
assignment
silenced by the
they
university.
say the amount, so you have to run the answer.
Hmm?
The answer assignment thing doesn't show the amount. It just shows the query.
Does it only show a query?
The first one is correct. The first one is correct. 46,346.
Hey, let's go. All right. Solve application 5 with a subquery. List the title names,
Aye.
including a character named Chewbacca, except those produced in 2005. For example, Star Wars at the big
British Broadcasting Service.
Oh yeah, that thing, that one.
British.
That's not even the acronym. It's British Broadcasting
British.
Community.
British.
British.
My boyfriend's brother actually works at the BBC. Interesting place.
Oof. List the title names. So we want the title, right? So select title from title 100k title. It's a lot of title. Except those produced. Oh yeah, okay. So where product. you guys want to see a big brain play?
BVP.
Yeah. Big brain moment.
Yeah.
Yeah.
Title.id is equal
Yeah.
not in.
Where title.id in select star from numbers where number kleiner dan 2015. Oh god.
No.
Just make a table called numbers.
No. This is fine. All right. So let's see. So
Yes, the famous movies that were produced in 1 AD.
oh, you're right. We're not thinking about negative numbers. I think we're onto something, guys.
Can you not just say that the number has to be that thing has to be smaller than 2015?
Well, yeah, you can, but that's what we're doing here. Where titled. We're just fucking around. This is like a really easy question. Don't worry. Equal to 2000. Oh wait, except those that were produced before. So before 2015. So we want all titles except the ones that were produced before 2015.
And you need to use set.
Hmm?
In Chewbacca.
No, this is like solve query 5 with a subquery.
Oh.
And we also want to know, including a character named Chewbacca. So I can add the character named Chewbacca both here and here. It will drastically speed up the query, but I cannot be asked, so I'm only going to do it here. Join, and it is about the character named Chewbacca, so we join with cast info and character name. Cast info 100k. Cast info on cast info dot movie id equals title dot id. Join character name 100k on our share name on car name dot id is equal to cast info dot person role id. So then we want this thing, and also where car name dot name is not equal to Chewbacca. I'm not sure if I wrote that right because I haven't seen the Star Wars movies. Probably someone who's going to be very upset at me with that. Oh, including. So it is this one, and single quotes. Ugh, this language, man, I swear to God. Okay, so we want the title. From the title list, join on by cast info, join by character names, where the title ID is not in the list of all movies before 2015, and one of the characters included in it is Chewbacca.
Should bring out a lot of movies.
Boba Fett lives and Star Wars at the BBC.
Wait, Wolf had live spoilers.
Whoa, 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 whoa! Spoilers. Wait. Okay, you're good again, guys. You can watch again.
Great, now I have to like spoiler tag the whole video.
All right. Is there anyone like specifically wants to do? Because I think like we understand making queries now.
Well, there was you said stars to BBC, but it was an example of what should not be there, right?
Was
It
it?
wasn't an example. E.g. stars to BBC. Should that not be included?
No, I think that's an example for what should be in what you get, not what shouldn't be.
Okay.
Yeah, because like here they say E.g. actor Neo, and that was also in the. Yeah, I do understand this is quite an ambiguous thing, and I would also
Yeah,
freak
because
out during a
it says
test, but I think
accept.
that's correct.
Have we
Okay.
used all the subquery statements? Have we used with, exists, and in?
We have used exist and in, but we haven't used the with. But with is just making a subquery and declaring it outside. Right?
Yeah, indeed.
It's just where with a subquery.
Yeah, exactly. It's where with a
They
subquery, but
also-
then fancy.
They also did not use with in their example thing. So
Okay, so I don't need with.
No.
Yeah, with is just a fancy. It's just sparkling. Where?
So it's like a join is a fancy union or is a union select both where one equals other.
Controversial.
Technically,
Oh,
Actually, for a join statement, you could just write as many unions as there are columns, and
Oh no. For a join, I like to use a Cartesian product and then select later from there.
actually for join, I'd like to type it out myself.
I like to go just manually through all the tables and compare them myself.
Yeah, actually, I exported the PostgreSQL database into an Excel spreadsheet, and then we're using that now.
Yeah. So we're using CSV files now.
Comma separated values. I will cry. I actually used comma separated values for Minecraft sheet finding just now, like yesterday. All right. Is there anything else? I think we've had it all, right? Application programming. Fuck off. Okay. Lab assignment numero dos.
Yes. Wait, Jurre, don't we need to interface with a database through Python for the first one?
I'm gonna knock your teeth out.
Cool.
Cool, Paul.
yay!
They're not gonna do it during a test.
Relax. Okay, I'm gonna close this one because I don't need it. I'm gonna open this gist. I remember fucking around with this shit for a long time. We did do this one. Yeah, we did do this one. All right. So let's see. These are the or actually, if I make this one big, yeah, you can see it here on the side. So I think the best move here, the play, is just doing it like this because then you can also see everything here.
Yes.
I don't need this one anymore.
Yeet.
Oh, relational algebra! I swear I'm gonna throw myself off a fucking bridge.
I mean, honestly,
It's
if you format it,
SQL with way worse syntax.
once you format it a little bit, it is pretty alright, I think.
It's doable, but barely.
List the names of all employees who have a dependent with the first name as themselves. Okay, so we want to let's see, let's start out because we want to join the employee with their dependent. So let's say I love how this is just a valid query. Department, 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 department dname. So let's see,
Department.
we say dependent, and then we do a natural join on. Actually, can I say dependent rename it? So what's the rename thing again? This one, rename dep, and then we natural join that with rename employee. I love how I'm using like 5 different coding conventions.
Isn't it the only way to do it?
Wait, are we? Oh, we only have 7 employees. Bulk. And then we join it on dep.
What is this, a startup?
Hmm?
What is this, a startup?
Yeah, we should do it where we work, Yellow. That's gonna be a long table. So we want to join it on the department dot, or the dependent, not department, dot ESSN is equal to emp.ssn. I love how they actually do like the checking during the thing. Could not find emp. Did I just not click? I didn't click the thing, guys.
Right.
Okay, so now we have this thing, which is just the join of these two. And then we want to, from that, select everything where, for where dep dot dependent name is equal to emp dot, and it is first name, I think. Yeah, it's first name, so f name. Could not find. Oh, so let's see. I might have to put another set of brackets around this one. It's our boy Franklin with a son called Franklin. Holy shit, guys!
I
And we-
dacht het son.
Franklin!
It's Franklin Franklin. Holy shit, meneer Franklin.
It's the turtle!
Oh god.
Oh, why is it complaining? Oh, I space? No, fuck. Could not find emp. Oh, fnum. Why is it complaining? Franklin. List the names of all employees who have a dependent with the same first name as themselves. Actually, they want the name, so I guess I should say emp.l name.
Oh,
So here's the full name of the one employee who has the same thing as their son. The same name as their dependent. I think this makes sense. If the same person, does he still have the answer sheet open for this one as well? I guess that's a no. Does anyone want to have the answer sheet open and look at the answers so we can make sure that we're actually doing stuff correctly?
That silence, oh my god.
Yeah.
Yeah, it's Franklin 1.
Awesome. Can you keep the
Sorry, I was muted.
Queen Quay? Can you keep it open so you can check?
Yeah, sure.
So I have the. I'm sorry for being muted. I think there were 2 names. Like Franklin Wong was correct. The first question is correct.
Okay, cool. Find the names of all employees who are directly supervised by James Borg. I thought it said James Bong. Bong. So let's see. Oh yeah, so that's realistically a self join because we have the super SSN thing. Or we can also do a subquery.
Yeah.
Let's do that. So employee. Then we can say we can make it subquery real quick. We can say employee. From that we want only the one where s name or f name is equal to supervised by James Borg is equal to James, and L name is equal to Borg. Now it's gonna complain. Oh, Pog. Why can't I? So let's see. This is the selection tool. Yes, I'm not dumb. So I want to select this stuff. Nope, doesn't work either. Oh,
Also
maybe my
put
logical
employee
and is
between
wrong.
I think the
brackets.
bracket should be around the employee.
Let me check with this first. Yeah, I used my logical and. It should be their logical and, which totally
Of
makes
course.
sense.
Jure, just use A and D. Holy hell.
Is that, no, that's not allowed, is it?
It's allowed. Just display. Yeah, and
What
HT
the
query.
fuck? No. I
Natural language in my computer language is more likely than you think.
Yeah, okay, I'm used to Python, where you can just speak and it will just be pseudocode and it will work, but... Okay, so we want to select from this, the SSN. So let's see, does this thing have an in operator? Oh, well, actually, we don't have to use in, we can just use equal. Right, so here's the SSN, so now we can say... employee. What do we want to do with employee? We want to select from there where let me actually rename this to emp1. So I want to select where emp1 is equal dot e or actually super ssn is equal to. And why is this not allowed?
Well, because so far you're just saying. I don't think you guys use subqueries like that. I think you have to join the outer two queries or outer two tables. I don't know. I've never used subqueries in relational algebra. I didn't even think they were allowed.
Yeah, but when I select this execution, this is just the ssn. So this should be the same as just having the number there. Because if I do like 1, 2, 3, 4, that's not allowed either. Oh well, yeah, fuck off. So it's the number 1, 2, 3, 4. Why is that allowed? What do you mean?
You're gonna need to like.
Yeah, okay,
know.
I see. So what we can do is we can
Cross join yeet.
we can cross join it with this, and rename first of all rename this thing to SSN.
Yeah, and then ESSN. Yeah, this should work.
Um,
There's probably a bracket.
yeah. So we want.
Oh wait, ESSN dot SSN.
Oh yeah, that makes sense actually, because ESSN is now just the relation, but we want but we want .ssn from that, and it's SSN with a capital S.
I was about to say it's gonna be capital. I think this sounds better. It's not optimally optimized, but
I might have to put brackets around this, but it's not actually in there though.
ESSN dot SSN.
Oh wait, I might have to put brackets around all this stuff too. Yeah, these are two of the same super FSN. And what do we want? What do we want to know from them? Find the names of all employees. So then we just want to say, okay, grab emp1.f name, emp1.l name.
I think relational algebra is like a lot easier to understand. It's just that writing it is a bitch.
It's just take a query but make it Greek.
Can you scroll down? Yeah, that's it.
Thanks. So, and again, because like right now, what we're doing is instead of making a subquery, we are like making a table consisting out of one row, joining that to the employee table. So the employee table, all it does is fancily, it adds one row to the employee table. Because as you can see here, employee is just the normal employee things, and here you can see it has the employee things and ESSN.SSN. And then we're filtering it, selecting it.
Yeah. I completely forgot what I want to say.
We could probably optimize something like this as well by.
The reason that you have to do this as well is because if you look at the selection thing, it just works on a table. It's just select this from table. That's all you can do.
fair.
So subqueries can't work.
Oh, it's M1. And here, by first only taking these three things, we are making it a lot faster. Woo! Okay, so yeah, that's my query optimization.
It's Franklin.
checking out,
It's
guys.
Franklin again.
Yeah, it's
Same
motherfucking
guy.
Franklin Wong. He's here again. Wow. All right. Retrieve the names of all employees who work on every project.
God.
Interesting. So let's see. We definitely want to use the P-no. Let's see. Is there a way for us to... is there a counting within relational algebra?
Aggregation is there.
Hmm?
I guess there is something to count.
Just hover over everything and check what it says.
Gamma. You
Yeah.
can use gamma.
Gamma?
Yes. indeed.
Gamma. Yeah, gamma is count. It just said.
The seventh character.
Oh yeah,
Yeah.
here. Oh yeah, I remember this syntax. Yeah. Yeah, because this is what you do with group by, so
Indeed.
I guess that makes sense. So we want to first take the works on. Because what this will do is we're going to work with the works on table, then we're going to work with like the P&Os, and once we have the SSNs which work on every P&O, then we can just join that with employee. It's a lot of projects. Okay, so we can say works on, and then we can group by. Let's see. So we want to group by, or actually I probably have to do that to the left of it. So we want to group by works on dot ESSN. And we want to have a count function. So we want to have count works on dot P&O as total project. Okay, so here we have all the ESSNs together with their list total projects. And this in normal SQL, this would be the same as saying select count P&O from works on group by ESSN. So that's what we have here. And we want to have this so that total project is equal to the total amount of projects. So then we can first make another query, namely project, and then we want to say group by nothing count p number as. Let me actually change this. I'm gonna say this to total projects per employee, and this is total project. Total project. Okay, so here this is like total project, which is the let's see. So this is like the final. Yeah, how do you say that? Like the total amount of projects. Let's say it like that. Then because I want to do it as a subquery, but subqueries don't work in relational algebra, so I'm gonna do a full join, a cross join. That's what I called. So here we can see all the ESSNs, the total projects per employee, and the total projects. Then here we can filter this on total projects per employee is equal to total project. Could not find. Oh yeah. So again, more brackets. When in doubt, always add more brackets. And then what we
It's
want
a
to have.
shuddering in fear.
Yeah, what we do then is yep.
What's the symbol to close all brackets again?
Oh yeah, that's just like as many brackets as you want, and then they know you mean like, hey, this is all the brackets closed. Retrieve the name, and we want the names of that as well again. So then we have to join this with employee on. Oh, it's full caps, of course. Of course, it's full caps. And we want to join this on employee.ssn is equal to works on dot ESSN. Man just goes to the right. Where? Can I not even see that? Oh wait. Oh fuck. No, that. I don't think I can see it. Oh, there we go. Hey.
Dark Relax shows the forbidden branch.
The forbidden branch. And then let me zoom back in again, and we want to we want from this to grab employee dot f name, employee dot l name, and again more brackets. So the Franklin, you
What
bloody
is
ass motherfucker!
Maybe it's the son, Franklin.
I doubt the
Maybe
dependent will be in
all 7
the
employees are
the
called
table as well.
Franklin, and we just hadn't realized.
He just swapped it.
Wait, it's all Franklin. Always has been.
Yeah, indeed, it's Franklin again. Franklin doing everything.
What's this guy up to?
No, you guys don't understand. This guy is pulling his fucking weight, man. All right.
He's getting that dough.
And now we can retrieve names of all employees who do not work on any project. The fucking
that's
slack.
not Franklin.
Franklin won again.
Well, I mean, we can probably assume Franklin's son, also Franklin, does not work on any project. So you get what I'm saying, boys.
Schrodinger's Franklin.
Yeah. Okay, so the thing now is, we can't just do this, right? Because when we want to grab stuff from works on, the issue with that is works on will not have it. So we want to find employees who are within employee but not in works on. Let's have a look how we're gonna do that. So let's see.
What about...
Wait, I know. We can use the
what
subtraction.
about the division?
So we can say employee, then from that we select the SSN, and then we subtract from that works on select ESSN. This punk ass motherfucker.
Can we get the name? Can we get the name?
Yeah, we're gonna get the name. We're gonna slander this guy.
It's
So-
Franklin. No.
No. So
It's
first, let's make
Franklin,
this into a
Franklin.
neat little package with some brackets, and then we will natural join that on SSN is equal to SSN with employee. I don't. Yeah, that's what I thought. Result.
SSN, ain't that the ship from Pokemon?
No, that's the SS. The SSNE. Nice. So we rename this to emp2 or emp2, so we can say emp2.ssn. And then from this whole thing, more brackets by the way, don't worry guys, already putting them down. We can select emp2.fname m2.l name James Borg, the supervising son of a bitch.
The guy who supervises the guy who works on every project works on no project.
Son of a bitch.
This is James Borg. It's the supervisor guy. I'm onto him.
Yeah.
I mean, I guess it makes sense. He's not working on the project and he's supervising, but
Okay, what we know so far, this is probably like a startup with the number of like only 7 employees. And like there's like the one employee who's like pulling everyone's weight, but like a supervisor doesn't do anything. What's the story of this company?
no. I work in a startup. This is totally real. All right. Let's
Wait,
move on.
Franklin Wong has been here all along.
Yeah, and James Borg is fucking Seward, motherfucker. Whoa, hold up.
Name calling. Chill.
Okay. Refine the average salary of all the... Okay, to be fair, sex is a string, not a boolean. I can respect that.
But it's only M or F. But you know, that could also be because
Do you have sex?
Sex.
Yes or no?
that could just be because this company only has has
Yeah,
employees who are
doesn't
male or
have any
female.
employees. Like, you know,
Yeah.
They don't have any employee that.
You're not forced to take on MB employees. You're just forced to not discriminate against them.
exactly based. Like, as long as the option is there. You can't just say in your thing, yeah, it's the varchar one, only M or F as a constraint.
Well, yeah, okay. A varchar one is possible. You just got NB's ends.
Yeah, or X's.
Yeah.
That's like how they
Yeah.
do it in Passport.
And for a database, like one of the things like that were supposed to show us like how to do relational modeling was like again with a company like sex, and they wrote like would be actually more accurate to use gender, and they were like we don't make the graphs, like just change it. It's like I don't think a company has like records of like the sex of their employees. Like it doesn't even
Yes,
say.
hello,
True.
welcome to
Government.
company. Yes, welcome to company XYZ. Before you can take part, unfortunately, we're gonna have to see your dick.
Yeah.
It's part of the-
Please submit a complete genetic sample.
It's part of the pre-employment screening, man. We have to see your dick. I don't make the rule. Okay. The average salary of all male employees. So we first want to. Ooh, what do we want to group? Oh, I've got this. We group by sex.
Yes.
Why do all male employees on average make about 12% more?
Isn't that just called
What a
an orgy?
coincidence!
What a coincidence. Okay, so we want to.
Franklin is a guy. So, you know.
Okay, guys, real quick. So we want to have sex. That's the joke.
This is so
Yo,
getting fucking.
Everyone come here, they're handing out free sex.
Fuck.
This is so blacklisted on YouTube.
Yeah,
Like,
I'm not putting
That's
that
why
publicly.
it's unlisted.
Demonetized.
It's not like doing it.
Demonetized.
Demonetized.
Demonetize it.
No.
COVID. Now we're actually demonetized, pork.
Guys, please, nobody say the N-word on YouTube.
Okay, no, seriously, don't.
No,
do
don't
that.
actually do that. I will ban you.
No, hold on, no.
Mrs. Obama, get down. Execute the query. Okay. No, wait, they actually made it accurate. No.
It's all James's fault. Because he's a supervisor, I think James has higher salary. It's all James's fault. James is like the one supervisor.
Wait. Guys, I've got this.
70%?
Can we group? Wait, I've got this. So, we take employee, but then we select out. Name is not equal to.
James Bond.
James.
What's the number for women again?
He changes it so much!
Yeah.
It's almost
It's
equal!
all James' fault.
James, you motherfucker!
You sit on your ass, do nothing, and get paid 50,000 a month.
What?
Okay, real quick.
Which company?
Employee. Select, F name is James.
What's Jason's salary?
55.
Let's go
Unfair. Unfair. Boycott.
James,
Guys,
Boycott, James.
guys,
like
just say,
James is like my.
guys.
What about Franklin? I want to know Franklin. Is
Oh,
this guy
oh,
paid
Franklin.
enough?
Yeah, this guy makes a point. Franklin.
Yeah.
Guys. Okay, real quick.
Okay.
I think it's time to unionize.
Yeah.
I think I think this company should be turned into a communistic society.
Dude, I wish.
Yeah.
Everyone gets the same.
Oh.
Shut co-op.
Okay, let's actually go to the assignment. That might be.
Yeah.
Yeah, that's it.
So we want the average salary where sex is male from everything grouped by the average grouped by sex. Dude, I can't wait to get like this
Group by
off.
sex. Yes. No.
I can't wait to have this like to have somebody go to this recording, then cut out, and then just say, just take one of those like one of my sentences saying, yeah, so we have sex, and then just turn into like a meme like. Yeah.
Can't you just already select before you do a group by?
Oh yeah, I could. Like I could say employee select.
Would be even more efficient, I guess.
Efficiency. Yeah, probably. I mean, but then we.
Yeah, because.
But then we don't even have to group by sex, right?
No, then you can remove sex.
Yeah.
And then you can remove sex.
We don't have sexes no more.
Sex is no more. Only gender. An ideal society.
Yeah.
Penises are now outlawed. Cyberpunk 3077.
Yeah.
Alright, so we have the average salary. Can somebody tell me if this is correct?
Abstinence only
Hey,
people
hold on.
everywhere rejoice.
Scroll down.
Oh yeah, it's 37,000.
Yeah.
Wait.
That's correct.
Yeah, that's correct. That's correct.
Ah, okay, cool. But wait,
And then
that
it goes
means
down
that
to 40.
Franklin still makes more than the average male.
Yeah.
Wow. Okay.
But he also carries this company. So
I was about
like,
to say, good on you, Franklin. You deserve a raise.
the problem
Wait.
with James is that like he doesn't do anything.
Exactly.
He's a
Wait.
supervisor, yeah, but a supervisor of what?
Wait.
I
Wait.
mean, if
Actually.
If Franklin
Update.
earned so much, then some of them earned like 20k to make it that average.
Employee.
Yeah.
Set.
Or maybe
Yeah.
maybe there's one that's just not paid. You know.
Oh, someone has.
It's a startup. It's not necessarily like they have the money anyway.
Yeah.
What's the what's the manager name again?
James Borg. Single. Yeah.
We can't do updates. Wait, what am I doing here? Oh, damn it.
Go to the SQL page. You can have SQL editor.
Yeah,
We'll
but like here, if I do update, it's not allowed. I can only do select.
Guess we'll just have to eat the rich.
Yeah, update.
But let's continue. We don't have all day.
Wait, modify current dataset. Let's go.
Okay, let's see
Okay,
who
wait,
gets
James-
paid like.
Where is he? James Bohr.
Ahmad Jabbar, Joyce, English,
where is he?
and
Franklin Wong. Yeah. Okay, we're good.
okay, Alicia.
Don't worry,
Maya,
guys,
and
we're good
Hammond,
again.
How to fix society
okay, the
issues?
thing is,
Just added a
I
table.
think there might be some races involved. Alicia Zelaya and Ahmed Jabbar, all both don't earn much. Like both
You're right.
earn 30k, and then Joyce English is okay. They're all from Texas. Never mind.
Yeah. Okay. And to be fair, Franklin Wong doesn't sound like an entirely.
Yeah.
Yeah. So and
Does-
he makes 100 million. So.
It's the whole model minority thing.
All right. Let's have a look at storage. I'm done with relational algebra. I don't want to. I don't want to get into classism. Well, actually, I do want to get into classism, but let's keep the stream politically.
Monetizable.
Yeah, monetizable. That's the right word. Okay. Consider a disk with the following characteristics. It has a block size of 512 bytes, an inter-block gap of 128 bytes. The number of blocks per track is 20, and the number of tracks per surface is 400. A disk contains 15 double-sided discs. A disk pack, thank you.
Also, Jure, it's no problem getting political because all the conservatives don't go to university anyways.
And if they do, we're going to tell them anarcho-communists, not anarcho-capitalists. Fuck them.
I am very glad that this is private. I'm sure there are a few of my employees who would not want me having going out saying stuff like this, but hell yeah, based. What is the total capacity of a track, and what is its useful capacity excluding interblock gaps? So we want to have the number of blocks per track, 128, times the block size, 512. But we also have the interblock gaps. So the total capacity is...
Isn't the number of block 20 instead of 128? Shouldn't it be 20?
Oh yeah, okay. Number of blocks per... I looked at it like...
Yeah, I was like
120...
confused for a second.
Yeah, okay. Excuse me. And now the question is the interblock gap like contained within the block size? No, right?
No, it's not.
Okay, that makes a lot of sense because it's interblock, so it's not within the block. So this is the amount of total capacity of a track is 20 times this plus 128, but the amount of useful capacity without the interblock gaps is this. All right, everybody agree? First of all, am I right?
Just one more.
Yes.
Yeah. One question. So,
Yep.
The interblock gap. Why is there an interblock gap after the last block?
It's circular.
Also, that basically accounts for the other tracks.
Hmm?
That
No, it's
basically accounts
like a circle. So it's like block gap, block gap, block gap, block gap.
that's
There is no start, there is no end.
Yeah. Okay.
And I'm really glad it's that way because if it wasn't, I would totally forget that.
Oh yeah, of a track, not of the block of the pack.
Yep. How
Oh,
many
you must-
cylinders are there? So the number of tracks per surface is 400, and a disc pack contains 15 double-sided discs. Well, I mean, as far as I know, right? So if we have, again, I did not pay attention during this lecture whatsoever.
I didn't pay attention during any lecture.
No one does.
Did anyone pay attention
Yeah.
to any lecture?
Yeah, I think this is not I,
you
but
like-
we.
Does somebody know how many people were there at the end of the last lecture? Because I think it's less than 150 or something.
Yeah,
I think it's 130-ish. I was like,
I think 120 something.
because I just joined in the Zoom and they like give a peek and it's like, nah, I'm just gonna quit.
He like
I forgot
starts
about
doing
that.
he like starts doing a tangent. He starts to zone out, and when you zone back in, he's in another tangent. Like you don't know if he went on topic in between or something, but he's still on a tangent.
Yeah.
Yeah.
Either way, so this is one of the discs, and you will have many of these stacked on top of each other. So then, each one of these discs will have 20 tracks per surface, and a track is like these circles, like from the disc. So let me see if I can make a few of those.
Wasn't it 400 tracks per surface?
Yeah, I'm not gonna draw 400. just to be clear, getting it out there, right?
I also don't think you're gonna draw 20.
Actually, I don't think I'm gonna draw like more than 5. So here we have the totally accurate number of tracks per circle, per surface.
I think you should.
One line represents 100 tracks.
Based, yeah, done. So then a cylinder is one of these tracks, but then across all of the 30 surfaces. So how many cylinders are there? Well, since there are 400, 400, is that correct? Yeah, 400 tracks per surface, and it does like a cylinder consists out of one track across all surfaces. That's just 400, right?
I think so.
Yeah.
I love how I ask people to have like the answer sheet open, and I'm hearing it. Like, yes.
No, it says number of.
I mean that sounds reasonable. I would
Yeah,
say.
like I'm trying to be argumentative, so I didn't say yeah, it's 400 and it can go on. So I'm just like thinking out loud. So again, if I make any mistake ever, then just tell me.
They also say number of cylinders equals number of tracks equals 400.
What is
what's
total
the definition of
capacity
cylinder
and the
again?
Hmm?
What's the definition for cylinder again?
So when you're working with, okay, imagine this is a hard drive, right? So let me draw it
Yep.
out. This is a hard drive. Then within this hard drive, you have, like, in this case, it is 15 double-sided disks. They're all stacked on top of each other.
Yep.
And every disk will look like this.
Mm-hmm.
Then one of these rings across all of these disks is what's considered a cylinder.
Ah, okay.
But because all the discs have the same number of lines, basically, of tracks.
Yeah.
It's basically just the same as the number of tracks.
Yeah, in this case it is, yeah. And it always is, actually. So what is the total capacity and the useful capacity of one cylinder? Well,
This
then
is
we
the
first
first
have to
question.
calculate the useful capacity and total capacity of a track, which we already have. And then for a cylinder, that's just the number of tracks, or the number of useful capacity per track, multiplied by the amount of surfaces. And keep in mind, there are 400 tracks per surface, but since there are 15 double-sided disks, there are 30 surfaces. So for actually, let me write down the answer. So this is 400. What's total capacity and useful capacity of a cylinder? That is 30 times the capacity of a track, because there are 30 tracks. Yeah. All right. Does that make sense? Because if we have like the useful capacity of one of these tracks, then we just project it across all 30 surfaces. That's just times 30. Okay, I presume that's a yes.
Yeah.
And what's the total
This
capacity?
is also easy. I'm not paying much attention. Sorry.
Yeah, no, I understand. And then we have the total capacity and useful capacity of a disk pack, and we know a disk pack is just nothing more than 400 of those cylinders, because every track upon one disk is or upon one surface is a cylinder, and we have 400 of those. So then we just do this, multiply by 400. So just a bunch of numbers multiplied by each other. And just to check, I'm going to evaluate this. So the total capacity of the entire disk pack is 153 megabytes, or not quite megabytes, because of, I think this would be, is this megabytes or megabytes or whatever the fuck it's called?
I really don't know.
Megabits or megabytes, yeah. It's just divided by 8.
It's megabytes because
Mostly should be byte, yeah.
Well, yeah, I know it's like
it's mega because you're just doing it divided by 1,000 and not 1,024.
Ah, okay, so 1024 would be maybe. Or
as far as I
whatever.
understand it, yes.
Yeah.
Okay, cool. So this is just indeed 153.6 megabytes. And then the amount of useful capacity, so the amount of capacity you can actually get out of that, is equal to 122.88 megabytes. Alright, makes sense.
Trees.
Okay.
Ooh.
B plus trees.
Oh,
The
my
bicycle of... Oh, fucking hell. What did I drop? I didn't drop my bicycle.
You dropped the table.
Did you drop your house?
You
Quick
would not
summon at
steal a
Alan.
house.
Wouldn't
Would I though? Would
Blow
I?
the house.
I was about to
You
say,
dropped the table.
you wouldn't steal a house. Crocker would like a word with you.
You wouldn't download a house.
Oh, I definitely would.
I definitely,
Yeah.
I would download a
What
3D.
an offer, man.
Download the house app for free, starting today.
Oh, Paul.
It's very good.
Okay. Assume a tree is initially empty and values are added in a given order. Construct B plus trees for the cases where inner and leaf nodes have a capacity of 3 or 4. Inner node links left. Inner node links left of a key have less than semantics, and link's right key has bigger than or equal semantics. Only the final 3 is required. Alright, unfortunately this drawing will have to go.
Oh.
Aww.
But the beautiful desk.
Okay. Starting out. A B plus 3.
I think that is correct.
I think that is correct. Base.
Actually, you should include a pointer that points towards the data.
Okay, yellow is banned. Okay, so
No need to
mute.
yell at him.
Server mute. Oh, hey, Alan, we were just talking about dropping you.
Ah! Well, it's
Oh,
not
yeah.
still on the table.
Don't
No, we
worry,
dropped
I
it.
was already dropped on my head as a kid. It's fine.
ha ha. Okay, so then we add the number 3. Then we add the number
Fog.
19. Then we add the number 7. Guys, it's about to get harder. Damn it.
Oh.
Okay,
By the way,
Me, who literally just did the ADS reset. I have no idea how to do it.
already has to split.
My guess would be that it goes like this.
Would agree.
That does look.
Pretty on point.
19 already had to split since you can only have 3 leaf nodes.
Yeah, exactly.
Yeah, so on 19 you already had to split rather than 7. Because leaf nodes are the nodes below.
No, inner and leaf nodes all have a capacity
Oh,
of 3.
okay, never mind. Also
It's the capacity, not the number of children.
Yeah. Okay.
Also, I would actually put the 3 in the top one. In the...
Yeah, I think it's the rightmost of the left half. I believe that was what it was.
Oh, then wait.
But the 7 should then be in the right node, Jura.
just redraw the whole thing.
Yeah, I was about to say. Okay,
Fuck it,
so
start
what you
over.
guys are saying, it should be 2, 3, 7, 19. And actually, I'm going to go a B plus 3 online, and we will visualize it.
Oh,
every time.
there's a
as we go.
visualization? That's
Yeah.
nice.
So we have 2. Wow. 3.
No way.
Oh, actually, the max degree is 3. Yeah. And then 19.
Oh.
Okay, so already there it splits.
No, but
No, I think
no.
it's
Then
max
the
degree
max
is
degree is equal to 4. Okay.
Yeah.
Oh, we
2,
have restarted. Woohoo.
3. 19. Okay, wait. Actually, there is a slider here somewhere for animation speed. Gonna go up a little bit, and then 7.
Yeah.
Okay.
Looks reasonable. Yep.
Okay, so then we have this. Then we will add the numbers 31. Oh. Well, that won't be too hard. It's going to be 31. And then number 17. And then we will have another issue here. So, yeah, so this will have to split somehow. However, it doesn't make sense to make this a 3 high 3 now already. So let's see.
The tree you're doing is actually B3, not B plus 3.
Oh yeah.
Ooh, good one.
We always have that. Like you gotta go to a fucking. If you just Google B plus 3s, it's the second one.
B plus
Yeah,
3.
it's the second one.
It's so dumb.
Yeah.
Motherfucker. Okay.
Yeah, B plus 3s have every node at the end as well, so
3.
that's the difference.
I have like a fucking stupid ass ezelsbruggetje which doesn't work at all, but it works as long as it's 2 layers high, and it wasn't working, so I was like, what the fuck?
Oh yeah, it takes the rightmost in this case.
Oh god.
Okay.
I thought I was done with the ADS.
You're never done with
it. You're never done with it.
Okay, so we have 7, 19 here. Okay. Then what?
Oh yeah, because it's
31.
greater or equal
31. And then 17. Then what I and this is just a wild guess, right? But I'm going to guess it splits again, and then afterwards it's going to merge back with the top node because that makes sense. Or is it just going to split and then?
It's probably gonna just put 19 in the top node and split it in half.
Yeah, 19 top or 17.
No,
19. 19.
Okay, so.
Oh yeah.
No, 19 stays there as well.
Oh yeah, of course, because it's everything should be everywhere. 7.
Yeah.
Let me.
17.
Oh, fucker.
7, 17, 19, 31.
So it's 7, 17, 19, 31.
And the last half is further away.
Yeah, and then it's
And there's
split.
also
This
19
will be.
there.
This will add a 19 here.
Yes.
And then this will mean that. Really? Okay, wait.
Beautiful.
This is the best idea to use Paint.net for this and not like some online B3 maker. Okay, and let me actually put this one a
Yeah,
little
so
bit.
you
up
remember
well.
my stupid ass fucking thing that only works for two layers?
Unfortunately, yes.
Great.
And then I'm going to make this all white.
But you
No.
currently have it on.
It-
No. You currently have it.
Probably on the same layer, Lemeo.
There we go.
Oh yeah, no, they not.
Okay. Oh, then I've
as
turned this down
good.
to like 3. Okay. So then we have on the wrong layer.
Wrong layer,
This one goes
Kronk.
here. This one goes here. That one goes there.
Don't we have the pointers towards each other?
Yeah, and they should point toward each other as well.
Although I recommend just not writing those lines because you're gonna have to redraw them 7 times.
Yeah. Keep in mind, everybody, there will be pointing towards each other from left to right. However, we're not doing that for now. We're just gonna add that at the end. Okay, so then we will add.
5.
Let's see, we added 17. We will add 5. I wish every insertion was like this. Then we will add the number 29. Let me.
So far, so good. Still the same insertion.
So far, so good.
We're just waiting for the next like.
Yeah, the next
shuffling.
catastrophic one. 23. Oh.
I'll be honest here. I think the best way to do it here wouldn't be Paint, but Excel.
Yeah, well, it would be, but anyway. Any other questions? Okay, so this will become 19, 23, 29, 31, right? But then we're gonna split it. So
Yeah.
I think 23 would go up here.
No,
Yeah.
29.
Oh yeah, because we want to have 2 in the left one, right?
Mm-hmm.
So 29 goes up here. And then, let's see, so it was... okay, so it was like this. Okay, yeah, we added 23, okay. So this is going to be 29. And then after... Oh, it should be like 4. So we have 19, 29, 31, 23. So this is going to be 19, 23, and this is going to be 29, 31. Alright, I think this is correct still. Let's actually catch up to what we have done. So this one only has these 4. And then we did 31 and 17. Then we split it, added 19 there. There we go. That's what we had as well. And after the 19 insertion, we added
5, I think.
Yeah.
Oh,
5,
yeah, 17
29,
insertion.
23.
Okay, yeah. So it's 5, 29, 23. 5, 29, 23. Okay, is this what we have? Yes,
Yeah.
it is.
Yes.
Dude, we are so good.
Yeah. We as a collective of like 50 people.
We're not going to talk about the individual.
We hope we
is
can take examines this group,
quality
which will
fucking
be
shit.
make everything
Well,
easier.
52 people technically.
I say we just do the exam together. Works
Yeah.
Yes,
Yeah.
everybody let's just do the exam on Discord.
Yeah, and then the moment that they all ask like, hey, like they do the after thing exams, you just plead the 5th every time.
No. What we do is we just put you on the phone.
Just put me on the phone every time. Okay.
Yeah.
Let's see.
Like, hello, yes, it is me, Amund.
Okay, so we
do not have-
added
we
we
do-
added
we do
23
not-
just now, right? So what we're going to do is we're going to go here. We're going to press right mouse button. 17 is Lucio. And I'm going to add 11 and 17 again. Okay, so it looks good. And then we add
7-11.
35. Again, adding 11 and 11 and 35 here. Shouldn't be too big of an issue. If I have this one wrong, I'm literally going to cry.
The next one will be.
And the next one will be
Yeah.
pain.
6.
Oh god.
Oh god.
Oh, we even got a 1 here.
Oh,
It's actually not that bad.
Okay, so
I know how to
looking
do it.
looking at it first, we have 2, 3, 5, 6, right? So how we would usually split this is 2, 3, 5, 5, 6, correct?
Yes.
Yep.
Adding that to this one would turn this into 5,
7, 19,
7, 19, 29, and here 2, 3, 5, 6.
Yes.
That doesn't work because then we have to split this one as well. So looking at this, we have 5, 7, 19, 29. This will become 5, 7, 19, 19, 29, right?
You don't need the 19. Yeah, I mean, yes, but you don't need the 19 there since you have, it's not the bottom one. So you don't need to add the 19
Yeah,
there.
good call. Looking at this, let's redraw this. So we have 2, 3. We have 5, 6. This turns into
7, 1.
5,
Yeah.
7. This here becomes 19. This here becomes 29. And to the left we have 19, 23.
You forgot 7, 11, 17.
I was about to say, where the fuck is the 7?
Oh yeah, okay.
It's but it's still appended to the 5-7 node.
Yeah.
Is it?
Yeah.
It's 5-7 now has 3.
Oh yeah, okay. So
children.
this 5 here is from the 2, 3, or the 2, 3. Then we have the 5, 6. And because this 5 gets merged with the 7 here, that also adds the 7, 11, 17 thing here. Okay, so then we have, I'm going to move this one a little bit more to the left. Gone! It's going to be 5, 6. Or, yeah. And it's going to be 7, 11.
And a large soda.
And don't forget the 17.
Yeah, thank you very much. 17. And then here on the left of this 29 we have 19, 23. And on the right of this 29 we have 29, 31, 35.
Looks good according to my bullshit ass fucking Agents game.
So then we have.
I think this is correct.
So we have it like
that
this,
looks
and like
very
this,
right.
and like this, and like this, or wrong one, like this. It's hard to draw it to the left when it's actually underneath it. So like this.
Yeah.
Let's have a look. So we are going to
Insert
add
6.
the number 6.
We are right. Woo!
Let's go.
Yeah.
Let's go!
Go.
Let's fucking go!
I just invented this strat of like splitting them on the left and then like writing it out on the right, like on the spot, but it works really well. And now, well, yeah, we add 22 and we add 24, so that's gonna split this one up.
Easy.
So here it has 22, and here it has
They sprung together.
24. So then we get the 19, 22, 23, 24 thing. That will become 19, 22, 23, 23, 24, which will get added to this 29 thing. So I'm actually going to take this thing, erase this. Oh, Pog, I'm 94 defense on my gargoyle. Yeah, this shows how much I care for you guys. This is gonna become 1923. And then this will be, I will erase
Wait, what did you just? You removed 29 and you made it 19.
Did I? Oh yeah, I did.
2319. No.
Yeah, no, I did. Okay, good call. So this is 2329 then.
Yeah.
Yep.
Okay. And then I will temporarily, or not temporarily, but I will get rid of this. To remember the numbers, I will actually put this up here. This will go, oh, let me unselect this. My paint skills are remarkably amazing.
Glorious.
So this will go to the right, oh, to the right here. Then 23 goes. Okay, so this makes space for all three of them. So then left of the 23 goes 1922. Right to the 9 of the 23 goes 23, 24, and right of everything else goes 29, 31, 35. And then, last but not least, the arrows between all the things. Oh,
the block.
The block.
So okay, we still have to add. Let's see, 22 here.
And I really recommend not doing the 4 one because it's only too high, so it's gonna be fucking boring as hell.
Yeah, this one is a lot more interesting, honestly.
Yeah.
Okay, now to check. 2, 3, 5, 6, 7, 11, haha, 17, 19, 22, 23, 24, 29, 31, 35. Here we have 19, here we have 5, 7, and here we have 23, 29. Boom, baby!
Let's fucking go!
Let's go!
We did it!
Go! I wanted to.
We did exactly what was expected of us. Woo! Let's go!
Whoa, yeah,
Where's
we do, but we got it correct.
Are we gonna do a lunch break?
Reread the assignment. Reread the assignment. We technically didn't do 3.1.
Yeah, we did 3.1. We're not gonna do 3.2 though. Fuck off.
Yeah, like I said, it's too high, or it's only too high at the end, so it's not worth it because you don't learn anything about the higher indexing. Like, why would we care?
Yeah.
Actually, let's.
Task 4 is very interesting. Are we going to do it before or after lunch break? Because I'm assuming we'll have a lunch break.
Yeah, we're gonna have a lunch break. Task 4. How long will it take? I don't think it will take too long, right? So we can just do it. Real quick, I want to have a B plus 3 like this, and we're gonna add the numbers. Have a look at.
You deleted 2.
Ah! Okay, so 2, 3, 19, 7. Wow, and then we have 31, and it's gonna split up. Okay, so when you have an even degree thing, the most the 3 white one is going to be on the right. So when we would have a thing with a capacity of 2 max, that means it would when you add a third one, it will be 1 top 2 3. If that makes sense. Anyway, we added 31, so then we add 17. Then we add 5. Then we add 31. Or no, then we add 29. Break it up, split it up there. 23. Then we add 11. Then we add 35. Then we add 6. We add 22. Then we add 24.
Wow, so exhilarating.
And now my question is to you guys: what will happen if I add 19?
Nothing.
Absolutely nothing. You don't get duplicate entries in a B plus tree. Let's see what happens.
This is pretty complicated.
Wait.
What?
What? Wait. Give me a second, guys.
What?
Huh?
Let's break the system. Let's break the system. Disrespect.
We have 19, and then we have 19, 19, 19, and 19. Very important.
And what happens if we add oh no you?
Ah.
I want to
Okay,
add another
and I'm
19.
going to copy this and put this into Jura's general chalkboard, so people who don't know what we're talking about will find it very confusing.
Wait, so
another thing, like that shouldn't happen. If you add 19 and there's already 19, it should just ignore it.
Yeah.
Yeah, because usually you make these out of primary keys, right?
Yeah.
But another thing is that it should not even go to the left because that's only smaller.
Yeah.
Yeah, in our case it wouldn't, because here we have like our
Yes,
bigger
but
or
also
equal
in
semantics.
battery, because it splits, it keeps the smallest one off the right, and so you had 19 on the right and the left of 19, which also doesn't make sense.
Yeah.
It probably had less than or equal to and greater than or equal to as the constraints for some reason, because it didn't expect keys that are equal.
Yeah. I mean, to be fair, what would happen if you have like 19, 19, you split it up, right? So imagine you have a cell with only like 19, 19, 19, and 19, right? So what's gonna happen is you put this one on the right, these two on the right, and then
Infinite splitting. Infinite splitting.
No, don't worry. You put all 5 of them together, and you take out the middle one.
Put all 5 together.
19.
Oh yeah, no, I get what you mean. So we put this one in the middle, right? So we get 19, 19, 19, 19, 19. And then we take out the middle one. Yeah, there we go.
Yeah, and then put that one at the top and split them on the sides.
Yeah. Put that one on the top and split them on the side. Son of a bitch. I just realized you have a brother. That's not a very good answer. All right. Let's do these two. Like this is real quick. It's like there's only 15 possible answers, right? We can't just brute force it.
How are you back?
Me labeling a thing that already has line labeling. Okay, the lecturer has learned two different indexing techniques: indexing with trees, indexing with hashes. Select which indexing technique is best suited for each of the attributes below in order for the queries, so all of them equally, to run as fast as possible. Assume B plus tree is a height of 4 and that the hash index does not have any overflows. The database contains hundreds of tens of millions of orders.
Billions.
And hundreds of millions of products. Yeah, hundreds of tens of millions. Yeah. This shows how the quality of the course.
You can just say billions.
Yeah.
That's billions of orders.
Yep. Okay, so let's look at the first one. Order.product ID. Let's see where order.product ID is used. It's used in here in a join. When we would add a hash index, this would be allowed to be a hash join, which would be really thick. Do we use it anywhere else? Yeah, we use it here, but that's also an equality. So the only two places we use it are in equalities. And in that case, a hash index would probably be better. What do you guys think?
Agree. So order.product ID.
Yeah, your order.product ID and order.product ID.
Yeah, I guess we're only using it for joins. Yeah, we are using it for joins and equals.
Yeah.
So what do you want to? Which kind of thing do you want for joins and equals is the question.
Hash indexes.
Hash indexes, if you say so.
I think so, because then you can use hash joins. At least I remember something like that. I don't know much of it, but
yeah, this is definitely like we need like a place where we can see all this shit, because
yeah, I'm not very. Yeah, let's actually go to the slides real quick.
There's the mega pack one of all the slides. If you guys want to have a look at it, it's in the IDM
yeah,
channel.
but there they go. Oh, you learned this in the thing, so we're gonna.
Oh yeah.
Which I understand because it's true, but then it doesn't help us when we're doing this.
Yeah. I was like, we should not read them for an overview because I don't understand this topic. It does.
So I've got here.
So it's probably in here somewhere. Probably in this one.
So no index is best if you use direct value / sums. Tree based is best for when you're doing ranges, and hash based is best for when you have a low number of tuples. According to this.
Let's see. Oh, this is all brown. Great. Okay. Query execution.
No, I think it's probably in the indexing lecture.
Man.
Oh, this one.
He was such a nice green color for the worst slides.
Yeah, I know, right?
At
I don't know
least
about
use
you.
like
I really dislike
twist yellow or something.
Yeah. Rows versus columns. Wait, that's only 24 slides. Okay, so
Yeah,
this is
they managed to filter out.
Probably still
That's why I
took you
go to
out
the
to get through
slides.
them.
It's so much faster because they spend so much time just babbling on.
Yeah. What was the thing about beavers?
It should be on the 8th one. Yeah, this one. This is about all the hashes and index and stuff.
Okay.
Do you actually care what was the thing about beavers?
It's on page 42 if you
No,
want to know
but
about
like
it.
I remember something about beavers,
Okay,
like a
so
tangent.
first of all, we have hash indexes, which where the search keys are distributed uniformly across blocks using some hash functions. And tree-based indexes, where we that's just what we did just now. So let's see. Primary and secondary indexes. I don't remember at all what that was, but that's alright. At line 42. Let's see. Then we have hash trees, hash indexes and B trees. So let's see, where does it say when this is better? I don't care about the example.
It says suitable for query loads with equality selection.
Wait, what do you say?
It says go a bit down.
A bit down?
No. Up.
Up, yeah. Okay.
No, probably 55.
55, so this one.
At the bottom.
Suitable for query loads with equality selections. Yeah. Okay, so that's what I thought, because when you hash something, you can get to it relatively fast if you just hash what you want to get, then go to it with the
key.
Yeah. And here again we are using equalities on both the things, so that makes sense. Can we search on these slides? No, right?
Yeah.
Should be PDFs.
Yeah, because when you have if you because the good thing hashing is good for joins because you can use an index hash join.
Yeah, that.
That's
here. This is the hash join that I was looking for. So if I go there, hash all tuples by their join attributes. Yeah. I mean, to be fair, they do say that this is really good if the hash table fits in memory, but
even if it doesn't, I think it's still faster.
Yeah, okay, that's true. It's still really, really fast.
I mean,
you just have to take into account how many blocks the table fits in.
It's yeah, it is best for a low number of tuples. If there is a very high number of tuples, you might want to use no index because, like, you're gonna go down the hash thing for as many tuples as there are connections.
So they mentioned something about. Did they mention something about like table sizes?
In
The
this one,
table
yeah.
size here is gargantuan.
Yeah, so they have like
hundreds of tens of millions.
Yeah. So
yeah, for orders they have billions of orders. So I think actually no index might be better because they have so many orders. Because like even if every index was only a byte, billions is like what, a gigabyte, and for every byte that the hash takes per thing, it adds like a gigabyte of data. So if we have like a terabyte worth of an index, then that's not worth it.
So the cost of an index join is the amount of blocks in R plus the amount of tuples in R times the cost of hash or whatever. So yeah, that's the amount of blocks plus the amount of tuples plus the output value. Well, if we are using actually, then it doesn't really matter because it's both going to be an index. Never mind.
Is a hash index not still going to be faster?
I mean, that's true because we are joining tables, and any other join will still be really, really slow.
The only thing they ask is run as fast as possible.
That's true. We're just going to fill it in, and then we're going to look at the answers later.
Yes.
Product.description.
Why the fuck would you use an index? What do you mean?
Is it even used in here? No.
still, like, just think about the heuristics for a second. You've got a description. Why?
Yeah, true. The only thing I would do in a description, not even equal, but just like.
Yeah,
I don't think there's an index
that doesn't
specifically
work
made
on
for
an
like.
index. No, so no index.
Yeah.
Easy. Order quantity, you're probably gonna want to do more than if order quantity greater than X, so then B3.
Yeah, B3.
Yeah, like you can see in here, the only thing they do is order quantity bigger than 2. So
Yeah.
B3, not just 3.
Is it a B3 or B plus tree? I think they said that when they refer to B3s, they mean B plus trees.
Yeah.
Same with like loop joins, that it's actually a block nested loop join.
Yeah.
Exactly.
Product ID.
But that also only gets used in
joins, so that's hash index.
Like, it literally gets used in exactly the same thing. So there's no whatever you have here, you would have here as well.
And price, they do go higher than and lower than, and B3s aren't amazing when you're using lower than, but I think it's still better than a no index.
Because you have the higher than, right? What this means is if you only have lower than, it's going to be really annoying. But if you have higher than and lower than, you could just go from the higher than until you find a value bigger than the lower than.
But no, like if you only have, if you only want X higher than 7, sure, it's fine. If you only want X lower than 1,000, it's going to be very slow.
Yeah, but if you have X higher than 7 and lower than 1,000, it's going to be fast as well.
Yeah, because
but it's probably price and product.
If you only have lower than X, then it's going to be slow because they're going to have to go like sequentially through all of them.
Yeah.
But if you have higher than and lower than, then yes.
What's actually in the queries?
Well, here it says higher than. It says higher than X and higher than X and lower than Z. So B3.
Then it's fine.
All right.
That's it.
Let's have a look at the answer.
Hash index, no index, B3, index, B3.
Dude, we're good.
We're gaming.
Gaming, boys and girls, people.
Speedrun.
People.
Humans.
Yes.
Yes.
Creatures.
We're gaming creatures.
Well, technically, people is more inclusive than humans because it includes non-humans.
Yeah.
Actually, I'm not human. I'm queer, according to Russia.
People.
Sure. Are we gonna do a lunch break?
Well,
yeah, we're gonna take a break.
I'm not human. I'm a query.
I'm a query.
A query. Oh, petition to rename LGBT people to query when we're talking about indexes.
That's what we named our OPP up.
Holy
because
shit!
It's a name for question, and it starts with a Q, which is a cool letter. So
yeah, and it's also queer.
Yeah,
that's fucking hilarious.
I named it, by the way. It was my idea.
We named ours "Good Question" because they were like, "What are we gonna name it?" And I said, "Good question." And then we roll with it.
We called it the most.
That name is questionable.
Classroom with a Q instead of a K. Come on. Like
class.
Thank you very much.
That's so long and memorable. Like, good question. That's too short.
Dude. My thing is the best. It's called TUDelf Q&A. Yeah, no.
TUDQA.
Someone was creative.
We named ours
TUDQA.
after a typo one of the team members made.
What? I find that very funny.
Well, hey, if you guys want to hear something, ours doesn't even have a fucking proper README.
No, neither does ours.
Yeah.
No, there's no installation instructions.
Hell yeah.
There's no installation instructions. Oh yeah, but didn't you make
installer? Yeah, but there isn't like it doesn't say so in the
There's nothing
README.
that tells you use this installer.
All right, guys, it is now break. It is now 1 o'clock. We're going to see each other again at 1:30.
No.
Yeah, go and have lunch.
Yes. Jurre, bapau.
Bapau.
Ba-ba-ba.
All right, bye, people.
Adios, Peppo.
Ja.
hop into the gaming voice in the meanwhile.
I mean, I'll be making food, so for that I will be off my mic, though I will still be able to hear things. So.
Yeah, why not?
Yeah, learning IDM in a day. I guess the assignments are fine up to now. I haven't done the material, but I instantly understand what's being talked about, so that's great. You delete? Of course they left, did they? Didn't they? Yep, they left. Oh, bye people.
Mam więcej?
Ja, ze wiele sekundy gdzieś tu żyje.
No, kiedy nas taka...
Nie,
Ignas, you were unmuted, so we could hear everything, which Sir muted you, but just so you know.
individuals, maar ik
jaw.
Bone smack.
Bone apple tits.
All right, I'm giving everybody like 2 or 3 more minutes to return, and then we can get started again.
Oh. I love how like the 3, but by now the 3 only like separated unique rules are Assembly God, Boosting Madlats, and Spy Drone. 2 of
Yep.
which only one person has.
I mean, where's the SQL injection role?
Ask Tomato, it's not my job.
Let me just inject my own role.
Good luck.
Okay, let's see. I'll put it in the IDM 1.
All right. So we're going to end up doing IDM assignment 3, which oh boy.
Wasn't there
Anyways.
something with checkpoints as well?
Yeah.
I just completely skipped checkpoints. Someone tell me how they work.
You know, but the thing is, right? If we go to the
No, it had green slides, but it didn't say detour. So they just used the green slides because they think it's funny to use green slides when they don't mean detour because they're fucking dumb.
It says detour though.
Wait, does it? Okay,
Yeah.
then I'm the dumb one, but they're the double dumb one because they use it in the assignments.
Yeah, no, I'm seriously not going to learn the checkpointing thing, because it's a detour.
There we go.
Here, see, checkpointing, detour. Like I'm not going to do or learn anything about checkpointing because it's detour, and they can't like make up their mind on what is and isn't.
If it is on the exam, we just gotta say we were told that detours aren't important for the course.
The detours are good to know, but aren't going to be on the test. They literally said it is not going to be on the test.
The moment I see checkpoints in the exam, I'm gonna write them an email.
Yeah, no, me too. I think it would actually either we can all send them a single email, or we can send one email out of the name of all of them.
Yeah,
we can prepare what we can do, like one that is like that we prepared as like a in case there's checkpoints and like one person sends them off, like and signed by everyone else.
Yeah.
Because that's like we're prepared, we're organized, we're unionized.
We are unionized. All right. So first of all, let me grab all the.
Christian Huygens would be proud.
So let's see. I want to find that one slide with all the different formulas, or not the one slide, but like the one presentation. I think it's this.
I can send you a few slides.
Yes, please. Send them in the VC channel, please.
Sure.
So this is just about joint strategies.
The things to the side are my notes, and they're probably wrong. Just saying, but like the rest is slide stuff, so that shouldn't be wrong. General VC channel.
Compenseer collega-geld tot nu.
Ja. Vind ik dat ze het gelijk hebben? Nee, ik zou eigenlijk origineel zou het niet moeten. Vind ik dat er €2000 toch wel €2000 is? Zeker! Hey. Fucking.
I love the fact that we are getting that we are paying €2,000 for a Zoom link, and I love the fact even more that there are people who aren't even joining the Zoom link and just going off of my shit.
Yeah, like I'm not gonna lie, this is much more useful than the actual like course.
Oh, thanks. That's flattering.
Yeah.
It literally is though.
That isn't because of the fucking. That is like sure, you're doing God's work out here, man.
Yeah.
But it's more because of the course.
Yeah, I spent more in the past 2.5 hours than in the entirety of the
For
Zoom
some fucking
lectures.
reason, everything to do with databases is just a hot mess.
Yeah.
Weapon
Well, yeah.
databases.
Yeah, they were both hosted by the
Like-
same person, so.
Ironically, the database, the data management course is very badly organized.
Yeah.
They should just put it in a database or something.
To be fair, I think most databases are also pretty bad.
What do you mean? Our CSV file works just fine for up and until 10 users.
Based.
Are you actually?
No, I doubt it. No, you're
we're
using
not.
a Postgres database. You just said that.
We're using local Postgres database. So now if you want to run our app, you have to locally install pgadmin and add the credentials to the dev properties.dev file, and then you can launch the app.
Yeah, that's really fucking stupid. We just have like an online.
Yeah, we have.
We
HTML
just include
anyone-
the
and
anyone
Docker
who has the
compose file.
server, so
Yep.
anyone who has the server files can edit the database that everyone is using.
Same.
Oh, that's fun.
Bulgars.
Hell, not only that, we're using like just password login.
And the password file is in your Git.
Yeah, it's in plain text in ours as well.
We just tell people to set up their own thing, which is probably going to make the university go, Angie, but like, come on, this is the way we programmed it. It's not our problem. You can't
Get
fucking
fucked.
install it.
I don't
Yeah.
think. I think if you go up to like your group or like your TA during the Q&A session and you say herder get fucked, I think you're gonna be in a bit of a situation.
I mean, they never told us that it has to be runnable only by running the executable. Like, there can be.
They just said as long as there's installation
Here, look,
instructions
first you
and
can
how
just
to
say-
run instructions, it works.
Yeah, that's what we did.
Select star from lecture. Here's all the lectures.
What the fuck is wrong with you?
Yeah.
Why is this all in here?
Good question.
And like every time you run the test, it just creates new stuff which it doesn't throw away or what?
Oh, it throws it away. Yeah, but this is just from manual testing from us.
We just did in-memory database for testing, so that it even works if you don't have internet. And like, yeah, because fucking Maurits managed to install. Maurits, if you hear this, you carried the project. So you have in-memory for testing and out of memory for like the other stuff.
Yeah, Teamer, if you're here, you're a fucking god.
Yeah.
Okay.
Sure,
Anyways,
well,
let's go on with the assignments, shall we?
Yeah, Mikael, I know you're here. Thanks for everything.
We should just like have a moment within the IDM channel or within an appreciation channel where we just shout out like all the people who just carry the
Yeah,
project.
I mean, I think after this thing is done, like after everything is done, the Q&A is done, and we're probably allowed to share our videos. I'm gonna post my video in the
Yeah, me
in the
too.
appreciation channel and be like, hey guys, great work, and like fucking flag. Like I already offered this before, but I haven't posted in the server suggestions. We should just have a channel where like we had a channel where people could show off CO stuff. Right,
Yeah.
remember when the game stuff?
Yeah.
Why not have a channel where people can show off their fucking apps? They put a lot more work into the app than the CO stuff, depending on
Yeah.
who it is.
Yeah.
So like, you know what? Fuck it, why not?
Okay. Wait. So the only thing we have to do here is insert this thing. Okay. So we have a.
Yes, but I remember us going like,
So let's see. I'm gonna copy the tree first. Salary 150, age 60, age 50. So again, like if we go here, so this is salary bigger than 150, age less than 50, salary less than 300. That's here. Salary 300, 30,260. 70, 100, 110, 85, 140, salary 80, 50, 150, 120, and here right of age 50 we have 50,
120, let's
75.
go.
Ah, dude, funny. 60, 260. Okay. And now let me draw some lines to actually make it like visible. draw how to insert the value 65, 110. So what we have to do is 65 salary less than it's age comma salary, by the way. I sure hope so. I hate how they say like salary age, but the thing is an age salary. So let's see, salary is less than 150 over here. Age is more than 60 over here. So we're gonna have to split this up into a heuristic of like into another like split. So we have 65, 100.
110.
Yeah, 110. Yep. So now this part over here looks like this, but there's 3 of them, so we have to make a split. I'm going to choose to split it at. Let's see. So the left has a less than semantics, and the right has a bigger than or equal to semantics. I'm going to split it at salary 140. So I'm going to cut this, paste it over here. Bonk. So let's say salary 140. So the tuples to the left of this will be 65, 110 and 70, 110. And the tuple to the right of this will be 85, 140. Less space. Again, this is very crowded. Yeah, that's my bad, but so this is what it looks like for me.
It's very crowded. I suggest you suck it up.
Paste. So this is what I think it will look like after the insertion. And just to check, salary less than 150, age bigger than 60, salary less than 140 is here, salary bigger than 140 is here.
Is it bigger or bigger than equal?
It's actually bigger than or equal to, my bad.
Yeah, that's what I thought.
Okay, so I think this is correct.
Yes, it is.
Quick question: are you allowed to put any value between, so then like higher than 110 and lower than or equal to 140, or is there actually like some kind of argument to which value you should pick?
As long as it works.
Okay, so there's no like rule for it.
No idea.
I think the only reason why you didn't pick like the middle one here is because then you would still have 3 of them on the right. But I think in general you pick the middle one.
Yeah. You okay? So you usually pick the middle one, but here, yeah, if you have like 110, then it wouldn't work. So we pick another one.
Yeah, at least that's what I think. But they have not really talked or shown on the slides a specific rule about that.
Okay, cool. That's all I wanted to know. So, number 2, the algebraic hill climbing. Modify a query in its.
This is a long question.
Whew! Okay. Okay, so we're gonna have to take this query, and then do the hill climbing thing until we get a better one. I mean, all in all, this is not too bad. Let me see. Where can I find the gist that has this? Is this the same one as before? No, it's not. Do they not give us a gist?
It's at the very top.
At the very oh yeah, my bad. So it is this one. Okay. So starting off. Starting off, we will. So what this query does is it will select student.given name, student.family name, courses.code, courses.code, courses.name, and grades.grade from join on student number is equal to grades student number and courses dot quarter is equal to 1, and grades dot course number is equal to courses dot ID, and grade dot grade is bigger than or equal to. Can I do this? No. Bigger than or equal to 9 from the cross product of grades of students by grades cross product courses. Oh, one too many. And if I do execute query, it will give us a bunch of stuff, and this is what it looks like. 107,400 rows. Which, I mean, honestly, like, if we look at this,
Yeah.
like, we know this cross product is just gonna be this times this, right? So it's 600 times this, which, yeah, seems about right. So, let's start with this one. First step is breaking up, yeah. So these are the hill climbing steps. If they actually give us this on the exam as well, that would be really nice. Otherwise, I'm just gonna like put it in. Like I am going to put this in my cheat sheet because this is like really important. So then I can say break up selections. So the selections are this part. So I can then say select this thing, select this thing, select this thing, execute query. Query is going to be practically the same, other than that we are doing these selections in parts. Push selections as far as possible.
Yeah, as far down.
Okay, so this one only uses grades, so I can put this one into here in grades. And as you can see, what I will do when I execute this query, we can see that this is now over here. So this will actually return only 30 rows instead of 180-ish. Then I can do the same for quarter is equal to 1. So I can do this here. Execute query. And then the last one I can push down is grades.number is grades.course number is courses.id. I can put that in here. So that let me make this easily spaced real quick. So that it is pushed down as much as possible. Alright, this seems good. Break, eliminate, push, and introduce projections. Try to project intermediate result sets as greedily as possible. Okay. So let's see. Let's start with the selection from courses. So here we can select course says.code, courses.name, and then the things we also use in the what's it called? In the selections and the joins, which is courses.quarter, courses.id from courses. Now the question is, they say as greedily as possible. Does that mean that I have to select all this stuff here, then do the selection, and then select all this stuff minus quarter, because this doesn't seem to make much sense.
I think greedily means you need to like reduce the most every time possible.
I see, so then it is like this. Because right now we're taking courses, we are taking only what we need, then we select, and then we're taking only what we need.
Yeah, I think that's
Yeah,
right.
it's fine.
Okay, cool.
Says
So
the person
I
who
am going to
didn't
put this on its
attend
own
a
line because
single
by God does it
lecture.
deserve that.
Says the person who didn't attend a single lecture. Why are you listening to me?
Go on.
Like, guys, why is anyone listening to me? Why am I even talking?
Good question. So then we take grades
Go
dot
on,
grade
we always wonder that.
and grades dot course number. Oh. Oh, and grades dot student number. Actually, we can check this out real quick because here it is. Here it will say an example of here the heuristics in action. So here they select and then project. Okay, so the first one is not needed. Good to know. That makes a lot more sense to me as well, honestly. So then we can do this and put that over here. So then we can also get rid of, well, we can't get rid of grade because it has to be printed over here. But here we can get rid of quarter to quarter, so that's good. And then for student, we can also project that one real quick to be only students dot student number, students dot given name, students dot family name, and execute query. I'm gonna set this full screen real quickly. So as we can see, well, not very much see, but when we yeah. So we have a thing, we select from it, we project it. We here we don't have a selection at all, so we only project it. Then we join those, select from it, or yeah, select project. So it's always something, which is either like the original table or a product or whatever. Select project. Something, select. Something, select project. I mean, realistically, we can also put a selection here, so let's do that actually.
You just want to select as often as possible.
Exactly.
Trim that size down.
Yeah, it reduces the number because you're doing a Cartesian product, so it reduces the number of rows drastically.
Yeah. So here, this part right now has all this stuff and all this stuff. However, we do not need courses.id and courses. And grades.course number. No, and a comma here. So now when we do this, so it's yeah. So right now it's always project select, or select project. Yeah. Unless you don't have a selection, in case that's here. But for the rest, it's always a selection or and a projection. And in that case, that is over here as well. So before you do anything, there's always a selection. That's good. Okay, so this will be the next step. Okay, next step. We have from the assignment. Collect selections and projections that between other operators there's only a single block of selections followed by a single block of projections.
Yeah, I'm gonna show.
Okay. I already did that. Cool. Combine selections and Cartesian products to joins. Well, that's not too hard. So this is only, let's see. Okay, so we're doing this join. So this is like Cartesian product and a thing. We can combine that into a natural join on this. Yeah, a natural join on this clause. Same goes for this x. That can be a natural join on this clause. Execute query. Yeah, and here we can see instead of like, so it will say just, yeah. Cool. And then we have to prepare for pipelining for unary operations, which would be this part, and I think that's it.
The query as one line is cursed.
Hmm? Yeah. Yeah. I love how because they realize that now the table names are the most important, they just put it full in full width. So like students, grades, courses.
Yeah. But I think it always does that because like the thing that belongs to the selection or projection part is always written in subscript.
Yeah, exactly. That's what I think too. Because I can see like these symbols are the same height as these. Either way, that is it for this assignment.
I would say check it with the answers, because the answers probably have the proper query. I believe the answers are out. Should fucking be, it's a day.
Yeah, the answers are out. Lab assignments.
Because I think we've checked all of our questions before, but this one.
Yeah.
Yep.
So we had that one correct. Here we had this correct because we broke everything up here. Then we pushed these down. Yep, looked good. Yeah, they also selected here. That's good.
Yeah, we were wondering about the selection, projection, selection, or projection,
here.
selection, projection.
They actually do that here, though.
Yeah, exactly. They do that as well, so it's fine.
Yes, it's fine. It's probably better than even.
Mm-hmm.
Or you said selection, projection, selection. It's actually projection, selection, projection. Yeah.
Yeah, I corrected myself.
Yeah. Okay. Then here. Oh yeah. Okay, and then they remove it on step 4.
Why do they remove it though?
Because it's less work, and selections are the same effort as long as you have, with like, no matter how many rows you have.
Sure.
Okay. Number 5. Well, that just does the natural join, and the unary operators are the parts that like only happen within one table that you can do. You can pipelines. Okay, I think we got that relatively correct.
Sort of. 4 out of 5 points.
All right, let's have a look at. Oh God, no! I don't feel like doing this, man. Okay.
Yeah.
Okay, luckily we only have to calculate like I1, I2, I3.
And I1, I2, I3,
I4. In number of records, number of bytes, and number of blocks by using suitable heuristics. Alright, let's read everything. So, same university schema as the previous task. Now you have some more information about the attributes. Int uses 4, char uses 2. Records are stored row-wise using fixed length without spanning. For a block, there's for the most blocks there are free space left. Oh, there is free space left. Records are stored on disk ascending with respect to primary key. A block stores 496 bytes. The following table and column statistics are available. Blah. Based on the above schema, perform the following tasks for the two operators.
Unique values too. Boo! Gender, unique values, 2.
Boo!
Ooh.
It says
I'm
sex.
literally having a conversation about this with another person in the EMs right now. Wait, let me grab a screenshot real quick.
I mean, realistically, like it could very well be that that the number of unique values is 2 because they don't have a non-binary student.
Mm-hmm.
And it says
However,
sex.
they do have like 1,000 people. Or actually, no,
1,000
that's
teachers.
that's 1,000. Hmm. That's
They have
But
five-
there
they
are
have
more than
5,000
two sexes,
students.
though.
They have
So
5,000 students.
Oh yeah, here it is. 5,000 students, no MB student, and all of 5,000 of them. Then again,
We've
maybe
got 600. They've got like 5 MBs or something.
yeah, okay, but we are CSE.
Yeah.
We're all either autistic or LGBT.
yeah, or both.
Or both.
True.
Okay, so and that's not discriminative for me to say because I'm both of them.
Same.
So let's see. Okay, yeah. So if we have, for example, here a char 20, that will always take 20 bytes. And I love how they like state all of this.
Well,
And then,
char 2 bytes per length.
ah, yeah, good one. Even though like this is all not useful because here it just says the number. So grade is a chart of length 1, that's 2 bytes, and then it has 2 ints of 4 bytes, that's 10 total. So, you know, we can just use these. We can also manually calculate it, doesn't matter.
Mm-hmm. It's good to manually calculate a few times so that people know how to do it.
Let's look at grade. Let's look at courses then. So an integer is 4 bytes, and a char is 2 times the length. So this one would take 4, 8, 12, plus 12 is 24, plus 60 is 84. Courses takes 84 per row. There we go.
Epic, very difficult.
Epic. Wow, we are doing university level calculations, guys. Calculate this using an integral. Okay, so I am going to grab my favorite tool again. And let's start by this one. So let's have courses. That thing has how many? So select courses. 2,000 students. Select courses with Q is 2. Is 2,000 divided by the amount of unique values for quarters, right? Because if there are 4 quarters that are, we assume, evenly distributed, then every quarter will have, is 500. Then we can select only the ID. That's still 500 records, but now every record only holds an ID. So they want to know, where is it? Number of records. So let's call this one L0 or L1. It's L1. Wow, boo. L1. 500 records. The records contain only ints. So let's see, number of bytes. Yeah, so it contains only ints, and ints are 4 bytes per. So it's 500 records times 4 bytes per record is equal to 2,000 bytes, and then the amount of blocks. Amount of blocks is equal to 2,000 bytes divided by 496 bytes per block. And then we take the ceiling function of that, which is the opposite of the floor function. So what that means is just round it up.
But we're non-spanning, right? So we might have problems here. We need to look at records per block, not at bytes per record, probably.
Let's see.
Yeah, because if you have if you're like 2 blocks, records don't get cut off and put in both of the blocks. They just cut off the record at the block, so that each record is in only 1 block at the same time.
Yeah, okay, that makes sense actually. Let's do that then. So we have 500. Let's see. So we have 496 records per byte, or record bytes per record. My bad. Then we want to see. So every record is Oh, yeah, okay. My bad. So this is bytes per block. Then we... let's see, what's the other thing? We only have integers, so we have 4 bytes per record. And does that work out? And this turns into records per block, yeah. Is equal to... Let's see, so that is 124, I think? 120, yeah, okay, it's 125 minus 1, so 124. 124 records per block. Then we have 500 records divided by 124 records per block is equal to... And then we take the ceiling function of that, because we can't just use a quarter of a block. Oh, that's 5. So either way, it's still 5, but I think if we had like a bigger record size, it would have mattered. So thanks for correcting me nonetheless. Okay. So the answer for my first, for like I1 is going to be 500 records, 2000 bytes, and 5 blocks. I'm sorry if my notation, by the way, is very confusing. But I like to put down what the number represents behind everything, because that way I can check if it makes sense. So here we have bytes per block divided by bytes per record. Same with multiplying by records per byte. Then we get bytes times record divided by block times bytes. That becomes just records per block, which it makes sense. Kind of what I do for chemistry. L2. So we have a natural join, not a cross join, a natural join of courses styled by and the list of 500 IDs. So we have courses styled by x ID is equal to... So here we have 5,000 records. We multiply that by the amount of records in this one, it's 500. Let's see, but this is a natural join. Let's have a look if we can find it here. If somebody knows it, by the way, feel free to tell me what the amount of numbers will be. And what the formula is for that.
For what?
How many records there will be after we join on a primary key. Or is it a primary key, actually?
That should be in the table. So hold on, what are you joining by?
We have courses styled by, which has 2 primary keys, namely teacher ID and course ID.
Mm-hmm.
And we have teacher IDs. Like a list.
So we're joining by teacher IDs.
Yeah.
So then, for every teacher,
yeah, wouldn't that mean there's just one?
No. That is.
Oh, here, yeah, we have to use this.
Yeah.
Okay, yeah.
It's there.
Okay, cool. So we have. There are 1,000 teacher ID, distinct teacher IDs, and there are 2,000 different distinct course IDs. So for every one teacher ID, there's approximately 2 course IDs. So for 500 teacher IDs, there's approximately 1,000 course IDs. Actually, is that course IDs or teacher IDs? Let me see what we're doing again. Ah, so this is teacher IDs. If you show this to anybody, they're gonna freak out. Divided by actually, so this a good way to say this is 5,000 times 2 divided 2 course ID per teacher ID. Wait, am I wrong here? I think I'm wrong here. Because we are starting with course IDs and then we are going to teacher IDs, right? Yeah, okay, so yeah, that's my bad. So this should be divided by 2 course ID per teacher ID. And then we will end up with 250 pairs of teacher ID, course ID. And then afterwards we just join that and then we become only teacher ID. Yeah, so just to reiterate, we start with 500 course IDs. And for every 2 course IDs, there is approximately 1 teacher ID. So that means we halve this number, and that will become 250 teacher ID course ID pairs. And then we select that, and that will be 250 teacher ID. Okay, does that make sense? $50 people and not a single person.
So it's literally just look up the values in the table.
Yes.
Wait, how do we know that each teacher has 2 course IDs?
That's like on average, and we are using the number of distinct values here.
Oh, okay.
So yeah, there are like 2,000 distinct course IDs, and there is 1,000 distinct teacher IDs. So on average, every teacher ID will have 2 course IDs.
Okay.
Again, if I'm doing something wrong, please tell me, because I did not follow this lecture. Or I did follow it, but I wasn't really there with my mind.
I know the feeling, man.
Yeah.
Mood. I was watching a movie.
We all feel that.
Yeah. When the movie's more interesting, you know. So now we are
wait,
here.
So you're saying that there is 250 records in I2?
Hmm?
So
in I2, yeah. There's 250 records consisting of only teacher ID and I2.
Right. I'm not sure this is correct though, because the way you calculate like join is by taking the like you multiply the size of one relation times the size of the second relation, and then you divide by the number of unique values.
Yeah.
Right.
Yeah.
But the number of unique values is different than what you said here. I don't think that's the way you calculate it.
Okay, good. Thank you for mentioning it. So that's why I was wondering if anybody knew the formula. So let's have a look at that. So let's look at the join
costs.
Let's see. Join cost is the yeah, so this A times B divided by the blocking factor.
Blocking factor is that's not the like the correct formula. There is one, I'm not sure on which slide though. Yeah, it should be here. This is the maximum, like the reduction factor is the maximum of the number of distinct values in like two relations. So in this case, we are joining by course ID, and in courses taught by there is 2,000 unique course IDs, and in I1 there is like the number of all the records have distinct course IDs, and then you take the maximum of these two and then you divide it by that.
Yeah, Jura, I should have it somewhere.
Yeah, I was about to say, everything you said so far makes sense. I'm just trying to find it.
I think
put the formula in the chat.
I've got it.
Yeah. I was saying something, I'm like,
I put it in the chat as well.
Okay.
Ah, yeah. Okay, open original. So this is it. So you have the number of records in R times the number of records in S divided by the product of the max of the number of distinct values in one thing divided by the number of distinct values in the other thing. So let's have a look. This makes a lot more sense than what I was saying. So we have how many records were it again? 5,000 records in course style by, I think. Yep, and 500 in ours. And then we divide that by the product of all the join join conditions, but we only have one in this case, right? So we can just forget about this product.
Yeah, should be fine.
Yeah, so then it's just the max of the distinct values of for the distinct values of our of like the thing in our relationship. So relationships, I meant relations. So we know that this one has a max number of distinct values on teacher IDs of 500. Or not teacher ID, sorry. This has a distinct number of course IDs of 500, and this one has a distinct number of course IDs of 2000. So we divide actually by 2000. The formula I used here makes sense for something else, but it's not for this. Okay, doing some quick maths. Let me copy this over. Then I divide by 1000. Then this will be 2.5 times 500, which makes it 1250.
Yeah.
Okay, this seems to make a lot more sense. Sorry for the hiccup, everybody. Sorry for getting it wrong. I just didn't know. So now we do.
You're learning together with us. You're not a lecturer.
Exactly. I'm not paid by the school.
You should.
No, but then I'll be under all sort of legal obligations. This is fun.
I mean, you still are, but they just don't know about you.
Based.
You're working outside the law.
I am the law.
You know,
Vigilante lecturer.
I have to say, I think the school probably has a pretty good idea of who you are at this point.
They really do. Actually, they said before that when I uploaded one of my OOPP things, they saw that I did an exam that was really similar to one we did before. So that was when we did like the Deezer and Spotify exam thing, I think.
Yep.
And they had to edit the exam because the thing I uploaded was way too similar to their thing.
Yeah.
Oh, so that's why the exam was so difficult.
Yeah, blame me.
Actually,
So-
actually, yes, like really, it's great.
Yeah, I had like a lecture. They said it.
At least the reset was much better.
I mean, I don't think it was too bad. I got like a 9.5, but
Flex.
flex. Humble brag. I got only higher than 9.5 in the first quarter. Flex. Okay, so we have 1250 teacher IDs. Well, that's 1250 ints. So that is 1250 times 4 is equal to 5,000 bytes. Again, we know teacher IDs are int because of this. And then we have, well, we know again because we're using the same records per, we're using the same data thing, so we can still use the same amount of records per block. So we can just take this the same thing here. So we have 1250 records divided by 124 records per block is equal to 11. And this is 11 blocks. So my answer here is 1250 records, 5,000 bytes, and 11 blocks. And somebody can check that for me. Well, I wish I was doing like anything else right now. So
Wait, which one?
wait. Oh, okay. I was like, wait, that doesn't make sense, but that's the answers. And now the last one, we join this thing with teachers, and then only grab the email. So this is basically just grabbing all the emails of teachers who teach in Q2. Well, that shouldn't be that much. There's only like 3 of them. Okay, so right now we have 2050 teacher IDs. Honestly, I think after this, like, because this is a natural join on the private key, right? Wait, how does this make sense? I don't think it does.
How do we have more teacher IDs than there exist teacher IDs?
Yeah, then there exist teachers.
Oh, because there's some teachers who have multiple courses.
Yeah, okay, so this is
for courses.
Yeah, so this is not distinct. This is just the total set.
Yeah.
Okay.
Okay, let's see how this works when we actually do that. So we have this amount of teacher IDs. Then we have this amount of teacher IDs times this amount of teachers divided by the max of the distinct values of this thing or this thing. Well, that's going to be divided by and again, because we have like 2 different relationships, so and the max of the number of teacher IDs in a list of 1250 teacher IDs, or 1,000 teachers with 1,000 teacher IDs is just 125 or 1250. So we will get a list of 1,000.
Can't be correct, I think. There can't be 1250 distinct teacher IDs.
They're not distinct.
They're not distinct. Oh wait, yeah, you're right, because we are grabbing the max of the distinct values.
Ooh.
Ooh, that makes it more interesting. So we know from this that the... Oh, I see. Okay, I see how we have to do this. So we know from this that there is a... in teachers, there are 1,000 unique teacher IDs, because this is a private key, right?
Primary key.
A primary key, sorry. Private key. So we know that the number of distinct values in teachers is going to be 1,000. We can realistically assume more than, let's say, a factor of like I don't know, more than 25% of the teachers teach more than one course. So we don't have to make an actual estimate. We can just say that we guess that it's lower. Like once we these are the total amount of teacher IDs, but once we filter out teachers who teach twice or two things in one quarter, we can assume that the biggest number is going to be the 1,000. So then we take the max of the two distinct values. This will probably have less distinct values than 1,000. So we can divide by 1,000, and this is going to be equal to 1,250. Does that make sense?
I mean, it kind of makes sense when you like look at the, how do you call it? Just like if you merge those two things together, like nothing should really change except like you add the teacher's name after.
Yeah, exactly. And I don't like we don't explicitly say anywhere that it has to be distinct, right? So if we take 1,250 values and we join it with teachers, then it's still going to be 1,250 values. Either way, so we have 1,250 values of a bunch of shit, but we're gonna restrain that to just emails. So for our L2, or actually it's gonna be L3, is going to be 1,250 records. Every record consists of an email. An email consists of a char 30. There's 2 bytes per length, so that's 60 bytes per. So it's 250 records times 60 bytes per record is equal to, well, this times 60. So actually I can do that by heart. That's 15,000. So we have 15,000 bytes. And then we can calculate the amount of bytes per record. Or, sorry, bytes per block. That's not calculate, but we can just look it up. It's 520, or 520. 496 bytes per block. We can.
I think it's 75,000, not 15,000.
Oh, does that make sense? It's 15 times 5,000. Yep, you're right. Shouldn't let me do math when I'm 3 hours into fucking yeah, this stuff.
I don't think you should go to bytes. You can just immediately go from records to amount of blocks because there are 4, like every teacher, there are 4 records of teachers in a block. So you can just do divide by.
Yeah, but we don't have record of teachers. We have record of teacher emails.
Oh, okay, no, never mind in that case.
Yep, no worries. So we have 60 bytes per, so we have this amount of bytes per block. We have 60 bytes per record. We'll leave it with something in records per block. So that's what we want, yes. Then I can just say 496 divided by 60. And it's going to be like the floor of this, right? Because they're non-spanning. So this will be 8. So there are 8 records per block. So we have 1250 divided by 8 is equal to, or let's actually say 1250 records divided by 8 records per block is equal to 1250 divided by 8, 157 blocks. Okay, let's have a look. So for the first one, we have 500 records, 2,000 bytes, and 5 blocks. Yep, we had that correct.
Yep.
Then here we have 1,250 teacher IDs, 5,000 bytes, and 11 blocks. Woo! Woo! And then I'll treat the big one. So we have 1,250 records. Oh, here they say max 1,000, 1,000. That's interesting. So they assume the number of distinct values in 1,250 teachers is 1,000. I just assumed it would be less than that.
Yeah, because there's only 1,000 records of teachers.
Yeah, true. But what if one teacher does multiple courses?
No, there's 1,000 records per teacher.
Okay, so what I'm thinking, right? So teachers is 1,000. So the max DV of teachers is always going to be 1,000. But we don't know what the max or what the distinct number of values is in 1,250 random teacher IDs, right?
Yeah, you don't know this exactly, but you know for sure that it's no more than 1,000. So
Yeah, we know that much.
Yeah. So
Or
that's
at least
just-
we
that's
assume that
the
much.
max. Yeah, you don't have to assume that because you know that there are 1,000 teachers. So there's
Oh
no
yeah,
way
that makes sense. So there won't be more than 1,000. So we know for a fact that it always.
Yeah, so that's
Yeah,
the fact.
It's just that they used 1,000 here, whatever.
The max of both is 1,000. That's why they use 1,000.
Yeah, the max of those is 1,000, so we know that much. And here we have 157, which is correct. Woo! Buggers, boys. All right. Gonna put that.
Talk about.
Whatever. Okay, and delete. Next one. This. Ooh. Okay. I mean, we are getting faster with this, so it shouldn't be too hard. So we have L1. So we have the entirety of courses. That is 2,000 courses. Then we select it by ECTs is 5. What's the There are 5 unique values for ETCs, so that is 2,000 courses divided by 5 DVs is equal to 4,000 courses. Yeah, this doesn't make much sense when you look at it from a unit perspective, but you guys get what I mean, right?
Yeah.
Okay. So, again, is that the right one? Yeah.
Well, it does if you look at it from a unit perspective, because the bottom is just a number.
Yeah, okay. So this is just indeed. If you look at it as like a number instead of DVs, then yes.
Well, yeah, because it's 5. That's a count. Yeah. It's not like there's 5 different. Yeah, okay, there's 5 different distinct values, but it's a number. It's a factor.
Yeah. It's a unitless number. Yes.
Yes.
Then we select ID, code. So 400 ID code. So then I1 of L1 is 400 records. It uses ID, which is an int, and code is a char 6. The char 6 is 12 bytes, so this is 16 bytes per record times 400 records is equal to what, like 6400?
Yeah.
Oh, that's wrong one.
6,400 bytes.
6400 bytes. And then we can look at the amount of records per block. So we have again 16 bytes per record. We take 496. We divide that by 16. Well, that's going to be a neat little number. So that's 31. And it's 31 records per block. And then we do the seal of 400 divided by 31 is equal to. Can I just put this into Google? Sad. So that is 13. Okay, so we have 13 blocks for this. Let's see if that's correct. Very careful scrolling. Wait, what? Oh, okay, yeah. So it's operator tree 1, operator tree 2, operator tree 3. Tree, haha. Boy, I can't wait to do assignment 2 and assignment 3. Okay. So then we join this with grades. And it's a natural join, so we will take courses dot let's see, where is it? Ah, yeah, grades.course ID is equal, and then that belongs to courses.id. Yeah. Okay. Yeah, so this join is equal to 400 times the amount of the amount of things in grades, which is 10,000 divided by the max of distinct values of, and these are again course IDs. So it's the max DV of something less than 400. Where is it? Max of 400, and the distinct number of course ID. So that's going to be 2000.
Okay.
Somebody's on the phone. Can you please mute yourself?
Hammond.
Ah, Hammond. Wait, where is he?
He muted.
I sort of muted him. Hammond, when you're done with your phone, you can send me a message. So this is just equal to 400 times 5, which is 2000 again. So here we have 2000 records. And then we select only teacher ID, so then we'll have 2000 teacher IDs. And from there on, it is relatively straightforward. So again, 2000 records. We have every teacher ID is only an int, so that's 8000 bytes. And hell, we can even use the same amount of records per block because it's only a byte. So that's 124 records per block, so we can take 2000 records divided by 124 records per block is equal to 17 blocks. Next one. So then, I looked at this one, not this one. So we actually, damn it. Okay, so it's actually 2000 student ID, comma, code, comma, grade. And is that everything within? No, so it's the course code, student ID, and a grade. Okay, cool. So, yeah, we still have 2000 records. So a student ID is an int, so that's 4 plus. A code is, what's the code again? A char 6, so that's going to be 12. And the grade is a char, that's plus 2. That is equal to 18. So then we have 2000 times 18 is equal to 36,000 bytes. And then we can calculate the amount of bytes per record, or records per block. Records per block is equal to 496 divided by 18. It's 18 bytes per record, yeah. It's equal to 27. And then we can do 400 divided by 27. And then take the ceiling of that, and that becomes 15.
I'm so glad we allowed a calculator on this.
Yeah. And this is all for L2, obviously. L3. Oh, that's this one. So we have the students only. I read this as sexy is yes. But is sexiness distributed evenly? I mean, we can assume it is.
Yeah.
By the way, you took 400 records in line 19. It should be 2000.
Ah, good one.
I mean, you know, if they only have 2 categories,
Just
so
times, that's just that
don't
times
make it
5.
balanced properly.
So that is 75.
Oh no, wait, can you, I think it had like, oh, never mind, no.
Okay, so L3, we have the list of all students. All students are 5,000 students. Then we filter by distinct values. There are 2 distinct values. It is really good that they actually mention it and it's not implied, because then, you know, I do find it pretty funny that if there will be one non-binary student, the number of distinct values here will be 3, and the number of students will be like what, 1,666 instead of whatever, 2,500. That's just the power that non-binary people have. I don't know what to tell you.
Yeah. Honestly, it's just sad.
So we have 2,500 ID, names, and then we should do the calculations again. Woo! So we have 2,500 records. 2,500 times an ID is an integer, so that's 4 plus, and name is a
But
char 30, 60,
technically, sex could also be null. Or,
yeah, I don't know if they've explicitly said not null, but even then that would be another distinct value.
Yeah.
So that would be 160,000. So we have 160,000 bytes. We have 496 divided by 64 is equal to 7 records per block. And 496 divided by 7. Oh, actually, it's the number of records. Yeah, it's the number of records divided by the number of records per block gives us the amount of blocks. So we need. Why are these the first? Okay, 358 record blocks. Okay, L4. So then we join these on student ID. And since that's the primary key, the number of records here is the distinct is the number of values. So we have 2,500 times that's, and then the previous ones, that is 2,000 divided by the max of the distinct values of both of them. So let me write that out real quick. So we have 25,000 students with for sure distinct values, and this will be some number less than 2,000. It doesn't matter. So then this will be just 2,500 is equal to 2,000, which honestly makes sense because we are taking some number of student IDs and we are joining them with students. So that will be just that same amount. So you know there's going to be just as many records in L2 as in L4.
I think you fucked up L3.
Oh, Pog, how?
It's you took the teacher, the amount of characters in the teacher name is different than the number of characters in the student name.
Seriously?
It's 20 characters per student, so it would be 44 instead of 64.
How come teachers are allowed to have longer names? That's disgusting.
Sorry, wait, what?
Teachers are allowed to have longer names, and therefore my math is wrong.
Chad.
Fuck me, man. That's why.
Kind of a power move, to be honest.
Logic.
This is great.
What is greater, the power of teachers to have longer names or the power of non-binary people to break an entire database?
Yeah, so we have 2,000 of name, code, and grade. So that is 2,000 records, consisting out of 2,000 times. And again, student name, which is 40 characters. What else do we have? Code. So, or actually it's 20 characters, 40 bytes. Code is a char 6, so that's plus 12. And what was the last thing we took? Grade, which is a char, so that is plus 2. Again, keep in mind, a char is a char 1, is 2 bytes. And this will be equal to, actually let me calculate this is 54 54. $108,000, so that is. Okay, so we have this amount of bytes. Now we can calculate the amount of bytes per record. Or, actually it's a record per block, my bad. That is 9, and then we can have the amount of records divided by the amount of records per block will give us the amount of blocks. And that is 278. Can somebody check my numbers? I expect them all to be correct because I am very, very smart. This is sarcasm.
Something's wrong with I4.
I4.
It should be 223 blocks.
223 blocks. That means I either fucked up something here, or with my counting of amount of bytes. And it's probably I probably fucked something up in my counting of amount of bytes.
No,
oh no, I fucked up the this one. Yep.
Yeah.
Hey, it's 223, guys. Woo! Woo! Again, yeah. Again, I've been busy with this for 3.5 hours, so.
It's lit, yeah.
Exactly. All right. So I'm going to take this and put it in the feed sheet channel as well. The reason I'm doing that is because we will actually. It's actually a surprise tool that we will need later. Decide which algorithm implementing the highlighted operations is optimal by computing the costs in combined block accesses for both reading and writing blocks of all applicable alternatives, and select the cheapest one. You can skip any alternative. You can convincingly argue that it's guaranteed to be bad. However, if you decided in the previous question that attributes to be indexed. Wait, no, we actually, we have to actually use.
Yeah.
Yeah. Show that using index indeed cheaper than block accessing and not using it. It must be clear how you obtain the result. The available algorithms you can use are relation scans, index scans, block less than tube joint, index less than tube joint, and merge joint. And only the root node is always in main memory. Okay, we're gonna start out with the first one. So that's this thing. Let me copy that over. And all we care about is the amount of records. So we have 500 records. Actually, do we? Yeah, because these all just use intermediate results. Here we have... Or actually, never mind. We probably should keep this. Okay, so for figure 1, this one. Let's see. So we have a relation scan and an index scan. And an index scan is only faster if the thing is indexed, right? And for all other purposes, we should use a relational scan. Or...
I mean, you can't index scan on something that isn't indexed, right?
Yeah. Only if we have an index, and I think also then for equality, does an index can also work if we have inequalities.
Sorry, what?
So like, index scans are good if you have an index. However, are they only good for equality? They're also inequalities then.
It depends which index you use. You can use hash index, no index, or binary index. Or
Yeah,
like,
okay,
what
that's
was it
fair.
again?
Yeah, okay, that makes sense.
No, not binary index, binary. I'm dumb.
Yeah, no,
it
the
is-
tree index, like the
yeah,
B
that
trees.
one. So B, hash, and no. That's it.
Yeah. For somebody asking why do we round down the number of blocks like
Because there will be
yeah,
a
okay.
certain
So they
amount
are
of empty space.
yeah, so
in the
they
block.
are over here they say records are stored row-wise using fixed length without spanning between blocks. So that means that every block contains as many records as it can fit until there are not enough bytes left to fit a whole record, then it doesn't chop them up or anything. It just takes the whole amount. So that's why we floor it. We round it down. Okay. Somebody sent me a controversial meme.
Okay.
To be fair, they did change the book when I alerted them that not everybody fits in the category male or female. So they were doing that right. Oh, that's the answer.
Didn't they fix it in the wrong way?
Well, yeah, no.
A lot of teachers haven't updated their lecture material in like the past 16
I
years.
mean, that
Wait,
was
what did they change wrong?
That was RNL where they changed it into genes, but I mean,
Yeah,
yeah,
but there was one that now includes like some of it, but not all of it.
Yeah,
I don't know. They're making an effort, and that's nice.
Yeah, I appreciate the effort.
Yes.
What happened was like in the RNL book they said that the union of the set of all people who are male and all people who are female is the set of all people. No, because then you're not including non-binary people. So I sent an email and they said, okay, we'll fix it. And then they say, okay, the union of all people who have XY chromosomes and have XX chromosomes are
Yeah.
the set of everybody. And that's still not correct because intersex people exist and they have like XXY
Yeah,
or
XXY. Yeah.
or I don't know, something else.
Yeah, XXY.
So you can have others as well, but primarily XXY, but there are others. You can have XXX.
If we should bully the professors enough, eventually they'll change their ways.
Based.
I mean,
This is a university, and we are the peers in the word peer-reviewed.
Based.
It's
Again,
not the way this
try
is supposed to work. It's just the way it will work.
Because database about using gender instead of sex, and they just were like, we can't change that. No, sorry, it's in the book, so we can't change it.
It's in the book, so we can't change it.
Stupid.
Buy a different book.
It's one word. Change using one word to be more not just like sex. I think it's just like it's not accurate. Like you wouldn't record an employee's sex. You'd record an employee's gender.
Yeah. Anyways, let's continue.
Let's continue. Yep. So, using the highlighted operation. Oh. Wait, no, that's everything. Fucker.
I think they mean the joins, or is every join highlighted the same way?
Everything is highlighted.
Then we gotta compute the best cost for all of them, I guess.
That's so annoying. Whatever.
I mean, for projections, there. Do you need to compute for projections? I mean, that's gonna be the same as for selections, right? It's just a scan over the entire thing.
Yeah. So scans are either for projections or.
No, I think just for for selections. Because for projections, you gotta go over everything anyways, and that's gonna take the same amount of time anyways. So. Because projection is just, hey, this tuple, I chop off this stuff. Next tuple, chop off this stuff. Next tuple, that doesn't change no matter how you do it.
Yeah, true. But it is still like
it's just selections.
Yeah, but like for like there's this still is included within the total cost, right?
Yeah, sure. The total cost, sure. But the thing is, it's not going to change the output of what you're going to use.
Yeah. Okay. So starting with this tree.
I would really recommend getting all the formulas on paper here so that you can just copy the formula, fill in the numbers, and put it in a calculator because you're going to use them many times.
I mean, I'll add them to a list as we go.
Sure.
So let's see. We're starting out by courses. It starts doing a quarter is equal to 2. Well, that will just be a relational scan.
Yeah, but you gotta do both a relational scan and an index scan.
Well, no, we can also just say quarter is not indexed, so a relational scan will be better. Actually,
will be the only way.
Will be better.
Okay.
So,
I think they are all indexed. It said in the question that the attributes are indexed with a B plus tree that has only the main root, like the root in the main memory.
Actually, if we go to here, it will say where. I seen that as well, but I'll have to find it real quick.
Below. It's lower.
More below?
Yeah, more below. Here.
Ah, yeah.
You can assume that all attributes are indexed.
All attributes. Okay, I thought it was only the primary key ones.
No, just all.
Okay, fuck. That's a lot of indexes. Why would you do that? Okay.
So that you can easily access everything.
Yeah, okay, but why would you index something with only like 4 distinct values?
So that you can easily go from like, hey, I've got this value. What else has this value? That's very quick now. You just go to the bucket and check. Or would that work that way?
Yeah,
no,
but it does have buckets. Are you using B+?
Oh, for B+ trees. Yeah. I mean, if it's indexed like with a B+ tree, and you want everything that has like 1,
Yeah, okay.
you can still go to the leftmost thing and keep going until you find a 2. That would still be the fastest way to do it.
Yeah, I guess, fair.
Like
Okay, let's have a look. So we're going to look at scans and scans with conditions.
What you want to know is for B+ trees, the index is, I've got it somewhere here. It's 0 if the entire tree is a memory. If only the root tree, or if only the root node is a memory, I believe it's 1 or 2. I'll have a look for you real quick.
Cost IX is equal to assuming the root.
Yeah, height of 3 minus 1.
So it's height of 3 minus 1, so that's going to be 3.
No.
Wait, no, actually,
What's
let me.
height of the tree?
Didn't it say tree height is 2?
Oh, yeah, true.
Yeah,
Okay, so it
height
costs
2.
only 1.
Yes, but it is amount of tuples times IX plus 1. So the cost for a index scan is going to be 2 times the amount of tuples.
Wait.
Because you go from the node which you have, you go to the block where you kind of split things up, and then you go to the value. So you have 2 block accesses.
Okay, wait. So we have. Let's see, a relation scan.
I believe this is in the stuff I posted in VC channel, but I could be wrong. Yeah, it's in the stuff that I posted in the VC channel.
Is on ordered attribute. Okay, so if it's not a primary key, we can't use the binary third, so then it's just the amount of blocks. And otherwise, it's the 2 log of the amount of blocks. Okay, and then for the cost of an index scan is the number of tuples matching the selection criteria times the cost plus 1. So we have, I'll call this cost underscore IX is 1. And then we have matching tuples times cost IX plus 1. Oh, my bad, there should be an underscore. Is equal to, and then we can go here. So on this index scan, we have 500. So it is 500 times 2 is equal to 1000. So the cost for this index scan is 1000. Then the cost of this thing is also 1000, or is 500, because this is just iterating over the entire thing. Actually, would it be 1000, or would it be 500 or 1000? Because 500 for reading all of them and 500 for writing all of them.
I think the values for writing them are included in. So if you look at the picture which I posted in VC channel, you will see that the cost of an index scan is hold on, why doesn't? For some reason, my Discord sometimes just doesn't like cooperating. So yeah, for a scan that isn't writing, I think only for joints you will have to factor in the writing cost, because.
Oh, they just update, I guess. Either way, we will use this slide. This is the one you posted.
Yeah.
In the answers, they do add like the intermediate size, because this kind of makes sense because you need to save it somewhere. But on some exams they do count it in some they don't. So yeah, I don't really know. But I think if they say that add the result of writing back,
Yeah, we should really take note of it. Like, I assume here that we don't need to factor this in.
I think they don't mind either way.
Whatever.
I don't know. It's difficult.
Also, the binary scan, it literally says we can't use it, so that's good. We don't have to worry about that. Okay, so we've done this part, we've done this part. This one we'll figure it out. And then we have the intermediate result. Yep. Then we have this join.
I would say, hold on. Maybe because like in the bottom one, you see writing L1. Like scroll down a bit. So operator T32. For some reason, L1 is in the thing there. So maybe there you have to factor in writing it down. The other one you don't. Yeah, I think that might be the case.
Yeah, let's just do that. That sounds reasonable.
It's reasonable enough that we can do it now to understand the theory.
Exactly. Then we joined L1 on course install by. And we have the choice
also-
out of...
I think there was 400 matching tuples and not 500.
Let's have a look. So this is the one for... Yeah, so this is for the top one. For this one. And yeah, after Q2, we still have 500 matching tuples. It's 400 for this one.
Oh yeah, sorry. Okay, never mind.
Yeah, no worries. So yeah, looking at this, we can choose from either block nested loop join, index nested loop join, or merge join. Merge join is only suitable if it is sorted, so that when we are working with the thing is, course install by, like, can we assume it is sorted on the primary key?
Well, it's in a B plus tree, isn't it?
Hmm.
Or what are you talking about?
For merge join, like SML. Like merge join only works if the attributes are sorted.
I mean, they're going to be sorted on the primary key.
That's fair, but then when we have our records, these 500 records, will they be sorted?
It depends. What's the original thing on? If the original thing is sorted, I think our final result will also be sorted.
That's true. Then I think this might be sorted.
I think the thing is, what do you call it again? In place? In ADS terms?
Yeah.
Yeah, that it doesn't scramble shit. I think all our scans and things are that way. I don't know, but I'm guessing that it's the case.
Yeah.
This is definitely the most hand wavy fucking thing that we've ever done, but you know, this is a very hand wavy subject.
Exactly. I understand. Like, the thing is, it's like it has a 95% passing percentage or something. But it like when I'm doing this, it doesn't make me feel like that. All right. Either way,
Maybe this year's gonna be like 60% and rip. You know.
Either way, I don't need this, but then I have to do it again, which I really don't want to do. Like anything but that.
As we can see here, you can technically learn the entire course in like a day.
Well, no, you can learn everything you need for the
like,
assignments, but because they made it so that the test is practically the assignment, that's fine.
Yeah.
The whole course, like stuff to do with grade and shit, no.
Also,
wait, I'm curious. Who here started studying IDM today? Who here did not
I
today?
mean, I didn't do anything since week 3.
Yeah, same.
I watched the lectures and took screenshots of the most important slides. Or didn't watch lectures. I went through the slides and took screenshots of the most important ones.
Honestly, that's
it.
more value than actually watching the lectures.
I went through like the first lecture until Crystal said, "Hey, I will go over like detours are very important because they are very important."
They teach you stuff that you will need later. Yes, okay, I don't give a shit.
Yeah, so then I went just through rewatch everything at 2x speed and I skipped the detours.
Yeah. Yeah, the moment it goes like these detours are very important for this course. You will need to study them carefully. I just dropped out.
Dropped out, of course. Okay, let's focus on the thing real quick. So we
I just
have
started watching the movies.
mood. So we have course.by is being joined with a list of IDs. These are both sorted. So let's have a look. And again, I think it does matter which is to the right and to the left. So let's see, we have courses.by, which has a number of. So it's number of blocks within courses.by. Let's have a look. Course.by blocks is 81, so it's 81, and then the number of blocks of our intermediate result. Well, luckily we have that as well. So that is 5 blocks. Can we swap these around as we want? No, right? Because they are in an order here. Yeah, I'm gonna assume this is left, this is right.
We can swap them. Summer, I think, mentioned that if you can like use the fact that join is symmetrical in a way.
Okay, then we'll do that.
But I'm not sure.
If you're joining, like, it does matter. Like when joining, it does matter which one is R, which one is S for speed, but you can just pick which one is R and which one is S.
Okay, that's cool. That's all I wanted to know. So let's see. We have index nested loop join here. We have the search, the sorted merge join here, and we have the block nested loop join. Again, the cost of result is equal to the number of results that you get out of the thing. So we have those already, right? So when we look at the assignment, we can see that the number of things we will get out of this join is equal to. Let's see, where is it? That's the start of here. That will be 1250. So we have. I'll actually write this down. So blocks left is equal to 81. Blocks right is equal to 5, and the cost result is equal to this. So then we only have to find out what the least number is out of all of this. So we can have the SMJ, which is going to be equal to this plus this plus this, which is equal to, like, I'm very lazy, 1336. Reverator, what do you mean? Somebody asked in the chat, by the way, isn't it 1005 because you need to store them before the join?
Well, no. Why would you need to store them before the join? You're not writing like that. That's you just keep that in memory. I guess I don't know if you can keep the entire thing in memory.
So this is what I was talking
for the
about.
index scan of L1. Also, the relation scan of L1 is 405, which is faster. The relation scan is just the number of blocks for this one. So let's have a look at that. So the relation scan of blocks of R, though. So wouldn't this be, if we use the relation scan on this one, wouldn't that just be a cost of 2000? Oh wait, you're looking at record. That makes sense. So it is the number of blocks. So when we have 2000, but when we then we have to look at the amount of courses per block. Or wait. So we have to look at the number of blocks. when we're looking at all of courses, that is 400 blocks. So then just an index again would be 400. Huh. Yeah, you're right. So in this case,
because of the low amount of tuples here, you actually have to do all of the calculations.
relation scan 400 blocks plus 5 to store results. 405. So use relation scan. Okay. Cool. And then, so we have looked at the sorted merge join. We can look at the index loop join, or is that what it's called? Index nested loop
For
join. That was it.
sorted merge join, I don't think we're supposed to use it because it's not sorted on the same attribute.
I think it is. So wait. So let's see. We can assume. I think they said somewhere that we can assume that courses that things are sorted by the primary key, or no?
Yeah, but their own primary key.
Yeah, but courses is sorted by.
Yeah, but courses.by has a joint primary key.
Yeah, but,
so the thing is,
Okay, I don't know. In the solutions, they say for merge join, the two tables need to be sorted first. They don't need. They. I guess they mean that it's not sorted by the same attribute. So like when you join it, the attribute that you're joining by, it's not sorted the same way in both tables.
Yeah, I mean, if only course ID would be
you
a primary key
understand,
here,
or
then
are you
yes,
still confused?
then it would be then it would be true. But I guess because both of them are primary key and it's not like it's sorted at both of them at the same time, then I guess it's gonna be.
It's very weird how both of them are primary key in my opinion.
Yeah, I guess it's like a joint primary key then.
Probably.
Yeah. Anyway, thanks for mentioning it because they are both primary keys. They're not sorted in the same way, even though they are sorted. So you can't use you can use a sorted merge join, but you're required to sort them first, which would take a long time.
Yeah, exactly.
Okay.
Because that's what's written in the solutions. Yeah.
Okay, so next one. Let's see. So we have the index nested loop join. So when they say
Also, your cost result is not 1,250. It should be the number of blocks.
Yep.
For the result. Yeah.
So that is let's see, 1,250. But then in this is still let me have a look. So it is about this join, which is yeah, okay, that's only the ID. Then we have 1,250 teacher IDs. Okay, so this will be 11 blocks. Okay, so we have the index index. Fuck, I keep forgetting the name, man. Index nested loop join. It's actually the INL, and that is the blocks of R. So that's which one would make more sense? Big plus big times small, or small plus small times big? Small plus small times big. So we're gonna say 5 times, or 5 plus 5 times 81 plus 11 is equal to 421 block accesses. And then we also have the block nested. Actually, that was the block nested loop join, my bad. And then the index nested loop join, or the yeah, okay, block nested and block nested and index nested. So then for the block nested loop join, or the index nested loop join, we use this. Then we have the cost ix plus 1, which is 2. So then we have blocks r plus the amount of tuples in r times the cost of ix plus 1. We know the cost of ix plus 1 is 2, because we calculated that here. So this is going to be, and again, you would probably use your smallest table for this one. So that would be
You can only use one because I1 doesn't have the index anymore.
Mhm.
You can
Oh
only.
yeah, because you're right, because this thing is not indexed, so we can only index. We can only check it by the grade index thing.
Yeah, the higher tree, but yeah, the same idea.
Yeah. Sorry. Yeah. Course stop by. Okay. So let's see. Course stop by has a number of blocks of. So that is 81 plus. Then we have the number of. With this, they mean the number of records in R, right? So that is.
With what?
That is the size. So yeah.
Uh,
Yeah.
yeah, records. Otherwise, they would put hash block.
Yeah, exactly. So the number of records in the core style byte thing is equal to 5,000.
It's not from course.by, it should be from I1 because you're taking every single record in I1 and using the index in course.by to find the matching tuple. So
But
the number of blocks should be number of blocks in I1, I believe.
But then.
And
Oh, so you're saying R is the one that isn't indexed?
Yes.
Ah. Cool.
Wait, does it matter which one is R?
Yeah, because like it's either the one that is indexed or is not indexed. Yeah, okay, this makes sense. So you're taking for everyone that's not indexed, and you're looking it up in the index.
Yes, to find the matching tuple.
Yeah.
Oh, we're talking IXL. Yeah, no, okay. I thought we were talking about block nested loop. I was like, what does that have to do with index?
No,
No,
nothing.
yeah, okay.
Okay, so then we have the one that's not indexed. So that's our thing. So that is I1. I1 has consists of 5 blocks plus 5 times 2 plus the resulting is equal to 20.
Also, wasn't everything indexed in a B plus tree?
Yes, however, not the intermediate results.
Fair.
Yeah, I had the same mistake. So then when we take this, we can assume that IXL works best. So
Just a small mistake. It's the size is the number of records in I1, not the number of blocks when you're multiplying by 2.
Thank you very much. So that is the number of records in I1, that's 500. So that is actually 1016. So then it is the block nested loop join. Okay. Yeah, sorry if I'm like struggling a little bit. This is honestly, I've done this before, but it didn't go as well as you can tell. But we're getting there. Okay, so we've done this part. Then we can. This part is just scan. So the only part we have to worry about is this one. So again, since this is not sorted, yeah, no, this is not sorted. So SMJ is going to be big. Actually, let me write down the things again. So we have the amount of blocks in teacher is left is 250. The amount of blocks at the right side is our result of R2, which is, or I2, sorry. That is, oh, I did not write. Okay, L2. So the amount of blocks in this one is 11. And the cost result is equal to. So this is the cost of the result is equal to the amount of blocks of the output. So the amount of blocks of the output is equal to 125 records. But those are still the full teacher records. So then would the cost of the result be the 125 full records? So that would be just the entire teacher table? No, even more. Okay, so again, we're trying to figure out what the cost of the result is, which is the this thing divided by the blocking factor.
Won't it just be 157 because that's the blocks you got in L3?
Yeah, but for L3 we have already filtered by email.
Yeah, but you're calculating how much. I mean, you're not just calculating the join. You're calculating everything up to I3. I mean L3, right? So won't it just be
Are we
157
though?
blocks?
Right now we were just calculating the individual operations.
Yeah. Also, wouldn't the amount of are we talking about amount of blocks or amounts of bytes? Because if we're just projecting, then the amount of blocks doesn't, or amount of blocks doesn't change, does it?
No, it does, because the amount you first have records consisting of everything in teacher, and then you have records consisting of only the teacher emails.
But they do,
Yeah.
like in the answers, they assume that the cost of the join is 157.
They do?
Yes.
I guess to not have to reorder everything into different amount of blocks, because then you would have to pass over everything again.
Yeah, I guess. Wow, that's dumb. Cool.
Or maybe they are pipelining this. I don't know.
I have no clue, man. This course is fucking vague as shit.
Yes.
I have no clue. Okay, so the sorted merge join is going to be big because it's so fucking big, and then the block nested loop join is going to be number of blocks in smallest plus number of blocks smallest times number of blocks in biggest plus the result. That's going to be 11 plus 11 times 250 plus 157. That's 2,918. I love how we did the first assignments in like 1 hour each, and this one's going to take a little longer.
Yeah, tiny bit.
Then the index nested loop join is going to be. So we have an index only on teacher, so we're going to have the. Yeah, so the R thing is going to be the one that's not teacher. So that's going to be 11 plus the number of records in our in I2. That's going to be 1250 times 2 plus the result 157. I can already tell that this is probably going to be less. Two 668. So index nested loop join. Oh. Okay. And now the question is, so we've done this part, we've done this join, and we've done this join. Oh, we should also look at the other scans as well, by the way. So everything is indexed on everything. Let me think real quick. So in what cases would a relation scan be better than an index scan? In the case where the number of matching tuples is very big, or you have a really small set, because then this is going to be really small regardless.
Or maybe if the tuples are really big, like if you take a lot of, I don't know, data that occupies like maybe the entire block, right? So one tuple is like the entire block, then also maybe.
Yeah, true. This is so much to wrap your fucking head around, man. Alright.
And that's why we have a two-sided cheat sheet.
Yeah, for sure.
Yeah,
I'm going to copy everything in here in the cheat sheet, and everything in a bunch of other slides as well.
Yeah, I've literally got a fucking notepad of I've got a OneNote, that's the word, page, and it's called shed, and it's just nothing but this. I'm just gonna write this over, and this is gonna be my cheat sheet.
And rightfully fucking so. Alright, so let's see, we've done this one. Well, I mean, the rest is just the renaming of tuples. Do they actually account for anything for that in the answer? Because if not, 2668. Because like I'm sure I'm forgetting something when it comes to writing down the intermediate results, right?
I think you have everything.
I think that's everything, yeah.
So in this case, the answer would just be this plus this.
Yeah, it's just summing everything pretty much.
Yeah, but just summing only these two, it feels wrong.
No, also the scan, the relation scan.
Oh, so also like the amount of blocks in here. So it would be plus this.
No, the first relation scan, because we had
Oh
three
yeah.
intermediate
Okay,
steps.
yeah. Okay, my bad.
Yeah.
So this is 405. Okay, so to reiterate, we need to keep in mind the these things, but not the projections, only selections. So then we have 3494. If this is actually correct, I will cry. So let's have a look at the answers. If we use an index again, the cost will be 1005 blocks. Again, I forgot here to write to take down the cost of storing the results. If we use a relation scan, it will only be 405. For the join, we check out inner nested loop join and block nested loop join, which is what we did here. So this is going to be 421, yep, or 1016, yep. Then again, we do the same thing. It will be either 1981, yep, or 2668, yep. So the answer is correct. Wow, it only took 50 students in 3 hours.
Yeah.
And like 5 tries as well. You got like 7 things wrong, or we all got 7 things wrong.
Yeah.
Sounds about right.
Yeah, fun subject.
Sorry about me forgetting to mute my mic earlier, by the way.
No worries, it happens. Okay,
Did not
operator
realize it
3-1. So let's start with this one. So I'm going to delete this. I'm going to copy this. I'm going to put this in the general VC channel, and I'm going to copy.
But we don't do, or have we already done operator 3-2?
No.
That's not.
Okay, but first I want to check if this, like everything I wrote down here, is correct. So it's 400 courses, 6400 bytes, 13 blocks. Yep. 2000 records, 3600 bytes, and 75 blocks. Yep.
I mean, this is basic math.
Yeah, well, don't overestimate the ability of 50 combined people doing maths.
Yeah, it's actually just the remembering formulas part.
Well, not remembering, because you can write them down. Here, cause here I fuck shit up. I say, oh, actually, no, I don't. Fuck.
You actually did, for some reason,
22, 28.
Or
no,
am I looking?
Oh
at
wait,
the
no,
wrong spot?
this is. Oh yeah, no, I did fuck it up, but that's because I only changed it here and not there. So this would be correct. I just didn't evaluate it. And then here we have 2000 again. Then we have this correct, and this is also correct. All right. I will leave the second part as an exercise to the reader.
Now to the next question, because we're not done yet.
No, Bog.
Yeah, no, this one was just this one.
Oh yeah, yeah. So
Okay.
someone's gonna have to explain to both me and Jura how checkpointing works.
No. Checkpointing is in a detour. We're not gonna do checkpointing.
Oh yeah, true. But they're gonna ask it on the exam. Then we can be really angry.
Yeah, we can be really angry. If we learn it now, we don't have the right to be angry.
Yeah, you don't want to do that.
Yeah, you
Okay,
want.
yeah, that's true.
Wait, what did he say?
Yes, you do have the right to be angry.
Okay, that's true.
I think the only thing they really said about checkpoint was anyway that's a point where they don't accept it anymore. Like it's done. Like they don't check the commits in the log anymore after the check, like from everything before the checkpoint. So that's all.
Okay.
At least there's more explanation, but we don't care about that.
All right. So about transaction management. So we are going to look for conflicts between T1, T2, and T3. I'm going to write them down in a format like. So let's say T1 R. Let's say T1 the W of X interferes with the T3 reading of X because of these two. I don't know if it's actually the case, but this is just like an example of how I'm going to write this down. Just curious, would this actually be the case though? Because it actually comes after this one, but it doesn't matter then, I guess.
No, it doesn't matter which. Well,
But that would be a conflict
you
from
start.
T3 to T1.
Yeah, I was about to say you start with the one that's first.
Okay, yeah, that
Yeah.
makes sense. Okay, and again, read is not a conflict, only read write and write write.
Yeah. So what I do is I just start at the first one. I look at all the other things that aren't in the same thing, and everything that like conflicts with it, I write down.
Yeah,
and that
the
way
other
you
the other things
only-
that aren't in the same thing. No, I get what you mean. I get what you mean.
the other transaction. No, the other fucking. What do you call those things?
Read write operations.
Yeah,
whatever that.
All the other I look at all the operations in front of it that aren't in the same transaction, because then that way, if you look, you don't have to look backwards. Because if you do, you'll count each of them twice.
Yeah, exactly. That's genuinely a pretty good method.
Yeah.
So let's start with this one. So we're gonna look at T1 RX. Well, it's a read operation. Anything can happen after a read operation.
No, if a write happens after a read operation, it's still a problem. Read and then write is still a problem, if I recall correctly. Only read is not.
Yeah,
a problem.
yeah, okay, fair.
But there is no write currently for X.
Yeah, okay.
But you should remember that read write and write read are both bad.
Yeah, okay, good point. So there's no write X after this. RZ. There is a write Z, but that's in the same thing. So that's no problem either. RZ. So here's a read of Z. I should decide. Am I going to call it Z or Z? I'm going to call it Z. Here there's a read of Z, and here's a write of Z. So that's an issued from T1 RZ to T2 write Z.
When all is well and said.
Then here we are.
Do you want to get some used again?
No, it has to be said.
So here we do. Here we read X, and here we write X. So that's also an issue. Write X. Then here we read Y, and here we write Y. So that's T3 read Y into T2 write Y. Then here we write X. Do we do that anywhere else? No, we don't. We don't read it either. Here we write Y, so that's going to be T3 to write Y to T2 write Y. Here we read Y, we write Y, we write Z, and we read X. So what we can then do, we can put it in a little graph, little neat little thing here. We have T1.
That's wrong. Woo.
T1, T2, and T3. So from T1 to T2 there's a conflict. From T3 to T1 there's a conflict. I mean anyone with like more than, wait, let's see. So then from T3 to T2 there's a conflict. And there's another conflict from T3 to T2. So I'd say that this is conflict serializable. Now I will go to the answers to check if I'm correct, because I am very insecure.
Oh, this is right.
Let's go! We're gaming, guys. Absolutely fucking gaming.
Wait, so I'm confused. I've never seen this before.
Wait, you haven't?
No, like, why is there a conflict between like T3 and T2?
Alright, so if we look at T3 here we write the value of Y.
Yeah.
Then here we write the value of Y again, overwriting what happens here.
But look at the time. It
But you read it after
it reads
it's
after
written,
it's
right?
written.
It doesn't matter, because this isn't about the current state. This is about whether you can move the stuff around so that it's conflict serializable. So it's not just about the current state.
Oh, you just need to look at what things are possibly in conflict with each other.
Yeah.
So the things that can possibly conflict are that read or the read from R3 and the write from R2 or T2, and the write from T3 and the write from T2.
Okay, and
So
it's
those-
serializable if there are no things that no arrows that go towards each other or something.
Yeah.
There's
So if you graph it out and it would be cyclic like this, then it's not conflict serializable, and now it is.
And it can the cycle can also be like if T2 went to T3 without T3 going to T2.
Yeah. So if we would have this, then it would
It's
still be a
it's
cycle.
Still a cycle, yeah.
Yeah, you had graphs in
ADS.
ADS cycles. Cycles there are cycles here.
Whoa, ADS is useful.
Whoa.
So if there are no cycles to be going, it's serializable.
Yeah, if there are no cycles, it's serializable. It's conflict serializable.
Yeah. Okay.
Okay. Let's get rid of this. Let's get going. So for this one, let's start out. We have a reading of x here, and here a writing of x. So T3 reading of x into T4 writing of x. Then we here have a reading of x and a reading of x, but that's okay, so that doesn't matter. And here we have a reading of x and a writing of x, but they're on the same track, so it doesn't matter too. Here we have a writing of x, which matters because here we have a writing of x, and here we have a reading of x. So T4 writing of x into T3 writing of x, and T4 writing of x into T2 reading of x. Furthermore, here we have a writing of y, then we have a reading of y in the same tree, doesn't matter. Here we have a reading of y in another tree, that does matter. So T1 writing of y into T2 reading of y. Yeah?
What's the question here? Is it conflict serializable? No. T3 goes to T4, T4 goes to T3, done.
Yeah, but draw the conflict graph.
Conflict graph, there is a cycle. No, okay, I get what you mean. But like,
yeah, and even if it just says so, I will still do it all. But that's just because
it's good practice, but you should just be able to look at this and just know this isn't conflict serializable.
Yeah, correct. Either way, let's continue. So after this write, there's only this read here, and nothing else happens with y, so we can ignore it. After this read, there is this read here, and nothing happens with y, so we can ignore it. Good. After that, we write z, and here we write z again, so that's a conflict. So we can say T2 write z, or actually, sorry, my bad, T3 write z into T4 write z. That's a conflict. Here we write x, after that we read x. That's a conflict again. So T3 write x into T2 read x. And apart from that, nothing happens with x. Here we read x, nothing happens with x.
There was also a conflict between T3 and T4 write z and read z.
Oh yeah, so we have T3, so we have write z here, and also we read z. It happens after it, but it's still important to take into account. Thank you very much. So then after this write x, we have this read x, nothing happens with x. Then here we have this read z. So that's T3 read z into T4 write z. And here we have T3 read z into T4 read z, but reading into reading is allowed. And then here, after this, nothing happens. So this is the full list. Let's make a little cyclic graph out of it. Or let's hope non-cyclic, but T1,
On the
T2.
side, I don't think that reading after writing was a conflict.
It is, if I recall correctly.
Let me have a look then.
Let's check the answer.
Wait, let's first make it then, and then we'll have a look.
Yeah.
So I'm gonna take this out of the way.
Because I believe if
so we
it's
have
only not an answer if it's just reading. I think if the order doesn't matter for whether it's a conflict or not.
Yeah, because I do remember something like with a table like this, with just like this is a conflict, this is a conflict, this is a conflict.
The only thing that isn't is read
I'm
write.
getting a sore throat from all this talking. Give me a second.
Also getting a sore back from carrying us all through this subject.
Woo. I mean, true, but still.
Who, you or me?
You.
Fair.
Man, I've spent the past 3 hours browsing Reddit and watching RimWorld videos.
Hey, I'm playing RimWorld!
Nice.
Nice.
I'm trying to do multiplayer, but it's like fucking garbage.
Oh no! I just started a new organ harvesting place.
And hello YouTube.
Hello YouTube.
Yeah, no. I've got
Hello
my.
YouTube. We're British now.
I custom made myself a psychopathic, beautiful cannibal.
Nice.
Wait, I got a message saying, why is T something WX to T2RX? So that is, I guess, wait, to T2RX?
That's
the third line, maybe? Or the
this one. This one,
Oh,
I
yeah.
think. Let's have a look. So it was T3WX to T2RX. Yeah, this seems to make sense. So this one is interfering with this one. Shouldn't it be T3 instead of T4? Yeah, but I wrote T4. Oh, then you mean this one? Wait, no. This one. So this is about this thing going to this one. There is also a conflict of this one to this one, but this one to this one is also a conflict.
Yes.
Do you understand, Zaza?
Do you understand?
Wait, not typing, so I assume that's a yes, because I am very good at explaining stuff.
I also don't understand one thing about it. Why we have T3 right Z towards T4 right Z?
This one?
Yeah, and not the other way around.
Because here it starts with T3 writing Z, and it ends with T4 writing Z. So because this is earlier in like the schedule of Vanessa, right? It's first this one and then this one.
So you always like on the left you have the thing which is before in the timeline.
Yes.
Yeah.
On the right is the thing which goes after that.
Yes.
Yeah.
Okay.
And that's also the direction you draw the arrows.
Yeah.
So from the thing earlier in the timeline to the thing later in the timeline.
Yeah. Okay, let's draw this thing real quick before we get sidetracked again. So this thing is here. This thing is here. Oh, I wonder if it's cyclic. From T4 to T2. From T1 to T2. From T3 to T4. Already there.
Already done.
From
3 to 4 already there. 3 to 2.
Yeah, so 3 to 2.
And that's it.
And yeah, 3 to 4 again. And if we were to like actually write the whole graph, we would write it down. I'm not sure if it's actually required, but we could say Rx, Wx, and then like write down for everything what it is, so you can also see the different conflicts.
Mm-hmm.
And
I think that might be actually required in a normal one, but you know, fuck it.
Yeah, like as long as they don't ask you to upload it, you should be good. Yeah, okay. So I think this is it, and then we can see that there are so in the top half there's like no cycles at all, because everything just goes to one point, but in the bottom half you see there's a cycle here. So it's not conflict serializable. Let's have a look if the answer sheet agrees with us.
Yes, it does.
It does. We are gaming. Alright.
Okay. Now we can do logging and checkpointing, although they said checkpointing was a detour.
Yeah.
So we're not gonna do it.
We're not gonna do checkpointing.
Well, we can do undo, which is...
Yeah, we're gonna do undo redo. We're just not gonna do checkpointing.
Well, it only says undo.
Oh, yeah, well, okay. But here it says undo redo, but let's do undo, yeah. Sort the actions of the recovery manager and explain why. The undo log using non-blocking checkpointing contains the following data. Show the actions of recovery managing during recovery and explain why.
You only do from 9 to 11. No, wait, what? What the fuck? They have so many starts.
Yeah, there's 3 different things. Wait, so we only, as you can see, the only thing committed to the disk is T1.
So you undo T2 and T3.
Yeah.
So you walk from 11 backwards, undoing everything you see on the way.
Yeah, so first we would write 15 into Y, 13 into X, then 11 into Z, 9 into x, and we leave the rest because T1 has already committed.
So what I think the checkpoint here does is that you don't read before, but we have not learned, so we just ignore the checkpoint.
Exactly. Okay. Then we have the database management system running the following transaction, blah 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 blah. Column marked as T contains the current value is the local variable T. Mem A is the local resource A. Disk A is the resource on disk. Commit T, start T, and the other stuff. Cool.
There's no log. What the fuck?
Yeah, we have to rate the log ourselves.
So first, let's fill in the question marks.
Yeah. Also filling the missing value whenever you see a question mark. Let's do that first. So here we write. Let's see. So we write T to B. We write T to A. Then we read B into T. Well, because this is the B on in the memory and the most recent B, that will be 15. And you can think of it pretty logically, right? Because if you write B and then read it again, the value should not differ. It would be absolutely stupid if, because we didn't commit it yet, which is not something we actually control, the value would be different when we read it and write it again. So here it will be 20. Here it will be 20 again. Log will be flushed. Here it will be 20 still. Here it will be 20 still. But then this will be
20.
Yeah. So output A will write the value of 15 to the disk here. And here T will be 20. This mem B will be 20, and it will also write it to 20 here. So that's good. Let's see what else. So here above here, I think we let's see.
We start there.
We start at the very top, or do we start here? Or like here?
We start at the very.
You start before the first read.
Yeah, you start at the read. So you start above the read.
So we start above the read.
Then you put logs at both the rights with the old and new value because it's in the redo.
Yeah.
Oh, the start. Yeah. Okay.
Yeah. So here we say start T, and here we say T, comma, and let's see what was it.
T, B,
and then yeah. So
we don't know the old value, right? Oh, we do it. Okay, so it's T, comma 5, comma 15.
No, TB.
Or T. Yeah. Sorry. T, comma T, comma 515. Yeah. Here we say T, comma T, comma, or actually
T, comma A. And
then, yeah, T, comma A, comma 515. Yeah. Okay.
Yeah.
Then let's see.
Another write for the B, which is
T B 1520 or sorry.
Yeah, 1520.
Yeah, 1520. Yep. And then here we flush the log.
And then at the I think so. It's an undo log. So
it's an undo redo log.
Is it an undo redo log?
Yeah.
Oh yeah. Then it doesn't matter where you put the commit.
Nope.
But
I guess here, right?
No, yeah, it's either before the output or after the output. It needs to be before the flash log, though. That's all that matters. Before, as long as it's somewhere before the last flash log, it's fine.
The last flash log or both of them?
Last.
Actually, as long as it's after the second write.
Well,
the third write,
of course. It just needs to be somewhere around the writing to disk. You can either do it directly before you write to disk or directly after you write to disk. It doesn't matter because it's undo redo.
Okay, so let's say we just commit here, and
even if you do put it before the last one, as long as it sees it's committed, it's gonna redo it anyways because it's committed. Because it's undo redo logging.
Yeah.
Undo redo logging. If something isn't committed, it undoes it. If it is committed, it redoes it.
Yeah.
So you can even put it before the first flash log, I think.
Yeah, it really does not matter.
Yeah.
Can you explain what the flash log does?
It writes log to disk.
Okay, makes sense.
So if there's no flash log, like imagine it crashed here, then all of this would be non-recoverable.
Yes, but it doesn't matter.
Yeah, but it doesn't matter because we're not writing anything to disk yet.
Yes.
No,
Actually, if there, yeah, no, indeed, true.
I see. Okay, interesting. Let's see if we were correct. This one. So we have, yeah, okay, this is what we had. So we had from top to bottom this one, this one, this one, and this one.
Mm-hmm.
And it seems like, oh, since there is no end checkpoint, it's not committed. No
idea what that is, but cool.
Me neither. Let's go. Okay,
Let's
so
go.
here we have the 15, 20, 20, 20, 20, 20, 20, 20, 20.
They just put the commit in the middle of the outputs, the chads.
What fucking Chad?
Just throw it down somewhere.
I mean,
Yeah,
really
and here we have, as we said before, we start D, we write B, we write 15 into it was 5, we write 15 into A, it was 5. We write 15 into B, 20 into B, it was 15. We commit it, whatever.
Scroll up a bit. We are now showing the next task, which we haven't done yet.
Yep, noticed. What order will the recovery procedure do if we pull the plug right after the first flush log?
It will undo. We will undo everything.
Yeah, everything
from
will
bottom
undo.
to top.
Yeah.
From bottom to top.
So it will undo this right, it will undo this right.
It will write
this
15
right.
to B, then 5 to A, and then 5 to B.
Yep. So let's see. Kind of spoiled it already. 15 to B, 5 to A, 5 to B.
I mean, you literally just read the logs backwards. It's not that difficult.
Exactly.
Right. I think we should also
speedrun
do
the IDM.
Stuff quiz. Is that still up? I don't know if it's still open. Is it? Does anyone
I think
know
it's
if that
still open.
stuff quiz is still open?
So what we're going to do
The quizzes
is
are open. Yeah.
The quizzes? Yeah, it's still open. The quiz is still open.
Okay, then we're gonna do the quizzes probably. Right?
yeah,
Eva?
the practice quizzes. We're gonna do these 4.
There's
And
4? I thought there were 2.
No,
there's 4.
like they were opened like 8th of April.
Oh wow! Then that must have been a new thing. Okay, cool.
I mean, quiz
Aggressive.
4
Let's go.
Quiz 4 is a summary. Quiz 3 is about the transactions and other things.
Yeah, let's just go for it. We'll see how long it takes.
Yeah.
Maybe they're short. Are they short?
short.
Does anyone know?
Yeah, they're short.
They're quite short, I would say. I mean, it
Yeah.
depends on how
Estimated
knowledgeable
required
you are.
2
hours.
Fuck!
I mean, it literally depends how much understanding you have for the.
Yeah.
Well, we have 50,
Yoga,
we have 50
Yoga,
people
Yoga.
worth of understanding, yeah?
Yoga, this is important. Bring out the live split.
You're right. But do we do like all percent or just the different split?
It is 4 o'clock. We still have 3.5 hours to work before 8 o'clock, and we still need to make food. It's any percent.
No,
Yeah, okay,
this
but
is
we do all of them, right?
This is.
Let's do all of them individually.
Yeah, but like finishing all of it is when you finish the game. So any
Okay.
percent would require 2 of them.
Does the projection apply duplicate elimination? No.
Yes.
No.
Yes.
Wait,
does.
no, projection does. Yes, selection does
Yeah.
not.
So
okay.
projection, yeah.
Projection just.
Oh yeah,
removes
okay.
the
Because,
other-
Because the output is a set, and
Yeah,
sets can't
sets.
have duplicates.
Yeah.
okay, cool.
I got baited there as well.
Consider the following. Oh.
Okay, well this is not too bad. So select movie title, cast name from movie, join cast on the thing, where movie production year is 2010, and see the role as writer. So let's see. Let's start with this
I'll say
one.
the last one.
This
because
is
it's
this
short.
is not correct because it only selects title. This
Oh
one.
yeah.
Seems alright. Could be wrong.
This
Looks
one
alright.
seems alright. What
Yeah,
about
and
this
the third one also. It's just like in the schema, they just moved the selection up a bit. So the top one would be after
one-
the heuristic hill climbing.
No, the third one is or, not end.
Yeah, here it says or. Okay,
Oh yeah, okay. Pieces of shit, cunts.
based. Page 2. Consider
Oh,
owner
look at this,
relation-
look at this, Claudia. I can go back to previous pages.
Oh yeah. It's almost like there was an easy option to turn on.
Tyfus liars.
Okay, so we have student ID with SID and S name. We have reserve with SID and RID and time, and we have student room with RID type and position.
It's a student named Sid.
Oh yeah, Sid. Okay.
So I'm just trying to get my nuts.
What is the result of executing the following relational algebra expression? So we select Sid from all the
Big
rooms.
Yeah, but this is a natural join, right?
That's
Okay.
join, yeah.
I mean,
So
we
this is
still care
this is
only
just
about
all the student
stuff.
IDs that reserve big rooms and all the student IDs that reserve small rooms.
Yeah, and yeah.
Yeah, the entire thing.
So this is everything. So a big room or a
It
small room.
returns, the
Oh,
IDs.
and I think it's end, right?
Yeah, you just can't breathe. Or,
Oh yeah,
no,
I can't
union.
breathe.
But this
yes,
is a- Is that
It's
a
intersection. It's intersection.
It's an intersection.
For
Yeah,
intersection,
I
you
thought
have
it was a union as well. So it's the IDs of the students who have reserved a
Yeah,
big and a small room.
if you're wondering what it is, it's the same. Like in how in math, it's x is 1 or x is 2. These have the same shape.
Yeah. So
They
it's
look
like this is
like big
equal
boys.
to this.
Oh, a lot of mathematicians are angry at you right now, but you're correct.
I mean, you can literally just.
How to explain math and logic.
I just remember it because this kind of looks like an N, and the other one looks kind of like a U and intersection and union.
Yeah.
Fair.
Okay.
I just
a cross
remember
product
N because
is
it's
a
N-Bay. Giga brain.
a cross product is a binary operator because it takes two
what
different tables.
A cross product.
Yeah, if it was a natural join,
it would be a ternary.
Yeah, because you also have the what it joins on.
But a natural join is a binary again.
Yeah, because natural just assumes.
Yeah. Cool. Next.
Consider the following table contains the result of a relational blah 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 blah. Which operator could produce such a result? Well,
there's nothing empty, so it's not a left outer join.
Cross products.
Yeah, it's not it's not left outer join. It's not a natural join because oh wait, no.
The dep
Emp
ID,
ID takes department ID.
Yeah, dep ID and department name are literally just multiplied because you see 1, 2, 1, 2 logic. Just
it looks like a cross product.
It looks like a cross product, yeah.
Yeah, cool. Consider a database of the following three tables, blah blah blah. Which of the following statements is wrong? Selecting the CNAME, balance from the natural join of customers and accounts is equal to selecting the CNAME, balance from selecting the CNAME from customers, join selecting the balance from accounts.
Wait,
this is impossible
how
because
are you gonna?
You're not gonna join when you've already filtered out the join conditions.
Yeah, you can't join. Like the first one only creates a fucking. Like it creates a single row table or column table, and the only table is column, and the other only table is balance. And I would love to see you join balance on a name.
Based.
Yeah, no, that just looks wonky. Also, aren't the brackets completely fucked? Yes. Oh no, wait. Actually, never mind. The brackets are fine. I didn't see the opening bracket in the middle.
Yeah.
I just thought it was select CNAME balance from select balance from customers. What? No, but yeah, that one's wrong.
Okay, this one is correct because you can split up these things. This one is correct because this whatever makes sense.
Yeah. You chop off everything but the name and the city, and then you chop off the city.
Yeah.
Yes,
and
in my
this
head,
one is correct as well because again they're just doing one too many. Which one is the following statement? Equi join is a special case of theta join. I have no clue what either of those words mean.
Theta join is just a conditional join.
Yeah.
Oh, okay. An equi join is a natural join.
Equal join is something where they're equal. Like A equals B, and the theta join could be A greater than B.
Where ID equals B.
And this one can be produced by a relational projection because a projection creates a set, and a set are
able for duplicate.
Yeah.
No.
But it outputs twice.
Yeah, Bob and Bob. So that can't be relational because it's set and set has duplicates.
It cannot.
And it's which of the following statements is true, and we found the true one, so the rest is false.
Yeah, no, but I'm checking anyway.
Look at the bottom statement. All of the provided statements are false, meaning that if one of them is true, that it's directly only that one.
The result of the division operator between tables A and table B has same attribute as A. Yeah.
Wait.
Oh no. Wait.
Division.
Wait, division operator.
It would be A minus a few things, right?
Yeah, but same attributes.
A minus? No, it's not A minus. Wait.
Like, why would they call it a division operator? It's written as the division operator, but I don't think it's called a division operator, is it?
I think it is.
Oh.
Is it?
Wait, you say set A divides set B?
Yeah.
What the fuck?
Like, it is...
they have not taught us very well.
Yeah, correct. So if we have R is equal to A cross product B, then A is equal to R divided sign B.
Okay.
Yeah, but then instead of this one, it's actually like this division sign, but I can't type that.
What?
Wait a
It's
second, does that work? Because if
Backwards division
something is
sign.
in both A and B, then that doesn't necessarily.
Let's check that. Let's check it. So in here we had this thing. Where it was very much at the top. Yeah. So import the dataset. So if we have teachers, how much is it? 16 rows. Teachers, we cross product that by courses, and then we divide that by courses. That should return teachers again, right?
I put a
Okay.
picture in.
Oh well.
the-
I was today years old when I learned that set division was a thing.
Yeah, I
So
have no idea
this should
what
return the
that
same
is.
thing as teachers. There we go.
Okay, so the division actually removes all the attributes that aren't in teachers.
Oh yeah, if you look here, then this is like a bunch of attributes, and this is actually only a few attributes, so it doesn't remain the same. So then it makes sense as well. So
You're looking for the fucking right to have.
That one should be true. That one should be true. Wait, right?
Yeah, but no, this one has the false.
Oh,
because it
because
removed
you're
every
removing-
attribute.
Oh,
from
yeah,
each-
yeah. Never mind. Yeah.
Yeah. So this is
It's
false.
basically
This
A
is false.
minus B, right? I think.
one is true.
I mean, not necessarily A minus B, but like.
Yeah, a set difference. If you're talking about set difference, then yeah.
Yeah.
Set difference is
Look
A
in
minus
the
B, and this is A
general
divided by B.
Okay.
Yeah, so like if you look at set difference, if you have like table 1 has like A comma B comma C, table 2 has only A comma B, then you know table 1 divided by table 2 is equal to a set containing, and like these are not actual the tuples, these are just like the attributes.
Yeah, attribute
However, you can only do this, and it will still have a set containing the the attributes A and B. So this only removes attributes, and this also removes like this anti-cross products. Let's say it like that.
They never taught us about that though.
Yeah,
no,
correct.
They didn't.
Actually, fun fact: the only reason I noticed is because last or like 2 or 3 nights ago, I looked in the relational algebra channel, and one of Absolute Chads was explaining this really easily using like this method that I showed this one, and I just understood it, and I was like, wow, okay, cool.
Damn, son.
Yeah. Okay. Disk characteristics: 8 disks, 16 surfaces, a diameter in inches that we're not going to use because fuck calculating with inches.
Inches are fine.
No, they're not.
No, they're not.
It's 4. Read the last 2 sentences.
Let's assume a block size is this. How much sectors does one block contain of? Yeah, so these two are the only ones actually relevant, right?
And they give you the power of the 2.
Yeah, so it's actually so
To
you
the power of
divide this one by this one, and that leaves you with 2 to the power of 2. Assume a hard disk of one surface and a block size of 1 megabyte. The seek time of the disk is 10 milliseconds. We want to read 100 blocks that are randomly scattered around the surface of the disk. Which of the following is correct? The seek time is 10 milliseconds. So then it will take...
Minimum is 1 second.
Yeah, minimum is 10 times 100.
Wait, the minimum is actually 100 milliseconds because they can just be all 100 in a row. The maximum is 1 second.
No, if they are all
Or
in
am I
a row,
wrong?
they still need
No,
to
it should be the max.
The maximum is
Yeah, because if they're all in a row, like you don't need seek time.
No,
Yes,
but the
you do.
question then stated it's all randomly scattered around the
Yes,
surface
but
of the disk.
It's randomly scattered, but random could be all in a row. You don't know what randomly is.
Yes,
Yeah,
but
the seek time has to do, even though if it's at like after each other, it still does the seek time every
Yeah,
single
that's
time.
how I understood it as well. But let's actually look it up.
Yeah.
So
And
this
could
was
be
set
bigger.
in storage media.
Sorted media, yes.
Let's see if I can look for Control F. Seek time.
But I just want to say, like in that slide just now, they were saying what we learned from relational algebra. Division wasn't on there. XD.
XD, dude, it's funny, guys.
Wait, they actually just put
yeah,
in
here.
the answer. It wasn't on
Oh wait,
there?
no, huh?
Just Control F maybe?
Yeah, no, I'm
Yeah,
Control-Fing.
it was on there. Like if you scroll up a bit, not this one, the next one. Up a bit, yeah. Time to position. No.
Oh yeah, this one. Position ahead to the correct cylinder.
Yeah, but that's time needed to transfer a random block.
You know what?
Well,
Fuck it. We'll just enter it. See if it works. Sure.
I'll guess it's maximum.
Wait, where was the thing that we were filling in?
Fourth. Yep.
Transfer time is the position. Is it time to position RW head? No, that's seek time.
No.
motherfucker.
No, that's seek time.
Submit.
We can agree on that one.
Because if they're in the
Submit
same cylinder, do you have seek time?
Okay,
Yes.
this is correct. This is correct. This is correct. This is correct.
And
This is
then
correct. This is
split.
correct. This is correct.
This
This is correct. And this is
Oh,
100%, boys. Let's go.
It is minimum.
Yeah, it is
because
minimum.
Okay.
It could
Wait,
be more because of different.
Yeah, like it could
Ah.
take like the entirety of the spinning of the entire fucking disc. It's just at minimum it is 1 second.
Okay.
So even if
Confusing,
they're on
but
the
okay.
same- yeah, even if they're on
Seek
the
time
same
always needs to
cylinder,
happen.
it's quite.
Yeah. Nice, boys. That was like a 12:55.
Let's go.
Wait. Let me actually put that in the VC channel so I can remember. So
I really hope that that the thing is more like the quizzes than like the exercises because
I want it to be like the quizzes, but it probably will be like the exercises.
I think it will be combined.
Okay. Let's see. What sort of representation we can use to answer a query like this? Select star from employee where ID is 5.
Row.
100 attributes. Well, that's gonna be row based.
Row.
Yeah.
Otherwise, you have to connect all the things because you want to select.
Yeah, because you just want to select everything. If you want to select only one thing, then it would be easier. But even then, like doing a word query would suck.
ID, unless you want to select ID where ID equals 5, you can do column.
Yeah, exactly. Select the sum salary for employee. Well, this is going to be column based because here you can just go through the entire salary column
and that's only
sum up. Which statement is true? Finding a specific record using an equity condition is more efficient than using a primary index and using a secondary index. I have totally forgot what primary and secondary indexes are.
Oh, let me search.
Who knows? Who knows?
I don't think anyone does.
I thought you forgot to start the split.
Oh fuck.
I
It's
think
alright.
the primary index defines how the tuples are ordered on the.
It's on the indexing hash table entry and on slide 15.
Slide 15.
You know what I have to say basically most about these lectures is that Asteria's voice, like, it's very soothing to listen to, but we didn't learn much.
No. That's why I keep spouting this shit. I've spouted this shit since like a month ago. Read the slides, it teaches you more.
No, Yella. Don't worry. These are like the bikes of SQL.
Oh yeah, the bikes. Of course, instead of teaching us, it's about bikes.
Okay, so primary indexes are created by default for the primary key. It physically reorders the table. Okay, this makes sense. And the secondary indexes are optional indexes for non-primary keys, which is either B trees or hash indexes or everything, or something like that. So let's see. Yeah. Oh yeah, and this is just single.
That's
yeah.
primary.
So this is like dense
I have
indexes.
no idea what you even learned this.
What do
So
you think?
primary orders on disk, secondary doesn't.
Yeah, primary is like the exact space, and or like the sparse is like exactly the place, and the dense is just the block it is in.
No, the sparse is also the block, but it's that you have like a tree. Like if it's between 1 and 4, it's in the block of 1. If it's between 4 and 7, it's in the block of 4.
Wasn't it sparse? Also covers everything. Dense.
I mean, yeah, if it's between, if it's.
Oh yeah, I see. Okay, so it's like this. So here you only store like 1, 4, and 7, and it will just point to these things, and then the dense one it will store all of them, and in all cases they both point to the blocks. Excuse me, my bad. So yeah.
They point to the blocks.
Okay. There are secondary indexes, which does not. Yeah, so this is just.
Oh, for non-ordered.
Yeah, so they have to be dense.
Yeah, they're usually dense.
Well, they basically have to. Of course, you could make it, but they'd be pretty useless without being dense.
Exactly. Okay, let's continue. So
primary dense, secondary sparse, right? Or is it-
no secondary dense, and primary is either.
Primary, yeah,
Yeah,
cheapest
here.
to have it sparse.
So a primary can be like this, but a secondary is not ordered, so
it has to be right.
Yeah. Because they're not ordered in memory. That would make it like if you only store like this one and then this one, then it's still really hard.
Yeah.
Okay, quiz 2. Finding a
Depends.
specific record using equity condition is more efficient using a primary index than a secondary index.
No.
No, not necessarily.
No.
They're both as efficient.
Depends, because using a primary index, you could use the block.
But the other one as well?
Yeah.
That doesn't matter.
Yeah,
Each table
yes.
can have at most a single primary index.
Yes.
Yeah.
Unless they both have the
Yes.
same sorting order, but that is going to be very difficult to maintain. So I'm just going to say yes.
Yeah.
You can have
Primary indexes affect the order in which records are stored on disk.
Yes.
That's absolutely true.
Yeah, but that one is true as well.
The definitions.
Oh, okay, yeah. I can select multiple ones. Okay.
Which statements?
Primary
Of course.
indexes support range queries as well. Well, yeah,
Sure.
you just start somewhere and you go there.
Finding a specific record using an equality.
I,
Yeah, that
I
doesn't matter.
wouldn't. I wouldn't think all 4 true would be quite make sense. All 4 options are true.
Can you explain the first one again? Finding a specific record.
So like
I
if
don't-
you
I
have
think they are the same except for the fact that one has space on disk. I guess the good thing about a primary, okay, no, I think I get it. No, finding it's a specific one. If it's a range, it would be better because you could go on disk to the next one, which would maybe cost less reading time. But because it's finding a single specific one, it really doesn't matter. I think.
For range, it is better because you read it as a block, and then
Yeah,
that is one
exactly.
memory.
You can just go on in memory.
Yeah,
that is one disk access instead of multiple.
Which of the following statements are correct? You can have a maximum of 1 secondary index per table.
No.
Secondary indexes are in general faster. No. Can significantly, obviously.
Yes.
Yeah,
in a
remember
database
we
with
have
frequent updates and
indexes.
inserts, it's good idea to create a secondary index for each attribute. No.
No.
Because you will have to deal with upkeep costs.
Plus the fact that like your indexes will take in more space than your entire fucking
Yeah, that as
program.
IntelliJ basically.
Linear hashing uses dynamic directory to double and half the number of buckets.
Okay,
I don't
I'm
understand
going to
half
say this
these
right
words.
now.
Sounds correct.
I
I'm going
don't.
to say this.
Yeah.
We both do not know
Yeah,
what this
that's
is.
true. Yeah.
I think so.
I approve.
Cool.
Let me search.
9p. Which of the following
double
statements are
and
true?
What?
We'll see which one it is, and then afterwards we're going to go back to the slides. Which of the following statements are true? In B+ trees, only leave nodes store links to actual database blocks. Yep. In B+ trees, leave nodes are hashed for allowing faster access. No.
No.
Guys, what if we take a B+ tree and then hash it as
For
well?
question 5, that's extendable hashing, not linear hashing.
What should we do a hashed B+ tree?
Dude, I trust you with my life right now. It's fine.
You know what's the best thing about linear hashing? Like they're asking a question about linear hashing, and only on the slide it says linear hashing, blah 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 blah, not in this lecture, and there's nothing else mentioning linear hashing.
Yeah, because they want you to read a book or something, knowing them. Either read it back on the slides or read it in the book.
In B+ tree, leave nodes are linearly linked for allowing faster traversal. Correct?
Yes.
Yes.
Post-order traversal for R nodes is used to create an ordered list of key values.
Yes.
Post-order, so that would be
Yeah, that's
left, right
bottom.
access, left-right access, basically.
That's all the way at the bottom left.
Shouldn't be.
All the way bottom right, which is.
yeah, but then does it also include
No,
these ones, like the middle ones?
Yeah, eventually it will. Or
Well, it can just choose not to.
well, what if you have multiple layers? Like what if you have 3
Shouldn't
layers?
be in
Jonah?
order.
everything-
Shouldn't be in order traversal.
If
In
you
order traversal, it
yeah,
should
but
be
if you just choose to exclude the leaf, the inner nodes because they will also be present in the leaf nodes.
But to create an ordered list of what? Is it an ordered list of all
key values?
Key values.
Can't
So
you just read the leaves and won't it be in order?
Yeah, it would be, but like we don't know if it's a post
but
order
they were
or in
saying,
order.
yeah.
No, it's
I think it should
definitely
be in order because post order is left, then move to right, which is basically visit all the leaf and then access itself. But in order is like basically up down up down up down. I think.
I think it's the first search
You only
actually.
want the leaf, and then after the leaf, you can say don't read the rest. In order, if you go up, down, then you have some funky stuff with canceling out.
Like you would be able to do it, but then you would have to say
Edit it.
only do this if there are no child. If we just use post order like it is right now, no.
Okay.
There is a database table with 1 million records and a unique constraint on a non-primary key attribute A. There is a B plus tree indexing attribute A for the following settings. Capacity of each inner node is 512 search keys. Capacity of each leaf node is 2656 search keys. What is the maximum height this tree can have?
Hold on, real quick. What is an inner node and what is a leaf node again? Wasn't the leaf node like the very bottom layer?
Leaf node is the one that contains the actual references to blocks.
Yeah. So
that is the bottom row. Basically, it's the bottom row.
So what I'm thinking, right, is it's relatively easy. So we know that the bottom row will have 256, 256, 256. So we know the amount of leaf nodes will be 1 million divided by 256, which is
and
about,
then round up.
Yeah, round up. So it's
3907.
3907. So it's gonna be
That's it's a
3907.
height 3. It's a height 3. It's very simple to see that from 3907.
And then we have to look at the maximum height this tree can have, which is the ceiling of the 2 log of this thing.
512. 512. You get.
Well,
No, because wait, each inner node can have two. Wait.
Okay, so each leaf node will use this.
The leaf node capacity.
Yeah. So you already have a root which has which points to 513 nodes under it, and those point to 513 nodes each.
Or
so.
And then they will point to 513 nodes. However, that would not be enough. So then we add another layer.
Yeah, and then
you would have like 513 squared capacity, which is less than which is more than this. So the answer is going to be 2. Or well, 3 including the bottom one.
3. Yeah, because you have 2 inner nodes and 1 leaf node. Yeah.
Yeah, exactly. All right. So then, what will happen to this in above B plus tree, where each node can store a maximum of 2 values if 13 is inserted?
2 splits.
One split will happen here. This will become 1 or 5, 8, 8, 13. This 8 will split here. This will become 4, 5, 5, 8. 2 splits will happen.
Yeah, and they are using like the same software that we did before.
Yeah.
Yeah.
This.
Okay, which statement is true? Hash indexes perform well? Well, no. No indexes perform well. B plus 3. Anyways, what happens when we try to insert this value?
Is the previous one clear to everyone?
Yeah, if it's clear, by the way.
It should be.
Wait, that's just a question from the assignment.
Yeah, it is. Yeah.
What's no index actually?
It's when you just use the value.
Yeah. So if you don't index it at all,
the range, or like just normal like.
Yeah, you have to go through all the blocks.
Okay.
Yeah, it does not perform well.
You don't order them in any meaningful way. That's what it means.
You just have to scan through all of them.
Yeah, it's a linear scan. Or yeah.
Wait, so hash index is better for the specific range. Specific
Yeah, for your
use,
specific
right?
one, and when you have a range one, it's the B plus 3.
Yeah, because you can walk through them.
Yeah.
This is also one literally from the fucking slide or from the question.
Yeah, no, it's not literally. Because here it is 111.
Can I just say?
Yeah.
They don't actually specify which one is which one, in a slightly annoying way where they don't like. It's intuitive, but still.
Yeah, no.
Maybe the age is 111 and the salary is 65.
Yeah, but then it would be here.
Sense.
Then it would be
no,
here.
because
you can.
Because then, like, the thing is, if that would be the case, like age 60 or salary 80 splits to the right if the first value is 50. So it can't be that the first value is salary So, and you can assume that the value they give is in the same order as the value in the cells, so it's age then salary.
Yeah.
But
Unfortunately,
they should
but
have said us.
it should be specified. Yeah. So let's see. Salary is less than, age is more than. So this will split. Will cause a split.
So the third one, yeah.
Yeah. Submit.
Let's
And
go.
time. So that
Right,
is
2 more.
12:27. I think we're pretty consistent on the quiz.
Okay, let's see the score.
we're getting faster. We are
You still
like
have to
30
submit
something
confirm.
faster.
We
Submit
got a
quiz.
10 out of 10.
10 out of 10. 10 out of 10.
Ooh, 10 out of 10.
Ooh.
Wait, it's all of them.
Ooh.
Okay, so let's see. It's more efficient using a primary index than a secondary index. Why is that?
Oh.
Maybe because the primary index can be like
The only
sparse and-
difference for speed is the fact that it's on disk. So then it has to be because it's
Yeah,
on disk.
you're retrieving the whole block of all where the index is.
No, because secondary. Wait, is secondary mass?
No,
mass,
but the thing with secondary is dense. So what
Yeah.
you will have to do is you will have to, for each where that attribute is correct, where it is x equal 5, you will have to retrieve every single different block of that.
Yes.
And that will not be in the same block. Versus on a primary index, they will all anywhere x is equal to 5, where x is then the thing that is indexed on. Since it is sparse and it has blocks that are organized together, you'll require. No, but either way, you're retrieving less blocks.
Yeah. The thing is, they want one specific one. So if you have like 10 blocks, it's going to be one of the 10. And
for the primary index, while on the
Yeah.
secondary index, it could be on 3 different blocks. You could have that value be correct.
yeah, true. So with if the block size is 3 and there's 10 indexes, with the primary index, it's going to be in 4 different blocks. While with the secondary index, it could be on 10 different blocks.
Mm-hmm.
I get what he's
Basically,
saying. Yeah.
Less blocks.
And
Yeah.
also, a primary index is only done on the primary key, right? So it's unique anyway. So there's only one of them.
Well, I don't think that is necessarily the
primary
case. No, I don't think it is.
It isn't necessarily unique.
Is it not?
So-
Primary key, they're
But
always
then
unique,
primary
right?
index only on primary
keys are,
key.
but primary key isn't a primary index. You can use a primary index on something else if you are if you want to sort more often on something else that isn't unique.
But
A
primary
index
indexes
is
are always created
No, but
for...
yeah.
by default, Jure.
Yeah, but can you create a primary index that is not for the primary key?
Yes, primary key practically means I am going to use this most often, so I want it sorted by this on disk.
And it has to be unique.
Where?
No, it doesn't.
Where
A,
does it say
a
that, Jure?
primary key has to be unique.
Yes,
No.
but a primary attribute doesn't, and not because a primary attribute is literally just I'm going to be sorting by this because I am going to use this attribute more often.
Oh.
If we're looking at like a fucking a store, like the database of a store, the primary key is going to be the store item, the SSID. So like, but you're going to want your primary index. Well, you're gonna say you care about price. You want your primary index to be price, so you can buy things that are worth more than $60. So your primary index will be the price, so that's more efficient. But it won't be your primary key, and that is the difference.
Is it not maybe
I'm
that
confused, but okay.
Is it not maybe that the second index isn't automatically ordered, so you have to do first binary search to order them or to find your thing, and then you look up instead of the
No, it just checks
the
all
primary
the time.
index?
No, because it's an index, you can just instantly go to every block that has the thing. The problem is that there are more blocks.
Either way, the rest
Yeah,
is correct.
but you don't know where the index is because the blocks are stored on the primary index and not on the secondary index, so you don't necessarily know where the second index is. You first have to search through the primary index, right?
From an index, you know where the block is, don't you? Aren't
Yeah,
indexes
but
just
but
from
you
there
don't-
Indexes are a reference to the block.
to a block? Yeah.
Indexes on the bottommost layer, on the inner
The most
nodes.
technical.
The inner nodes contain a reference to the next node. On the
Leaf nodes?
bottom layer, the leaf nodes, you have a key value pair where the key is, of course, the key, and the value is a reference to your block, to the block
Yeah.
where that is stored, and a value, where it is on that
Yeah.
block as well, I guess.
Yeah, I get it, but like, do you have instant access to that index, or do you
Yes.
first have to look up that index
Well,
through your primary?
that's in the tree. you have a tree
Oh, right,
for that
okay.
index. So if you want to know that index, or if you want to, you have the index, you want the key. So that's how the whole process starts. You have an index, you want a block. So you traverse the tree until you're at the leaf node with that index, and from there you have that key value pair that the other guy talked about, and from there you can find the block.
Yeah, got it. Thanks.
Okay, everything clear. We're going on.
Yeah,
Star
and now-
quiz.
And now we can drop that table.
True or false? All serializable schedules will result in consistent results.
Yeah. Yeah.
It seems like it makes
Yeah, because
sense.
you can serialize it. And
Yeah,
this
there's
means
no
consistent.
conflict.
Yeah, then this means there's no conflict, which
By
means
the way, is conflict serializable and serializable the same thing?
I think serializable is
No.
serializable is a subset. So serializable means you can change it in such a way that it's just all in a row, and conflict serializable means that, and this is very vague. I only watched this lecture once, and I'm very dumb. But conflict serializable means that it gets to be the same efficiency as serializable, but it isn't necessarily serializable, from what I know. Correct me if I'm wrong.
Oh yeah, no, I think what you're saying is right.
Much
so-
of serializability.
How is was serializable? I couldn't even spell. S-E-R-I.
You're at the top, you're at the very top, you're at the very top. The first
At the very
slide. The first slide.
Huh?
Okay.
The same effect and conflict serializable is the same conflicting operations in the same order. So indeed, we can turn. Yeah, here it is. So we can turn a conflict serializable schedule into a serial schedule by just swapping it around.
Into it, but it has the same effects on a database.
No, that's serializable. I'm talking conflict serializable.
Yeah, conflict serializable is part of serializable, and
Yeah. So serializable has the same effect on a database, and conflict serializable means you can turn them around for them to be just in order.
Okay, here. All serial are conflict serializable. All conflict serializable are serializable. For it to be conflict serializable, but like.
oh god, this is what the fuck.
No, it's just.
It's cool. Let's go.
I would just say it's true. I just think it's true because
What was
that's
the question
basically
again?
like
Yeah, no, this is true. This is like the definition of serializable.
yeah.
Yeah, they avoid concurrency issues. That's what they say.
Yeah. So I can close this one. I can do this one. Is the following
What's the
conflict following schedule
Yes.
conflict serializable?
Yes.
So
it's all
it
in
reads.
order. 1, 2, 2, 3, 3. You don't need to do the thing. It's all in order.
Okay. Well,
It
does
is
that
serial.
No one
that
writes
doesn't, that
to.
doesn't care.
It is serial.
No, it's a serial thing, and therefore it's also inherently conflict serializable. He's right.
Oh.
Yeah, it's 1 1 2 2 3 3. So whatever happens in here doesn't matter. It's just the same as going from left to right.
Yeah, so for example, there is a conflict between write 1b and read 3b, but there's no way for that to be a conflict the other way around because they're in order.
Yeah, like if
Ah,
it's serial,
because
serial
okay.
is
Yeah, there is
serializable.
never a 1 that's after a 3.
Yeah,
because
exactly.
it's a single threaded and it's like oh I see.
Yeah.
It's serial.
In the
so you
following
don't-
conflict, schedule conflict serializable. Let's have a look. Read,
this
read,
doesn't
read,
look ready.
write.
No,
Or is
Wait,
that- wait. Okay.
uh,
Let me actually think about that one.
Wait. The thing is, they all the reads and writes act on different things. So, like,
they
for there to be
no, read 2C and write 3C.
but for there to be a conflict, there needs to be 3 operations, so read and write, which act on the same atom, so C, A, or B. So because you need something that's before something else, and then a third thing that is after the first thing, which all act on the same atom.
It doesn't have
Because
to
if
act
they
on the
don't
same atom.
Does it have?
Does
Like
it not?
we can have. Let me actually show you guys. So if we have T1 and T2, and T2 is blocked, it blocks T1 by like I don't know X, and this one blocks this one by Y. It doesn't matter if you have 3 or not.
Yeah, but that's the point.
So let's
it
have a
can
look
be
now.
It can be serializable, but it doesn't have to be conflict serializable.
True. Let's have a look.
So-
So first we read A, and then we write B.
So
C.
1 to 2 is blocked already.
Mhm.
No.
From
No.
1 to 2.
Oh yeah,
one
from
to
1 to 2. Yeah.
Yeah, so 1 to 2 is blocked.
2
to 3 is
to 3 is blocked.
And
And 3 to 1 is
And 3 to
blocked.
1 blocked, so it's 12.
It's not.
Yeah.
So it might not. So it might be serializable. It's just not conflict serializable.
Yeah.
Wait, can you explain it again? I didn't get it.
So from 1 to 2 is blocked because
Yeah, because we read 1 and then afterwards we write 2. Then from 2 to 3 is blocked because we read 2 and then we write 3. And then from 3 to
And
1
then
is blocked
we
because
read-
we read. Yeah. So it's a circle.
Okay.
The following conflict schedule conflict serializable.
From 1 to 2.
So from let's see, from 1 to 2,
1 to 2,
from
2
2
to 3.
to 1.
What?
No, wait, no,
2 to
sorry,
1,
I
so
thought it was
it's-
an 8. Okay, so from 1 to 2, from 2 to 3, and from 1 to 3. Yep, conflict serializable.
Yep, looks good.
Again, if we draw this one out, it's, let's see, T3.
Everything is gonna point to 3 because 3 is a point, so it's never. And
Yeah,
2
so
and 1 then
our
points to
1 had a
3.
conflict with our with 2, so like this. 1 has a conflict with 3, like this, and 2 have a conflict with 3, like this.
So everything points to 3. Nothing is a circle.
Yeah. So, which the cap theorem guarantees relate the following system property: requests are always answered by a response when at least one node is up. That is availability.
Yeah. Availability.
Oh god.
Which the cap theorem guarantees relate the following system property: all instances of querying nodes will see the exact same value of a given resource at a given point in time.
Consistency.
I don't
The
know.
last one is
I don't
partial
know what the
colors.
cap theorem is, and this I know what
By
the
the way,
answer is.
if you don't know what it is, the definitions are literally what we're now giving.
Yeah.
So,
And you can only choose 2 out of the 3 to. You cannot have a 3 out of 3.
Yeah, mathematically impossible.
Guys, by the way, has anybody looked at software quality and testing and the fact that the flipped classroom approach?
What?
Oh, Pog! The sessions are only for Q&A, so we have to teach ourselves.
Yeah.
Are you
fuck?
Hmm.
Fuck off.
This means we want you to
No
read the
way.
material, solve exercise, and ask questions before the lecture.
You'll have to pay us €2,000 though.
You know,
See,
what
this
that
hap-
means? You know what that means? I'm not gonna show up to the lectures. They can suck a fat one. I'm gonna,
Right,
They
but
learn
no,
nothing
in the
from web
lecture time,
technology.
learn the stuff.
I mean, the software quality SQT is only one you have to pass at Q4. I mean, if you have already BSc and if you want to finishing 3 years.
Yeah. Okay, wait.
Okay.
Let's have a look at the rest. We'll rage at SQT once my recording is done, because then I can swear. The following statements hold for redo logging and recovery, or for undo. Commit is written to log after all values are on disk.
Undo.
Undo, yeah.
Undo?
Yeah.
Yeah,
because
so you commit.
if it crashes before you write the commit to the log, it will then go
Undo
and undo everything back to the original state. So that way it will work.
Yeah. Same thing here. It's redo, but that's like because if you let's see.
You
the
can't
following
undo
statement
if it
for
only
redo-
holds new values.
Yeah. Exactly. So the log
If it
only holds the
undo
new
its old
values.
value, right?
If it crashes, then you have to redo them. Following statements hold for redo logging or and recovery or for undo. Committed transactions are ignored. So if you
Undo.
yeah,
Redo?
No, undo.
I'm tempted to
Redo
say
does. Redo
Undo. Yeah.
Undo.
So
Redo.
Shouldn't be redo though.
No, undo
redo.
fixes uncommitted. Undo fixes uncommitted transactions.
Redo recommit.
Yeah, but then it's committed.
No, but
Committed are ignored.
Yeah.
Oh, it's okay. Sorry.
Repeated is
My bad.
redo for question 11. Speedrun.
Redo.
yeah.
That's,
Okay.
that's redo.
That's just the complement of question 10.
Yeah.
The following holds for redo. Okay. Commit is written to log before any value is written to disk. That sounds like redo.
Redo?
Because and this is because of the fact that so you write commit, which means that all the values that have been written previously in the logs are the final values. So even if it crashes afterwards, you can use those final values that are last written in the log to do to fix the writing.
Oh yeah.
If you do this in undo and it crashes, you will not have the right values. So this is only possible in redo.
Yeah.
Okay. The
I'm
following
so gonna
statement
fail
hold
this
for
exam.
redo logging. Incomplete transactions are ignored.
Redo.
On
Redo. We discussed this.
Yeah,
Max.
yeah.
In a two-phase commit, transactions in a distributed database provide all or nothing atomacy, just like in a centralized database.
Yes, right. This is for two-phase
Or
commit. It's true, right?
I have no idea what two-phase commit is. I'm going to
What
be
is
fairly
all or nothing?
Two-phase commit.
You guys want to flip a coin?
All or nothing atomicity means that in every single database it has the same values. I think eventually.
Transaction.
Atomicity says
no,
that
this is not
it's all
true.
or nothing. So like either all databases like commit the change or they don't. There is no like state in between. And
That
I think
does sound.
two-phase commit.
I think this had. I think wasn't distributed databases eventual consistency.
No, that's I think NoSQL, right?
Oh, that could be as well.
Normally, you're right, but since there's a system for two-phase commit, it should be always consistent.
Okay, true then.
Across the entire thing, because they discuss with each other whether they
and
do
then-
something before actually confirming it.
Yeah, and then here we have the same thing as we just said, because it is. You said it was eventually.
I think yeah, because the thing is, wasn't it like as a main server, you send out to everyone, hey, commit this, and you wait until you get back from everyone, I have committed, and if you don't, you send it out again. So it could be that the commit is at a different time place, but the server will not stop sending commit this until it's committed. So it's not at the same time instance, but it's going to be very close to each other, if I recall correctly.
It just sounds like that server's really committed to getting that message out.
So it's
I'm pretty sure it asks if all the other servers to like prepare the commit, then it waits for all of them to respond to that, then it tells them, okay, you can now commit it. And then if there's not a confirmation from all of the servers, it will tell the other servers to undo it.
Oh, yeah, but then it's true.
No, because delay.
But it's not a. There could be a time delay because all the participants are not together.
Yeah, exactly.
Yeah,
like
true.
it could be a millisecond. So even if like because they're not on the same location, there can be a millisecond delay due to the fact that there's like
No, but they talked
communication time.
about the atomic clocks in these data centers.
Yeah, but
but your message arrives delayed, not because of that.
Yeah, but it waits until the time. I'm pretty sure. Well, whatever. It's 1 point.
Yeah, well I'll take that. I'll take that.
I don't think it's true.
Even if a site fails, the condition no, because it waits for everybody.
No, it doesn't, because you would just ask a board because basically he doesn't send it as they acknowledge basically.
Exactly. Okay, during a transaction, execute a two-phase message commit protocol. Sends out a prepare message. Everyone sends ready. Then the commit message. Talk to the coordinator, except for site 1. And then yeah. Okay. The coordinator.
No discs were harmed in the creation of this question.
Okay, so because not everybody can commit at the same time, it should roll back. The coordinator can declare the transaction successful. No.
Is this the first or the third? I would say.
Yes, it's the second.
What?
What?
No.
Yes,
it doesn't acknowledge it.
No, because you have a time within a time frame.
No, you can put on a timeout. It doesn't say that it has put on a timeout. Next to that, he has already sent the commit message.
But not the act.
Yeah, but not the act. He has sent. So he doesn't. He's not sure.
Yes, so it has sent the commit message. It still is waiting for acknowledgement. So after it has been put back up, it sends the acknowledgement to the coordinator, which then accepts. Oh, it's done.
Yes, but the transaction cannot be declared successful because not all of them are done.
Yes, but it doesn't know how fast.
That's why
how fast it responds.
Yeah. There's no timeout. It doesn't know if it responds fast or if it's slow or nothing. So it just waits. And there's timeout. No one put a timeout in any of those.
I don't think it's first because I think it's basically until a timeout, then you will shout out the rollback message.
Yeah, but if there's no timeout, then rollback is never going to happen, and then you're not doing two-phase.
I'm gonna agree with Yura.
I'm gonna look it up.
If you're going to no wait, I want to. This is the last question anyway, so we can see. But if you do not wait for everybody set a timeout, if you just wait indefinitely, then your entire protocol will your entire database cluster will fall to a grinding halt because one server doesn't reply.
Yes, That is
There
true,
is a-
but that's not the question.
The thing is, because it cannot alter that data again until it's
Wait,
been.
this is multiple choice. Maybe A or B.
No, it's like
A,
you
maybe
can have multiple of them.
But okay, think of it like this. Because
Oh, it's only 1 point. Yeah, never mind.
that data point, you don't want to be able to edit again until it won't be able to edit again until that has been it's completed.
Oh,
so...
wait, guys. Have a look at 2 and 3. I think 2 is right, 3 is wrong.
Yes.
Well, 3 is certainly wrong. But
Yeah, 3 is definitely wrong, but I think 2 is right.
3
2
is
is wrong.
definitely wrong.
I'm
okay,
not sure if 1 is true though.
One is
Because
I would say
If you don't need all the acts, what are the acts for?
acknowledgement that the commit has been successfully done.
Yeah, but they're useless if you don't wait for all the X, though.
Yes, that's why you wait for it to come back up. The
It would-
the rollback is only before the commit. After the commit, and you send a rollback, it will hey, but it already committed, so why should a rollback?
Let's have a look. So, 1,
Just jump to the last few,
1,
I'll say.
1. No, I want to check about everything else correct.
Yeah, and then the last one is only the second one. But you
Real
don't see it.
feedback.
Cordic, another side.
Yeah, there you go. It waits.
Yeah, but then 2 is false.
But wait, it can
No,
wait
2 is
before
true.
timing out.
Wait, what?
So 2 is false and only 1 is true, right?
No, 2 is true,
No.
1 is false.
2 is true, 1 is false.
It doesn't roll back.
Because yeah, you have to wait until you make sure the S1 is no response at all. Then you call out for the rollback.
Yeah, it shouldn't be immediately. I agree with that at least.
Oh, yeah, okay. Okay, immediately. Fair. I didn't see that word.
But there can be a timeout. But it
there
is
can be,
immediately.
but they didn't put in, and that's why they probably put in the word immediately to make sure that timeout is not in here. But it only rollbacks if it gets a failure or timeout. But there's
Yeah,
no
okay.
failure,
So
no timeout.
they also say S1's disk was not harmed because that means that it can look at the logs, and once S1 flips back online, it redo logs the entire thing and sends out acts according to what they found on the log.
Yeah.
And then and if the disk was harmed and there was a failure writing to disk,
Then
it
it will
will
roll back.
send a no or whatever the fuck the signal is, and then it will roll back.
Yeah.
If I recall correctly.
Yes.
Okay, seems to make sense. 15, 24.
Knowledge learn.
And now we can do 4, which is a summary roll.
Okay, let's see.
Fun.
15, 20, 24. Okay, practice quizzes, quiz number 3. And we're still above a 9.5, just say. Start quiz.
I mean, any group with 50 people would probably be above a 9.5.
That's
well, you say that, but for calculus, a group of 50 people got a fucking 7 or something.
Yeah, correct.
Yeah, but
Okay.
that's calculus.
Calculus just kind of hurts.
Wait for the following statements. Okay, it tries to avoid really bad execution plans. I sure hope so.
Yeah, because even if it does random stuff,
Yeah.
it won't find the optimal, but it will just make sure it's not really bad.
Okay, so these 2 are true. This
Yeah,
one, of course, is not
It's the
fucking
same
true.
set.
It should
Yeah, it should be the same set. Yeah.
Yeah,
Okay,
and
I
not the,
think it's this.
it's also not the optimal one because it can be
No, it can be
suboptimal
random.
but really good.
Yeah.
Assume there is a selection with the condition C on the relation R.
Okay. Okay.
No.
All attributes in C have a. Do we need this?
I think we do.
No.
No, just Sigma. What's a Sigma again? That's the
Sigma ball.
Sigma selection. Sigma selection.
Yeah,
So
Sigma
select
selection.
R,
Okay.
select R with relation or with condition C.
Okay, all attributes. Okay. An index fan is always faster than a relation
No.
scan. No.
If you have one tuple, that's wrong. If you
Yeah,
have one tuple, that's wrong.
exactly. And we already discussed this earlier when we were doing assignment 3.
Yeah.
A relation scan is likely faster when the reduction factor C is very high. Maybe check the counterintuitive definition
Just
of a
because they
reduction
say
factor.
that, it's true. Just because they say that, it's true. It has to be.
No, I think
agree
it
with
is.
you, yeah.
One over the number
Likely.
value.
I would say maybe it's true. Yeah, if it's likely, I would say it's true.
You divide by the reduction factor to get the cost. So if the reduction factor is higher, the cost is lower. So that's beneficial, I think.
Yeah, but is it beneficial for the index scan or the relation scan?
Yeah, I don't know about that. I just know that that's the counterintuitive definition. Don't know for which scan.
Cost.
Oh, there.
But it doesn't say here.
No, it's their
Well.
index scan. Matching tuples is
Oh,
based
yeah.
on the reduction factor, so it's for index scan. Related scan is just the blocks.
Yeah. So index scan is good if the reduction factor is high.
Index scan is better.
Yeah.
Then index
I
scan
think-
should
I
be
think so.
better.
Yeah.
Because
I
you have
think
less
so,
number
yes.
on the MT.
Okay.
Good, come on, we're losing time in the speed run.
Oh no!
Oh,
This is
Daylight.
so.
So that's not true.
Okay, this is false. Reduction factor C is very low, then an index scan is likely faster. We're looking at
No,
this.
because the MT will be bigger rather than
Yeah.
smaller.
Exactly.
So that's
Okay. And then if C contains a range square with a high reduction factor, then index scan is faster than relation due to the leaf links.
I'm just gonna look up real quick what the reduction factor is.
Why did you guys say that 2 and 3 is false?
Oh wait, the reduction factor is the fraction of records matching a thing, not 1 divided by a fraction. So it's the other way around.
Yeah,
so
low
it's
reduction factor.
Reduction
Wait,
factor is
so-
a fraction. So if the reduction factor is high, the amount of records matching that condition is also high.
Why do
So
they say
wait, so if
counterintuitive?
reduction factor
It
is
is so
high, so
low.
is MT high or MT low?
MT is high if reduction factor is high, which is why it's
Okay.
counterintuitive.
Yeah.
That's why. So then it is true.
But 2 and 3 are true.
Then it's both true indeed.
Then it should be 2 and 3 is true, yeah.
Yeah. 2 and 3 are true. Okay, that's why it's counterintuitive.
Yes.
Well,
So if C contains a range query with high reduction factor, then an index scan is faster. So high reduction factor means then an
Due to
index
leaf-
scan is faster than a relation scan.
Yeah.
I mean,
but
it
then it's
though?
not due to the leaf link. It's not due to the leaf link.
Yeah, but that has some.
But
that has
even
some-
It's
if
faster,
it was,
but it's not.
even if it was, why would it be faster? Because like if a high blocking factor, 1 is a high blocking factor, then you have all the tuples. Why would it be? Why would an index scan be faster if you have all the tuples?
So I think it'll be slower then.
Yeah. So I think it's 2 and 3.
2 and 3 only. Okay. Which of the following statements is true? During query execution, is a good heuristic to execute sort operations? Huh?
No.
Sort? Huh? Like there's like only 2 or 3 out of like all the different scenarios where you would want to sort something.
Well, still, like if you have a sort operation, do you want it as early or as late? I think as late.
I think
I think as late as possible because like you're gonna reduce more.
Look at the.
Yeah,
look at the
that's
bottom one.
access all the data to do the sorting cause.
Yeah.
Yeah.
Quick sort is a good operation database due to its good runtime complexity.
Sure, sounds good.
Yeah, no, but then, like it's
We
a
always use
terrible
Quicksort.
it's a
But it's
terrible
not even-
fucking thing in databases because like related to everything else. But it depends what they
Wait,
mean.
is
If they mean like
Quicksort
quick sort relative to like an index scan, or if they mean quick sort relative to
Quick
merge
sort
sort.
relative to it's a good sort operation. So quick sort
Ah,
relative to
sort
other
operation.
sorts.
Yeah, fair.
Yeah.
Merge
mean,
sort
that's
is a good sort
uh,
operation in database because it performed well with limited main
Yes.
memory
So
buffer.
quicksort would
Yes.
be good. If quicksort would be good if it what? Wait, merge sort. A merge join is good. A merge sort, I'm not sure.
Merge sort wouldn't be good because in database you generally it depends. If you have something where you have a lot of keys that are the same that you're sorting on, then a merge sort would probably be pretty good. Or I don't know. No,
But
wait, merge
Yeah, but that's not
Would it
because
be
of this.
good because of memory. I think 2 is correct and 3 isn't. I think.
Okay,
Yeah,
sorting
3
early
doesn't
during
sound
query
good.
station.
Let's wait and see 4. Let's wait and see 4.
Yeah.
Sorting
In-
early.
But
in
it's
place,
Yeah, but it's
multiple.
multiple choice, so it doesn't matter.
Sorting
in
early
place would be
during
good,
query execution.
but otherwise I think
Yes.
merge sort would be awful
Yeah.
actually.
Wait, sorting early during may sometimes be beneficial because from operation to.
yes.
Yes, that could be true. Because
Yeah.
sometimes it's only sometimes. Yeah, if it's sometimes, mostly it's true.
Yeah, but it depends because if we sort before a merge, it won't do anything, right?
Yeah.
Yes, it will because a merge join can only be done on a sorted list.
Yeah, but if only one of them is sorted.
Well, but like sorting may be beneficial because it allows for cheaper merge joins. That is a correct statement.
Yeah, okay, fair.
It literally says because.
Yeah, it says
following operations take
maybe,
advantage.
so that's fine.
Yeah.
But also,
Consider a join the natural join of RNF.
that's supposed to be join symbol.
Loop joins are likely extremely efficient if one relation completely fits within a buffer. Let's have a look.
believe so. Well,
No.
But
that
then
won't say it here. But
the number of
Merge.
blocks of R is just going to be 1. So index has to...
I don't think the amount of blocks is 1. I think just the fact that it can stay in buffer is just
Oh,
really nice.
true. Yeah, but they
What's
have
the width?
to they have to access everything only once.
Yeah, so then I would say
No,
it is correct.
Wait,
Because, like,
can you explain again? I didn't get it.
so
Okay,
a block
so
nested
if you
loop
have block
join-
nested loop join or index nested loop join, and everything fits into a buffer, that means you only have to load everything once.
only load one relation once, and the
Yeah,
rest
one
you can for the rest you can pick up, like, you've got you're comparing stuff. On the left
Yeah.
you have everything you need to compare to, and on the right you can just pick up one block, look at it, join those things, pick up the next block, look at it, join those things. So you only have to go over it once, and that is the thing that makes it cheap.
Ah,
Because you don't have
Oh,
to reload to the buffer all the time, which makes it so much faster. Or it should make it much faster. Depending on what you did with your buffer.
I now join. Sorry.
Index nested loop joins are likely very efficient if the reduction factor of the join condition is very low.
The reduction factor of the join condition is very low, means there's a small amount of matching tuples.
Yeah. So when we have a small amount of matching tuples, let's
The index
compare-
join is amount of blocks times amount of tuples in R. Wait.
I think
Wait.
this one is better then, right? Because
what?
Wait,
What
no.
the- what
Wait, it
the
doesn't
fuck is
really
an index?
match with
It doesn't
matching
matter.
tuples.
It's like
Wait,
if
what
this
the
will
fuck
be
kind
the
of question is that? Why is there a Oh, wait, is this a theta join they're talking about?
no, it's
No,
a
it's
natural
a,
join.
it's INL. It's INL. It's a natural join.
So they're talking then about if the join condition is very low. So there are many different things, or every index has a low amount of matching tuples, so there's going to be a lot of indexes. So index nested loop join is not good, because what you're going to do is you're going to go to the index and look at the other things that have the same thing, but then you only get a relatively small amount of other tuples. So
Because you have low matching tuples.
yeah, low amount of matching tuples per so an
Per condition.
IXL is like performing an index scan for every single different index, and if you have a low amount of tuples per index scan, that's going to be a problem. So I don't
that's
think
going to be
that's
not very efficient. So okay, that's false. A merge
okay.
join benefits from pre-sorted relationships, and that can be inferior choice if the
it can't be performed if it's not sorted. So
yeah, true.
Yeah.
Hash joins work particularly well for join conditions with very high reduction factors.
What?
Very high reduction factors means that there are very many
matching tuples.
Matching tuples per index. Yes, correct.
Then it should be.
Does it depend on the high reduction? Does it depend on the reduction factor though?
Yeah,
If you have a high reduction factor, then there's going to be a lot of tuples in there. And if a lot of tuples, somebody else explain it. I can't explain it very well.
Okay,
So hash joins, I believe they take the hash and look at all the other things which end up having the same hash. So if you have a very high reduction factor, one value, so one hash, has very many things in the same bucket. So you go through the hashing process once and just link everything you find in the same bucket up. So that's why it works really well, because you only have to perform the hash once, and then you can just go past everything in the same bucket. So that one is true. I am not sure about the index nested loop join, because I was thinking about hash joins when I was talking about index nested loop joins. I'm not actually sure what the fucking index nested loop join is. So this is naive version, which might access the same block multiple times.
Then it doesn't
Yeah, I
matter.
think I was correct as well. So I think this is the answer, but I'm not very sure, as you can hear from my voice. You're carrying the assignments, me carrying the quizzes.
Yeah, I am not a very smart man. I am leaving all the smarty things to you guys. That's basically what it comes
Maybe
down
we
to.
should do the exam together. It would be much easier.
It would be.
Oh yeah, smart.
Smart, good idea. Pipeline increases the efficiency of query execution by removing the need for temporary results.
What
No.
the fuck?
What?
Guys,
No.
what if we just didn't do temporary results? Sorting or duplicate elimination cannot be pipelined at all, easily or at all. I mean,
Sorting can't be.
No,
I mean, you can
this,
just
also
this
can't
can all
be.
be. This is all unary shit, so this can be pipelined easily because you can do this all just in a different pipeline.
No, but
while
like sorting, when they say sorting command in pipeline, I think they mean that you can't have 5 different like things doing the sorting at the same time.
when I say that, I think they mean you can do the rest of your query while you are sorting or duplicate elimination.
Ooh, if that's what they mean, then it's correct.
True. Yeah, I think it's true.
The pipelining, I thought was also the first one where for the pipelining you didn't need the temporary results, which makes pipelining faster.
Why
But
though?
if you don't have temporary results, how are you going to do the next query? You don't know what you're working on.
And temporary results in the same pipeline. The pipeline gives a temporary result, but in the pipeline you don't need it.
Yeah, but there are still temporary results. They're just maybe stored somewhere or differently or whatever, but there are still temporary results.
Fair enough.
But
Yeah,
maybe
it's a
they
vague
don't
question.
get. Well, no, but they have to be written to memory because, or to memory, or disk, whatever. I don't know which one. But if the amount of blocks, or if the temporary or intermediate result cannot fit in memory or in your buffer, so no matter where you do it, if you perform a query, you're gonna have to write the temporary result somewhere because they don't all fit in your buffer. So join operation cannot be pipelined.
Yeah, because that's like working on 2 different tables.
Well, the last one is absolutely not true.
Yeah, and I think this one is true because
No, they can be. Join. Why can join not? Join is the main thing that you're pipelining.
Is it though? Because in the assignments, when we're looking at
In the slides, that's the main thing they are pipelining.
okay, that could be fun.
Wait, what's
Can you look up the slides for pipelining? Because I have forgotten quite a bit about pipelining.
I'm trying to look for them, but I cannot find
Here, it says like the important heuristics are used pipelining for unary operations, and joining are binary operations. Yeah.
Wait, can you go to example pipeline? They probably also have like some example pictures.
So
Somewhere.
they did this, and then
no, that's not pipelining. But
I thought I would do it here. My bad.
So pipelining, if you scroll up to that example you were just at, if you could. Yeah. So what you can see here.
Did they do it here?
Or not,
yeah, here they do.
Scroll past, sure.
No. Here they do. So when you have unary operations that are next to each other, so you do this one, you can do it at the same time as this one.
Go to 87.
87.
Go down.
And you also see that they use less temporary results.
Where?
Just
you see it in the fact that
they have less keys.
But yeah, in the picture also they show that they do a binary operation.
Yeah, they do this one.
Yeah, and in the bottom pipeline too, they literally have around a binary operation too.
Okay, so pipeline is less. So your pipeline is less than or less what we did at CO with stuff being run parallelly.
Yeah.
And it is more or selecting special stuff to be run after each other without any interruptions, so you can use, so you can do same things at the same time. I think we were both thinking about CO.
Yeah, I was thinking about running things concurrently, but what they do is they just do this stuff, this stuff, this stuff, this stuff, and then write to memory instead of this stuff, write to memory, this stuff, write to memory, this stuff, write to memory.
Yeah,
so
okay.
that's
So
what
you were right,
pipelining
and
means.
we were thinking about something else. Thank you.
Wow, okay, that's really good that I'm checking that now because I did not know what pipelining was. Let me check it again.
Sorting. So the first two are correct. So first is
the first one should be correct.
Yeah, it is.
The thing is, it doesn't remove the need for temporary results entirely, but it does.
The thing is, it does because stuff like pipelining, stuff with like pipe. Or actually,
if you go to the slides, I think it's like if you go to the slides, that one, it's on, yeah. Because basically for the first one, you have to write. Yeah, but then first one you have to write 3 times. For the second one, you only have to write once.
Yeah, but there's less of them, but it doesn't eliminate the need for them.
No, but
it does eliminate. There is less demand right now. There's less demand.
You could see the T1 as being outside of pipeline 2.
Yeah, but like what the question is it it removes the need for temporary result. It doesn't remove it; it reduces it.
It removes the need inside of the pipeline.
Yeah, okay, but that's not the question.
I would say it's yes. I would say it's yes.
Like pipelining can't affect anything outside of the pipeline. Like
yeah, but there are still going to be temporary results, and pipelining does not get rid of that.
Technically, Jure, if you write the entire thing in one pipeline, there are no temporary results.
You're right. Cool. Sorting or duplicate elimination cannot be pipelined easily or at all. Well, yeah, this is true. Because then you'd have to do multiple things, but you're doing it all in a row, and you don't know the rest of the stuff.
Yeah.
No. You need to temporarily.
No. Sorting, like a sorting and a selection can be pipelined in one go. But so then, if you sort, you can remove stuff from the stuff that you're sorting.
Yeah,
so
you can,
that can be
you can go
pipelined.
to the slides, like slides three lower than you had like before.
This one.
Yeah, and here you have like pipelining does not usually work well with sorting and merge joins.
I can also explain why it does not merge joins, but it does work with other joins. Why it does not work with sorting is to actually sort, you have to again store a temporary result to use the sorted list.
Yeah, like what you can see it as pipelining is you do every tuple like one by one, and if you want to do duplicate elimination, you need to know what the other tuples are, but you are in your own pipeline, so you cannot do that.
Okay,
cool.
So sorting
join operations cannot be pipelined easy or at all. Well, yeah, they can. It's just the merge joins cannot be, but interconnected loop joins work great. And pipelining is always better than no pipelining. Nope. What the following operations are true? Algebraic query optimization selects the best implementation for each operator.
Wrong.
No.
It only transforms the algebra operator tree. I think that's true.
so. Yeah, like that's what it does.
Applying an algebraic query optimization rule always results in a more efficient operator tree.
It says always. The word always gets me.
If it says always, I
don't think so.
most of the time it does.
Okay, so you imagine you have a thing where you have T1, you have you have a table, you have something you put on the table, and out you get another table, and you perform algebraic query optimization. Good fucking luck.
Yeah. Like it doesn't. Yeah, okay, because sometimes it's the same.
Always.
Yeah.
If there's only one option, it's not gonna find a better one than the one option. Net.
Yeah. Okay. Can be used in both heuristic and cost-based optimization.
I have no idea what algebraic query optimization is, so it's probably true.
Yes.
Yeah, it sounds based.
That is seriously how I will test. Oh, sounds based.
Data filled.
Set minus is not commutative and associative. Joins and Cartesian products are Joins can be represented by well, they're less.
No, the last one.
The effect is true, but like it's less efficient. An outer joint can be represented by a Cartesian product and a projection, and vice versa.
Yeah.
No.
No.
A Cartesian product is an inner joint.
That does no. A Cartesian product is a very large outer join, isn't it? Or is it only? Yeah, but like when you do an outer a join is all values that exist. Oh
no, a Cartesian product doesn't care about any of the fucking values, and the outer join.
You're right.
Yeah, so an outer join will leave some null somewhere. A Cartesian product cannot leave null somewhere. That's the answer.
Oh, yeah, I forgot about that part.
Okay, that's literally the definition of outer joints versus inner joints and left joints and right joints. Okay, which of the following statements are true?
Always no.
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 Pushing selections.
Yes.
Pushing selections down. Yes.
Yeah.
I would say yeah.
Can have a negative if the selection can be implemented by an index scan.
What? No.
No. A select can have an negative impact on the selection criterion is very expensive. Yeah, that it makes sense because when you're more at the top, you have less tuples. So if it's a very, very expensive thing, then it might be true.
Yeah, sure. And pushing selection has a negative impact. It does say like one of the steps of the thing is push things as much as possible. So the third one sounds kind of scuffed.
Yeah.
Where
there are cases. Where you don't have
okay, real quick. Here it says is. So
That's but
Yeah,
that
but
is following statements. But
yeah,
that
okay,
is
but
following
sometimes like
statements.
yeah, like there is a way
We
to
just
make it
keep
only
it this way.
whatever.
But
I'll
it
keep
still
this way.
says
Yeah. We
statements.
just
It
keep
says
it
it's
this way.
multiple.
This is our answer, and if our
Yeah.
answer is wrong, then so it be.
It literally says statements is true.
Wait, statements is did they?
Yeah.
Punk ass fuckers.
No, which of the following statements is true?
Oh,
yeah,
which of the
because,
following? Okay, yeah, never mind. I take it back.
statements is true, but that means that there can only be one true statement.
Yeah, but
Whatever, we don't care.
they can suck
Statement
it.
is
So
true.
Whatever.
We gave
Whatever.
our answer. We keep it.
The is cannot be written there. That's just a
This is not
grammar
English
error.
class. Let's focus.
whatever.
No, but the grammar implies that there's only one correct
If
result.
this was a
one
test,
correct
we would
answer.
care. This is not.
Okay, which of the following
Yeah.
statements are true? It is nearly always beneficial to replace a Cartesian product and selection involving attributes to show relation with a natural join. Yes.
Can you use a natural join if they have different names?
Yeah. You just say natural join with this.
Is it then still a natural join?
You
Yes.
rename them.
Yes, because like that like weird squiggly like infinity sign is called a natural join. You could say natural join where blah blah.
Okay, I thought it was only called a natural join if it went by name, if it guessed the name.
Bug. Sort elimination describes a technique to eliminate duplicates by exploiting sort algorithms.
What?
What?
I've never heard of this, but it seems to make sense.
Never heard of. Sure.
Exploiting? I want to say
Yeah, no,
exploiting is a term they use often. It's fine.
Yeah.
Okay.
Dynamic filters introduce new selections that are join-based filters.
I
In
have
order
no
to...
clue what a dynamic filter is.
They love exploitation of any kind. Exploiting.
Yeah,
speed,
sounds good. Sounds
exploiting
good.
data.
Sounds good. No idea. Next.
Which of the following equivalents are true? Select star from relation 1 as R1, relation 2 as R2, where R1 is R1. Select 1 on... Yeah, this is true.
Is this true?
Yeah, this is just an inner join, and this is an inner join.
Yeah.
Select star from R1 where not exists. Select star from R2 where R1 or R2. Select star from R1, right join R2 where R2.a is null.
No.
No.
No?
No.
That doesn't have
No,
to be
because
true.
R2.a will never be null. Only this thing. Huh. Wait, no.
Because it's right join R2. So this would just get R1. The second one, I haven't looked at the first one. The second one will just give you every value in R1 with every value on R2 plastered on top of it. So I think the second one is just an inner join.
No, actually, I think. Yeah, okay. It says right join. It doesn't say on.
It says right join where R2.a is null. So it's just an inner join.
But
No, because it doesn't say R1.a is R2.a. So this is like a Cartesian product.
Yeah, but it has nothing to do with.
Oh yeah, this is fucking SQL, not relational algebra.
But it is. It doesn't check if R1A is not equal to R2A. It just checks where R2A is null.
And it also does like there could be values in R2 where R2.a is null automatically.
Yeah, this one doesn't make much sense. I'm just gonna say it's no.
Sure.
Select star from R1 where R and A is X. Union select R from R2 where R2.a is Y.
This is true.
Select
right?
star from.
This is true.
Yep.
Wait. Select star from R1, R2.
Yeah, this is a Cartesian product.
It's a union.
Yeah, so
It's union. It should be.
Yeah, but no. Okay.
No,
So
it's
what?
to say union is an or.
Pineapple.
The union is an or, and the other thing is and.
Yeah,
What this does is it takes the list of tuples from here and it adds the list of tuples from here. What this does is it will cross product both of them.
yeah, so
this
the
is
list,
not true.
the amount of attributes is different, which means they can't be the same.
Yeah. Select star from R1 where this intersects star from R1. So these are the same ones. Here they're different. Here they're the same. Where this is true. Okay.
Yeah.
Select star from where R is X. This is true.
That's just the definition.
Yeah.
of-
Wait, I still don't get the third option. Why is it wrong though? I don't get it.
So, okay, what this does is this grabs. Hell, this might not even compile. Yeah, no, it genuinely might not be. So what this does is this makes. Let me actually draw it out. So imagine the first. Oh shit, where is it? This one.
You should close some tabs.
Yeah, I probably could. So the left one, this one,
No, I
gives,
just
for
saw it
example,
and
this
then
gives the
select
list 1, 2, 3, like the tuple 1, 2, 3, the tuple 3, 4, 5, 6.
Yep.
Union, the tuple list containing tuple 2, 3, 4, 5, 6, 7, 8.
Yep.
And what this will do is it will make a list. Oh. With just the tuples of the two combined. So it will just do this. And the fun fact is if these two, like, because it selects star, if these two have a different number of attributes, it will not compile.
It will never compile to begin with if the attributes aren't exactly the same.
No, that's not true.
Okay.
The attributes can be different. They just...
What name would it display at the top?
There is no name displayed at the top inherently. Like, that's just something
in
like...
SQL there is.
No, I don't...
In SQL, actually, each attribute has a name, and now the names are different. This can't be displayed. What it might,
true,
what it might do, what it very much might do, is make like a table, like a fucking double-sided outer join type shit. But that's gonna be scuffed as fuck.
Yeah, no, but like in SQ in my thing, I have previously done like select I don't know, link, comma, image from images where image
Yeah,
is
whatever.
null, union select user password from users.
Yeah, but what this will do is give you a double-sided outer join probably.
I have no clue what that means, but it will give me like a link, an image.
A full outer join.
A full outer join, yes. So, like, say Jurre, your in your first example,
yep,
it won't return, or it will be 1, 2, 3, 0, 0, 0, 4, 5, 6, 0, 0, 0, and
No.
0, 0, 0, 2, 3, 4, 0, 0, 0, 6, 7, 8, because they're different attributes. So it's just gonna fill them in. It's a
No.
double-sided outer join, I think.
No, I don't think so.
I'm gonna Google it.
Okay, Google it,
I don't
please.
think so either. Just run it against the database and see what happens.
Unions on different columns. Union on different columns. You can't and shouldn't return them in the same position. Yeah, you want you can fill in the blanks by adding null to the name with fields like this. So yeah, it does a outer join
with null values.
Yeah,
which is amazing.
Amazing.
To implement a set union, your data sets must be union compatible, which means they need to have the same data types and the same number of columns in the same order.
Yeah, but then they don't have to have the same name.
Yeah, I guess, but they need to like very much be the same or be the same.
Yeah, but I don't care about that too much. I just say that they don't have to have the same name.
I guess not. Thank you, Jacob Case, database engineer.
Okay. I was busy programming an example, but honestly, I CBA. Which of the following statements are true? Concentrating on deep left trees is a good general heuristic for join order optimization.
Sure.
Yeah, sure. Like otherwise, if it was dumb, they wouldn't have taught us. Finding the optimal join order is an NP hard problem, i.e., really hard. Yep.
I don't really give a shit.
The size of tuples in a join order for R join S can be approximated by this thing, depending if there's a join condition. But just R join S, yes. The reduction factor.
Well, is it
not approximated? It's exactly.
Yeah, it's exactly.
I'll say false. The reduction factor of a join condition can be approximated by using a simple statistic based on the number of unique values.
All of the calculations we do are technically approximations because we can't be 100% sure.
So, Jurre, I would say it's true because approximating something that is equal is true. 1 + 1 is approximately 2, Jurre.
That's true. I saw this meme a while back where it says equal sign is approximately.
That's like if it was cross product, right? Joining usually just filters out stuff.
Well, but then you would give it a join operation. R join S is a cross product.
Is it?
It's true.
R join S on yada yada yada.
Yeah.
Is
So
not.
we have R join S is
it
equal
depends
to
on
from R, S.
Like it depends on what they mean with R join S. If they mean R join S on A, then it is not R comma S, it's R comma S. Or R comma S divided by the blocking factor. Then you get a problem.
A equals B.
Yeah,
Although you
yeah.
have to do R point A and S point B.
It
but
depends. It's nice, but it's not required if there are no ambiguous
They
names.
go to the same name, yeah.
Yes, but it's nice to
Okay.
read.
Yeah, true. Okay, find the optimal join under dynamic programming, join order optimization. Find the optimal join order. No.
No.
Or
not optimal.
under the current cost model. Not
might
really.
find
No.
more-
It won't find the optimal. It will just find a good one.
And
It's only
more
suitable for
optimal.
joint with a limited number of joint partner due to its high cost complexity.
Wasn't I don't think I think this was made in a way that it would work decently for things with a bajillion joints.
All right.
Like it was made for a way that it could run on like you would never program something for something that could work on two things or on only two joints because things like Amazon are going to have 5 billion joints. So I just out of my way of thinking, I think this shouldn't be correct. Not because I know it's wrong.
I know they talked at a certain point that one of the two things, so dynamic and the or the other one, was like really good for small ones and then really really stupid for big ones. But I think this one worked well for big ones.
Not sure.
We'll have a look. Or actually, if nobody knows it here, we'll have a look afterwards.
Yeah.
Greedy algorithm for join order optimization. They are in every way inferior to dynamic programming.
In every way,
algorithm.
next.
No.
No.
In every way is never.
Yeah, no, they might be slightly annoying to implement, so they're not better.
Yeah, gotcha. Right there.
Gotcha, sucker. Dynamic programming join order optimization can be used for deep left trees and also an arbitrary join tree shape with increased
Must
cost.
be true because the rest is false.
Yep, based. The block access code costs for blocknet loop join can be given by because there's no join condition.
Wasn't it blocks in R plus?
Oh wait, yeah, B and L is so it's this thing and then this thing falls away. So
It's blocks R plus blocks. So it's
so
still
it's
plus R.
this times opening bracket this plus 1, and it could be approximated because plus 1 is relatively small.
It says can be given by, and it's not approximated.
Exactly. The block access costs for the index nested loop joints are always lower than the block. Nope.
Always no.
Okay, and I was looking at the slides before about the greedy joints and the dynamic joints, and it seems like the dynamic joints have pretty high complexity, and for larger, they are too expensive.
Okay.
Cool. Thank you.
Imagine being a twin.
We have to consider the fourth one now because the rest has a true option.
Ooh. Can we use dynamic programming join order optimization can be used for deep left trees and also arbitrary join trees?
I
think
it could
so.
be.
Yep.
Yeah.
Okay, so this is false. Block order the block access costs for index nested loop joints are always lower. The block access costs.
The block access costs.
Always.
Yeah, no, I don't.
No.
Okay, guys, hear me out, What if we don't have an index? Okay, index retrieval. Index retrieval costs for index nested loop joints are lower for primary dense indexes than for secondary indexes because the result tuples marching an equality condition are usually found in the adjacent block. Yeah.
Sounds a-okay. Next.
Yeah, no, it makes sense because like
it's a lot of text which sounds very thought out.
It sounds like there's a possibility of it being correct.
No, it makes sense, right? Because the primary indexes are sorted on their primary indexes.
I think that's approximately correct.
Should be roughly
very
correct.
Low block access cost when all relations are properly pre-sorted. Let's have a look.
Yes.
About not wrong.
That was the entire
Where
thing
is
of
it?
merge shorts. I believe.
And time.
And 30, Jesus
36,
Christ.
90.
That was an increase from the last few.
A little bit, yeah.
I mean,
10.
it was
10.
summary as
Oh.
Oh.
So quick sort
So
is a
merge
shit
sort-
operation, and merge sort is a good operation. Wait,
Maybe because quicksort is not in order, not in place.
what do these things mean?
This means you got it wrong.
The
what you
blue
chose.
the blue arrow points to which are the correct answers, and the
Yeah.
cross means what you did correct and what you did incorrect.
Oh, okay, yeah. So this one is correct. Wait, this is false during query execution. Okay.
Yeah, we
Yeah,
marked
no,
it as
no, it's
false.
not because sorting you need access all. Most
Oh
of the
wait,
time
it's already
usually-
off. Yeah, okay. Okay,
Yeah.
sorting earlier.
Check mark is you did it right. Cross is you did it wrong.
Yeah, okay. So this
Arrows
is the only
are
one.
correct.
So these two are swapped around. So merge sort is good because it can be performed well with limited memory. Okay, to be fair, that actually makes a lot of sense if you think about databases with like a billion fucking things. You'd have to load them into memory the entire time with quicksort, which is really bad.
Yeah.
Also,
Okay,
yeah.
fair. Okay, this one.
I mean, it would still depend on your fucking heuristic for what you count good. But okay, whatever.
I love how the previous one went so well. Index are very efficient in the reduction factor of the join consistor is very low. So that is index nested loop joins. That's these. Then the reduction factor is very low. Therefore,
Oh, I guess because then that means that there's okay. So yeah, so you take a tuple, you look what it's in there, and you only have to match it with a small amount of other tuples, and then you go to the next one. You only have to match that one with a small amount of other tuples. So I guess it means that the output set is smaller, which means that it's faster.
cool. All right. This one is true. This one is true. This one is true. This one is false. So, pushing selections can have a negative impact. Oh, so this is.
We marked that, didn't we? Oh.
I thought we marked that.
Oh, I thought.
Okay, well, okay, whatever. We got points for that. We're just done. Next.
Okay, this one. Third elimination craft technique. Yeah, okay, we didn't know what third elimination was.
Yeah, they just didn't teach us that. Fuck off. Next.
Did they not?
I think they did. Wait, let me search.
You, the person who was just talking, have a look if we ever discussed this.
Sort elimin.
Huh? We actually got like
Oh, it's actually not in a slide. Never mind.
Exactly. So we've got this is plus 20% or plus 20 points because one of them we never knew, and one of them we clicked wrong.
Yeah.
Next to that, they don't give
So that's
points.
still a 70% for the recap of the entire fucking thing.
Yeah, but
with
they
like
also don't give
3
partial
people
points.
working.
You
So
either
you know.
gain 0 out of 10 or you gain 10 out of 10, which is why do you have 10 points then?
And this one is fucking wrong. They say the size of tuple, the size of tuples of a join result can be approximated. This is true because there's no fucking join condition.
Again,
that or
it
they.
depends on how you note it. So
Like-
Wasn't it like a natural join if there was?
I thought all the formulas for like cost and stuff were approximations because you can't be precisely
No, yeah, that's true.
exact with
But, like,
everything.
they're-
Yeah,
they're
so
like-
it is an approximation.
it is approximated. This is true if there is no join condition. If there is a join condition, it isn't. So it can't be approximated.
And
because
even
it
then, like
depends on the
they
join
might
condition.
either focus on the fact that they implicitly imply the join condition, or by the fact that it's exactly not approximated. But even then, 1 plus 1 is approximately 2.
Like,
and
still good enough.
It finds the optimal join. Oh wait, because like okay.
Yeah, it was very difficult, but in the end, it would like. Yeah, that's the one. That's the one where they did the example, and it was very, 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 very long. Like,
Yeah.
where we went through all the things, and you take like the perfect join order for 3 things and the perfect join order for 4
Yeah,
things.
yeah,
and
okay,
you spent,
that's
like
fair.
half an hour on it. So that's that one. Cool.
I mean, it will find it. I don't know if it's really efficient to just look for the optimal.
Only with a low amount
6
of
years,
things.
After 6 years, you finally found the optimal join order.
Well, you should only use it if you have fewer than like 7 or 6 things to join on.
Otherwise, you have like 17,000 options.
Yeah,
or
it's
more.
2 to the x. It goes up with 2 to the x, which is why it's a problem.
Okay. Either way,
99 options are
let me
the join
calculate
one.
the total time real quick. So
This is supposed to take
Around
8 hours.
1
by the
hour,
way.
I would say. When half.
So it's
This would take
36,
about
19.
8 hours, by the way.
Yeah, we literally. Why? But why do I think this would take 2 hours when you do the
It's
low?
probably just like they have to give a time limit on it. So they just gave it 2
So-
hours, so it gives enough time to
2
finish them.
hours is so long,
It's like we took approximately like 1 hour and 20 minutes.
and we were discussing a lot.
Yeah, there was a
And
lot
we
of
went-
discussion here.
Yeah.
So, like, alone you would do this way faster.
Yeah, but you also have
Maybe
more
not,
wrong.
but then you may make a lot more mistakes. So in the meantime,
Yeah.
Yeah, you make more mistakes, but
I mean,
still.
do you guys also want to do the online exams, the one?
No,
Those
we still
online,
have to
maybe?
work. If you guys want, you can stay in the channel and do it after I'm gone, but I'm done for now.
Yeah, we still need to work 3.5 hours plus 2 more hours today, so 5.5 hours. So, how late is 5.5 hours from now?
Like, let's see, that means it is.
That's 11.
11. Gezellig, and also an hour of eating. See you at 12, Jure?
Yes, gezellig. And then tomorrow a thing.
We're not doing 5.5 hours, Jure. I just want to get
No, I figured. Alright, so in that case, gonna close my YouTube real quick. Thank you everybody for joining. Hope you have a good one. Good luck in your exam. If this even gets live before the fucking thing, because it still has a process. And have a good one.